everyone, and welcome to this session on Kubernetes full course. If you follow technology news, it might seem like Kubernetes is everywhere. It has become hugely popular. In fact, developers and DevOps teams might feel like their application development pipeline is hopelessly outdated if they are not using Kubernetes. Kubernetes is an orchestration tool for containerized applications. Starting with a collection of Docker containers, Kubernetes can control resource allocation and traffic management for cloud applications and microservices. In this session, you will learn all about Kubernetes from scratch. So let's go ahead and check the agenda for this session. Firstly, we have the Docker essentials. Moving forward, we will see why Kubernetes evolved. After which, we will see the features of containers. After which, introduction to Kubernetes. Moving forward, we have Kubernetes Architecture and Kubernetes Deployment. After which, we have rolling updates with deployments. Moving forward, we have monitoring in Kubernetes. After which, we will see Kubernetes Objects. And then, we have Kubectl Commands. After which, we will see what is Google Kubernetes Engine, that is GKE. And lastly, we have interview questions and answers so that you ace your interviews. So that's all for the agenda. Now let's start the session.
Before we start the session, kindly subscribe and hit the bell icon for more updates.
When you start talking about Docker, right? The Docker, what is Docker or what is this container runtime, right? In the high level, even the container runtime, right? So they help you create a container for you, okay? The container is an isolated process on your operating system with its own complete resources, which is namespaces and C groups. So it means that, see, let's take a simple example here. So you have a Windows laptop, right? And you are installing a lot of tools on it. Like you installed a game, you're using Google Chrome browser, and you're also, for example, writing some Word document. These three things you're doing. And once you start playing game, right, or you load a game, all the other things will not respond fastly because this game is actually slowing down your system completely, and we don't manage it properly. The whole system goes down, right? It means that the processes can affect the other processes on your operating system. One main large process. That is the main reason why companies will never run multiple applications on the same server. No matter what happens, right? In every company, even a startup, right? What they do, they run the application server separately. They run the web server separately. They run the database separately, right? You never run all these three on the same server, right? We never do that mistake because each application when they are running, they may tend to disturb or go and what you call interfere with the other application runtime. That is why in the IT industry, what we do is we always ensure separately these three servers. Even though this server has a lot of free resources, we will not do the mistake of installing web server or app server on the database or vice versa, right? Now the same thing, now what you do is for multiple environments, right? In every enterprise, you don't have only one copy of servers, right? We have multiple copies of your application running, which is nothing but an environment. So we will ensure that we'll have multiple environments. Now, each environment will have all the servers included, right? And we have been doing that the same thing for a long time. The Docker, when you start using Docker, right, the obvious benefit right away you get is you get freedom from your operating system. How do you get freedom? Because you are no longer tied to that operating system. You have a Docker image, you download the Docker image through a Docker image pull, then you will create a container and it will be up and running within no time. And you do not need to do any additional activity to bring up that application. You don't need to install a software, you don't need to copy something, you don't need to change anything, right? It means that you've got freedom from your operating system, and you can take the Docker image to one more server and do the same thing without needing any other change. What you just need is a Docker installed on that server, that's all. So the container fundamentally is an isolated process on an operating system which cannot be discovered or which cannot be what you call connected by the other normal processes on the operating system. Okay. And this Docker fundamentally changed everything, because earlier, right, when you want to run application, what you did, you first created a Linux server, then installed Java there, then you download your Java code and then you run it. And if you want to move the Java application to other server, same thing again, you again install Java there, again deploy your Java code or any other config files, everything, right? So story starts always from the starting. And you all know that you can't simply copy paste something on a server to server, right? It's not possible. You installed Oracle database on one server, you can't simply copy the installed files and put it on some server and expect it to work. That doesn't work, right? Even a small software like putty software you install on your laptop, you can't copy and paste program files from one laptop to other laptop and expect it to work. And also, you know that when you go to a downloads page, Windows 7 installation file will be separate, Windows 10 installation file will be separate, or in Red Hat 7 version will be separate, Red Hat 6 version will be separate, or Ubuntu version will be separate. So within the operating system, within the same operating system type only, there will be different installation files. That is why from a very long period of time we were highly dependent on the operating system. Everything was tied to the operating system, but Docker completely changed it. Now once you create a Docker image, you can take the Docker image and run the Docker image on any Linux operating system, it doesn't matter. And that Linux and that Docker image can be of any base image. Okay. So this Docker is good, but if Docker is giving a lot of things, why Docker is not useful for running containers in high availability mode? That is where the problem will come. Docker lacks a lot of essential features for you to run application in a HA mode or in a high availability mode. Docker is mostly confined to running single container only. Beyond single container, Docker is not much useful, and there is nothing much what you call additional features, or what you call, which is going to help you run containers reliably. See, reliability is important. Just because there is some feature, if you start using it, if it is not reliable, you know what is the consequences, right? So Docker is not reliable for running containers at scale, and Docker lacks a lot of essential security, networking, storage features, which essentially makes it useless for running containers at the scale. That is why the Kubernetes is there. But a lot of people think that Kubernetes came after Docker. But when Docker came in 2013, right? Google in 2014, Google told, we are using some software from the last 10 years inside our company without telling anyone. So Google was using containers a decade before we all know what is container. And they were having an advanced software to manage those crores of containers. Let me tell you, Google has more than 7 billion containers running. Okay, it's not 100,000 million, it is billions. So there are more than 7 billion containers running inside Google data centers, which is being managed by something called as Borg. Okay, it is called Borg. And then why we don't have the Borg, right, if Google is using Borg? Because Google don't want to give completely all their advantages. So Google told, we will create an open source edition of that Borg tool. Okay, it took some features of it and made Kubernetes, and then released in 2014 and open sourced it in 2015. First they did not, first they told, there is like, see, if you know, right, Microsoft Windows 10 is there. Windows 10 is not open source, right? But you can still use it. So they released in 2014 to use, but 2015 they open sourced it. Now it means that Kubernetes from day one has the capability to fulfill any complex workload, right? See, our company is not even 1% of Google. Our companies will be 0.001% of what Google is, because all companies are so tiny companies, right? Even Microsoft is a tiny company in front of Google, right? So a lot of people don't know that. So if some software is good for Google, it is more than good for you guys, right? That's what it is. So if some software Google is using it and they are satisfied with the tool, we should be more than satisfied, we should be like very happy for that. So that is why Kubernetes has all the features you need to run applications or containers in an enterprise at scale. Okay, And when you talk about this container, right, this isolated process on operating system, if you still want to little bit understand, see, there are 10 people on a football ground, they're all playing together, okay, right? Now everyone wants to set up their own setup, like everyone wants their own pitch, or they want to right, someone wants a grass based ground, someone wants a mud ground, right? Someone, everyone wants to have little bit of their own customized ground, but you only have one ground, you can't customize it for 10 people. And if you try to customize, what happens, everyone will run into other person customized pitch, right, their ground. So then how can you ensure 10 people with their own little bit customization can continuously practice on that ground without running into each other, without fighting each other, or without disturbing others, right? A simple example is, you have shipping containers, right? You have ship, on the ship you see the rectangular boxes, right? If I simply put a rectangle box on top of that place and ask person to customize the ground for him, now what happens, that person will practice inside the rectangle box, right? And this rectangle box, this person can take anywhere with him. He'll go to one more ground, he can take it with him. He'll go to one more ground, he'll take it with him. That box he'll take carry with him, and that box inside has all the customizations he needs. So that is what a container is. Once you create, that is your Docker image, okay? So now multiple people can share same ground, 10 people, but still they will not be disturbed because you have a boundary, a thin wall around with you. That is what a container is. A container is a completely isolated process on an operating system, okay, with its own resources. That's a fundamental difference, and this process cannot be disturbed by others, okay, which is nothing but a isolated process. Now when we start talking about Kubernetes, right, the Kubernetes is built for containers. So you can't take normal Java application and try to run in Kubernetes, that won't work. Kubernetes only runs containers. So for a container you need an image. So before you start using Kubernetes, that is why you should have your base knowledge of Docker and base container image, so that you'll bring that and you'll start using it. And to understand this Kubernetes, what it is capable of, right, what it can actually do, let's try to see. Now when you talk about virtualization, right, a virtual machine is a dedicated operating system, right, a dedicated virtual operating system on top of physical hardware. And the virtual machine, you know, it takes up a lot of memory, CPU, a lot of storage, and it is a thick system. Means for running one application, if you are creating a virtual machine, you know the cost of it, right? Maintaining that virtual machine, upgrading, maintaining it, patching it, rebooting, if that server goes down, you need to do so. For just one application to isolate a run, today companies are creating virtual machines, a very large concept, which is thick concept, which is unnecessary to maintain. Once you containerize your applications, and once an application containerized cannot be disturbed by any other person, the need of a virtual machine is completely eliminated. You don't need that complicated headache to maintain for what, for isolating your application. So the main question, the main need is that you don't need a virtual machine. What you want to achieve is a, to what, to isolate your application. So when you have a chance to isolate your applications without the need of that all complexity, that is why the Kubernetes is popular, because the containers will give you a way to isolate your applications by running on the same server without maintaining hundreds of unnecessary servers, okay? So when you create a container, it has its own file system. We can dedicatedly provide the CPU and memory to it, and they are completely decoupled from your underlying operating system. They are highly portable in nature. You can carry your Docker image wherever you go and expect it to run exactly the same, whether it is a CentOS or Red Hat or Oracle Linux or what you call SUSE Linux or Amazon Linux. There are so many variants of Linux, it will run exactly same. But that's not the case. It just 5 years back, just 5 years back, you used to have a separate installer file dedicated to one specific Linux operating system, Linux what you call operating system type. But now that's not the case. So your, once you containerize it, they will become highly portable, and also to migrate from on premises to cloud will also be a seamless activity. if you're already having a containerized application on your on-premises, for you to migrate to cloud will only take you a couple of weeks. You don't need elaborate planning. Today, companies who want to migrate from on-premises to cloud with a virtual machine based architecture is going to be very, very highly complicated and time taking process. But if you're migrating from an on premises, or not only on premises, but for example you're on AWS cloud, you want to move to Azure cloud because there is some special advantage for you there, that will be very, very highly seamless for you there, because there is nothing you do. You just take the Docker image with you, go there, deploy it and start running. The only things you should be concerned about is little bit of networking and security. Apart from that, runtime perspective, you don't do anything. Okay, so that is why the containers are popular, because they give you a way to completely unisolate and give you a way to easily take that along with you to any number of servers and run as expected. Okay, and when you talk about containers, they are loosely coupled, and they give you what, cloud and OS distribution portability. That's what it is. It doesn't matter whether you're on premises or bare metal or cloud, the container or the image format exactly looks the same. And the dev and ops separation of concerns is gone. A lot of times, right, developers will complain this is working on dev environment, it is working on SIT environment, right? That's not going to be the case. What Once it works in one place, it will flawlessly work everywhere. Because earlier, right, when you installed some application or when you install Java, there may be some special file missing, or you are deploying the code manually, there may be some files you have missed to copy, or there is some OS specific thing which is not updated in the other server. But that's not the case now. Once you create a image like Docker image, you copy and paste the Docker image on all the servers in the exactly same way, so you're not going to lose anything. And again, you don't have dependency with the underlying operating system. So the, you will completely eliminate the concerns of developers complaining working on server 1, not working on server 2, or working on dev environment, not working on what you call integration environment, is completely gone, so that you'll have a lot of efficiency in your operations also. Okay, and they are highly resource efficient, means the containers take very less amount of resources when compared to virtual machines, so you'll have a lot of efficient resource utilization of your company servers. Okay, and also the main use case of all this story is your microservice architecture, right? That's not something we are going to be forgetting. Today the world is moving from a SOA architecture to a microservice architecture. So this architecture is from the application perspective. Okay, SOA is nothing but service oriented architecture. So the way we design our applications, the way they should communicate with each other, the way you should talk to each other, all those things, right? That is application architecture. The service oriented architecture, or simply called SOA architecture, came in around 2005 2007, and it was till 2016. So around a decade the companies all used, and today still most of the companies are still following that practice only. But around 2015-16 the microservice architecture came in, like 2015 I think, yeah, where you have a highly loosely coupled application which are having very tiny footprint, and which are only doing one specific activity efficiently. Earlier, right, Java applications, right, they used to have a lot of functionalities inside one application, and like that used to have some applications. Now today, instead of having some application with lot of functionalities, you'll have lot of application with a one specific functionality. So you have one customer care application, right? Every company has customer care application, right, where customer care portal team will have access to it. We will not have access, our the normal people, but customer care team, they will access. When you give them some ticket ID or your mobile number, they will type in and they'll retrieve all your details, they'll open a ticket. So that's a customer care portal, right? So that application used to be one application earlier. Now what companies are doing, they're breaking it into 10 12 small parts and maintaining them independently as a small application. That is your microservices. Okay, so for running microservices, the containers are the most efficient solution. If you do not use containers to maintain microservice architecture, you are going to have an impossible task with you which you cannot manage. So that is why also containers became very, very popular because they help you properly manage applications in a microservices architecture. In a microservice architecture, you will have 50, 100, 200 applications, microservice applications. Earlier, those used to be 10, 20, 30 only maximum. But now people are breaking that 1 into 10. So they are becoming 200. So managing 200 applications without container concept is impossible. That is why we also have very much high emphasis on containers, because every company is moving into a microservices based application architecture development. Okay, so that's also one of the important reason why we use this. Okay, the containers and the orchestration. So it's the same, like you have increased efficiency of container image creation compared to VM images. So it is easy to create a container images like the Docker, right? The Docker images, it is very easy to create, easy to manage, easy to store, easy to propagate, easy to copy from one server to other server, all the things. And the dev and ops concerns, which I've told you, it completely eliminates that. And portability, it doesn't matter. As I told, once you create a Docker image or container image, it is highly portable in nature and highly resource efficient. Okay, it only takes what it needs from the operating system, but it is not going to completely need operating system. You can share that container with other containers and expecting that those containers do not communicate with each other, do not fight each other for anything, and they do not interfere with the runtime of other containers. That's the main goal. Okay, as I was telling, the containers are a way to efficiently bundle your applications into images. But as I was telling, in a production environment scenario, you need to ensure that you are running these containers at scale. That's an important thing. So running at scale is ensuring that you are going to install and configure them and run them. Now the Kubernetes provides you an efficient way to manage this what you call containers, and it takes care of your scaling, it takes care of your failover, it takes care of everything. The first thing is Kubernetes is an open source container orchestration platform. It was developed by Google completely and Google open sourced it. Today, Google doesn't own it. Today, it's owned by CNCF. Apache Foundation is there, right? Like Apache Foundation is an open source foundation, like a small, you can think like Red Cross Foundation, right? Like foundation it is. It is a non-profit organization, guys, okay? So today it is under CNCF. It is pronounced like this. Okay, this is a foundation. Foundation means non-profit company. They'll not gain anything. Okay, like Apache Foundation. Apache also doesn't gain anything. They completely open source everything freely. Okay, so and it was first released in 2015, as I told you, as an open source product. And the main features of Kubernetes is the pod. You need to understand the pod before we do anything in Kubernetes. The pod is the fundamental execution object in Kubernetes. Okay, so what is a pod then? We already know what is, we already told you that container is everything, but when you come to the concept of Kubernetes, we have the fundamental unit of execution is pod. Everything is run as pod in Kubernetes. Okay, and the management will little bit differ, but the pod is what everything is. Now this pods is nothing but a pod can have a container running. But you can ask me a question, why are you bringing one more pod here, runtime? We already have container. But the problem is, I told you that Kubernetes cannot create container by itself. It needs another tool to create the container and hand over to it. So when Docker is creating container, so you all, this is simple answer, right? If Docker is a tool creating container, only Docker can control it, because that software created that container. So how can Kubernetes control it? So what Kubernetes will do is Kubernetes will actually take the container and place it inside a wrapper, and that wrapper is called pod. So it's like you gift wrapping it. So you have a gift, you want to wrap it in a paper. Now you catch that gift with a paper, right? So this is the same thing. So when we are managing, we will never deal with the containers, because Kubernetes will go to Docker, get the container created, bring it and put it inside a pod and expose that as a pod to you. So for you, everything is a pod. So you never directly even use the term container when you are using Kubernetes, because the pod itself is a container. The only thing is that there is a management layer added on top of that container, so that Kubernetes can accept your instructions and perform those instructions on that pod, and that inside that pod container is there. Okay, and all the features of Kubernetes are applied on the pod. Once you apply them, they'll be provided to the container. Okay, so that's why the pod is a fundamental unit of execution in the Kubernetes. But what is a pod? A pod is one or many containers inside a management layer, and that simple small management layer is managed by your Kubernetes. So a pod can have multiple containers also. It is completely possible. So it can have more than one container also, but as a rule of thumb, we will always only put one container inside, because if there are two containers, if the pod is not running, it will be highly impossible for you to determine due to which it is coming, and it is completely against the rule of a microservice architecture. In a microservice architecture, only one process should be there who is doing one work, so that we can manage it uniquely. Otherwise, if you're putting two inside, now one of the Java code needs to change, other application will go down now, because when you're updating Java code. So that is why it is always important that in a microservice architecture, only one person one run will be executed within a runtime, whether it is a Java application or a .NET or what you call JavaScript, right? We'll run one application. One more application itself will create one more container and separately deploy it. But this is a pod. Replication controller is one of the biggest features of Kubernetes. It will replicate your application. So when you want an application highly available, right? You are having a 10,000 customers. Now all of them are hitting your website. So your website content is same, right? But since the website content is only one copy, you can't have only one application, right? Means only one instance of your application running. If all of the 10,000 people will hit that small application, that application will crash. Now what you will do to make your website highly available, to even sustain lot of traffic or lot of customers, is same code you will create multiple copies, and you will do load balancing on it. So when the customer is coming, it will be sent to one of the 20 or one of the 30 copies of your application, and that is called as your application, right? So it's the same code, same Java code or same HTML code or same JavaScript code, but the number of copies will be more, so that we will be having the way to manage the sessions in efficient way, so that one copy of your code only cannot handle all the traffic, so that we'll make 20 copies, 30 copies, 40 copies, or if for Google, millions of copies, right? Google.com will be hit by 250 crore people every day, right? At the minimum, 250 crore people will use Google.com. So for 250 crore people, Google knows how many to maintain, so they'll maintain that many number, so that Google.com is always responsive. Same way, we will also calculate how many we need and we'll make it. So normally, right, doing that is a lengthy process in company. You need to create a server, you need to copy the code, you need to install all the tools there. That's a headache thing. But when you go to replication, you don't need to do anything. You just need to tell Kubernetes make 20 copies into x into 20. It will make 20 copies within 2 seconds. What normally takes hours and days, right? It takes a couple of seconds only to replicate. Now you will have 20 copies of same code auto load balanced by the Kubernetes for you. And service discovery. The service discovery is nothing but a DNS service. So Kubernetes has its own DNS service, where it is actually going to help you discover the microservices or the contain pods within the Kubernetes cluster. So when one pod wants to talk to other pod is nothing but what? Inside pod is there container, inside container your code is there. So it is nothing but one container application wants to talk to another container application. So Kubernetes will give you service discovery. So people can discover each other. And who can do that normally? The DNS. So Kubernetes has its own service discovery mechanism built in. That's a very huge thing. Then networking. Kubernetes has its own highly networking layer. So means when you install Kubernetes, Kubernetes will create its own networking layer between the servers it is connected together. So it means that it is not easy to access anything running inside Kubernetes. It is impossible. And Kubernetes has an efficient way of managing secrets, efficient managing of configuration management. It can do rolling updates without zero downtime. It can efficiently do application health checks, resource management, resource monitoring. There are a lot of things Kubernetes can do, and you will never even scratch the surface of Kubernetes. So what does it all means is, you can run one application inside a company to run 24/7 with minimal human intervention, and also as an administrator you will not have lot of work to do, right? Because it will give all the features to you, so that it does not need any attention. Means once you do that, you deploy it, right, you can forget about it will stay alive. Okay, if one server goes down, two server goes down. And yes, I'll slowly tell you how does it possible. When you talk about Kubernetes architecture, the Kubernetes architecture is a client server architecture. Okay, so Kubernetes architecture is a client server architecture. Client server architecture means when you're installing Kubernetes, you will actually install the Kubernetes has a client and server. Means in Kubernetes there is what you call slave nodes, or you don't call slave, you call it as a worker node. Okay, so there is worker nodes and there is master node. So that is why it's called client server, because there are two kinds of it. So, and when you install Kubernetes master node, worker node, and when you join them together, then only it is called Kubernetes cluster. In a Kubernetes cluster, at the minimum, you should have one master node, one worker node, both of them connected together. Then only it is called cluster. If you just install Kubernetes master, it will not become cluster. It will only be master node. If you just create a worker node, it is worker node, it's not cluster. When you have a master node, worker node, they both join together, then only it is called Kubernetes cluster. Okay, so for a Kubernetes architecture, you will have master node and worker node. And in production scenario, you should have three master nodes for high availability Kubernetes cluster. For your cluster to be highly available, you should have three master nodes. Okay, so, and the master node is that the complete intelligence of Kubernetes, the whole intelligence, right? Kubernetes is very, very intelligent, guys. Okay, it's more intelligent for us. So all that intelligence is built into the Kubernetes, into the master node. Okay, so let's talk about master node. What are the components of master node? All those things. In the Kubernetes architecture, we have four master components. The first one is the API server. The API server, this is component, means small internally tools. Okay, like small software, small tools inside your Kubernetes master server. Means when you install master server component, these four components will come for you. And Docker will always be there. I told you, Docker will always be there. It is prerequisite for Kubernetes. So whether if you see the master or worker.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Docker always will be there. Okay, because without Docker, Kubernetes will not be alive. So Docker will always be there. API server is an entry point into the Kubernetes cluster. Okay, what is entry point? Means if you want to talk to Kubernetes, you only can talk through the API server. Only API server I can directly communicate. I can't communicate with any of the other components. So means, you know, right, when normally, right, whenever you're working, you'll have some git command, some CLI command, right? So Kubernetes also has a CLI command called kubectl, a small tool you will install. Using that tool, you will communicate with the API server component. So API server is a master component, and means you can't directly talk to etcd, you can't directly talk to scheduler, you can't directly talk to controller manager. Okay, you only can talk to API server. Okay, so the Kubernetes API server exposes the Kubernetes, and the Kubernetes API server expects a REST API call. So a REST API call is something I would expect you to go through and learn, guys. Okay, that's a fundamental. The whole world's run on API calls today. What is REST API? What is an API call? All those things, it is mandatory for you to know. Okay, as a DevOps engineer, right? Kubernetes is mandatory, but Kubernetes has a lot of these small moving parts which you should understand. Part of it, API server, API calls, what is REST API, API calls, all those things you should know. And I would very much ask you to go and learn. Okay, what is a REST API, REST API protocol, REST API call, right? That's a general thing to know, but it's important to know. So API call means you make it over a HTTP protocol. A REST API call is nothing but you make a connection, or you make Means the person who will tell I'm a REST API or you need to talk to me on REST API means you need to communicate on a HTTP protocol to that application. Okay. Now the API server also will communicate over a HTTPS protocol because it is talking on a HTTP protocol. That is why it's called REST API call. So we'll make a REST API call through the kubectl command. Now once the request comes in, so the API server is an entry point. It is also going to authenticate to you. Unauthenticated users will not be allowed to talk to Kubernetes. It will authenticate you. Okay. So yes, by default, whenever you're talking to Kubernetes, you should have all the authentication details with you. If you don't have the details, it will not even communicate with you. It is impossible to talk to Kubernetes. So that is important. So once it is going to validate whether the user is valid user or not, and it will allow you to come in and provide instruction. So what instruction you will give at the maximum Kubernetes? Why are we using Kubernetes? I'll tell, see Kubernetes, this is my sales application. I want you to run my sales application in high availability mode. That's all. That is what you end up doing. The Kubernetes helps you run your application, company application, sales application or finance application or mobile application, customer care application, right? Our developers will write that application, Java code or .NET code, whatever it is. A DevOps responsibility is to ensure that it is managed and run at scale efficiently, auto scaling, all these kind of things you need, right? All that features Kubernetes will give you. So the work what we expect from Kubernetes is we give the work to Kubernetes as a to run applications. So we submit that work to the API server. I'll tell API server, see, this is my sales application. I want to create 10 replicas. I want you to run. So that's your API server. Okay. Then the API server is only entry point communication, but one thing you should understand when you talk about Kubernetes is the declarative nature and also idempotence also more important and when you are talking about these kind of systems. Okay. Yeah, by default any containers inside a pod, yes, they can reach out to them. Yes, see, communicating is different than interfering with the runtime and grabbing its resources. Yes, a pod can reach out to another pod and it's only for communication. Means that too if other pod is allowing the communication. A pod, there are in a Kubernetes cluster there can be hundreds of pods running. So one pod can reach out to other pod easily, provided that we give the information, right? That information is service discovery. So I'll tell this guy is there, go and talk to them. Yes, it will talk, but that is possible and that is out of the box. It is open. There is nothing special conversation you should do. If you want to block, you should specially do anything, but out of the box, every pod to every pod communication is open. Even though one pod is on server, one other pod is on server 10 also, they can reach out without any problem. You don't need to specially enable anything. That is possible through service discovery. Service discovery is allowing you to discover seamlessly. There are there is a firewall where you can put Kubernetes kind of network firewall in between so that you can restrict traffic. For example, one of the applications should not talk to other application. You don't want to because they're not talking. So you can put a firewall kind of thing. But out of the box, everyone can reach out to everyone, everyone can talk to everyone. But talking to other pod doesn't mean that it is going and interfering with the runtime. That's a different thing. Okay. So this API server allows to talk and communicate. That's fine. But when you provide some work to Kubernetes, the Kubernetes has disaster management built in. What does this disaster management mean? Disaster management means, see, today, right, what happens is in all the way, when you install Java, then install Tomcat, then deploy your code, then like copy config files, deploy code and start application, right? When you do this, is there any reliability that the same thing will always be there? Can you give guarantee that, okay, once I do this, nothing can disturb it, right? No, someone simply goes and deletes one file in Java, that's it, the whole system will break. Or someone will delete a config file, that's it, gone. Someone will remove a small file in the code, it is gone. Someone deletes an important file in Tomcat, broken. Or simply someone can go and stop your Java application, right? There are so many ways for your application to not working or to go bad, right? And who will be responsible now? Someone should, again, from admin team should log into that server and check what happened, then he will take necessary action on doing it. Same thing for 100 of like 20 instances are there. 20 instances, anything can happen, right? But when you talk about Kubernetes, right, I tell, see, sales application is there. I want sales application into 20 replicas. Now, when I first time tell Kubernetes will right away create 20 replicas, means 20 copies of my sales application. But it's not guaranteed that, right? One of the server may go down. Someone will wantedly bring down two replicas. Anything can happen. That is, you can't expect. But that is where the intelligence of Kubernetes will come. Once you tell Kubernetes to maintain 20 replicas or 20 pods of your application, no matter what happens, Kubernetes will ensure those 20 replicas are always running. Means, for example, you are having, for example, 5 servers. On 5 servers, 4 replicas are running on each, right? 5 4 20. Now, due to some unfortunate situation, someone deleted one replica or two replicas. Now, what should happen? Are you going to set up some monitoring, alerting, all these things? No need, because Kubernetes will right away identify that two of the pods have been deleted, and the same microsecond itself, it will replace that with a new pod right away, so that you're not having the down, you don't have the resource efficiencies, or you don't have any down, this loss of your application. Or this is same server, means on same server, but what if someone deleted one of the server? Now these 4 replicas cannot recreate, because okay, you deleted something, I can recreate because I know that. But what if the whole server is gone? Now someone deleted a whole server. Now Kubernetes will shift these 4 pods or your replicas to the other 4 servers. You don't even need to tell it. So means, no matter what happens, you destroy your server, you shut down, you delete, Kubernetes will continuously ensure that there are 20 replicas are always maintained until one situation. There is no RAM and CPU. Yeah, there is no RAM and CPU in company servers. That's a different story. It is an issue from our side. But until unless there is enough capacity in your Kubernetes cluster, Kubernetes will continuously create what? Continuously create replacement pods or move the pod from one server to other server and ensure it is. That is why Kubernetes is popular. Okay, and that is why it also has self-healing. Self-healing means anything happen, it will heal the cluster, your not cluster, your group of pods. Like 20 means 20 will be there. If something happens, it will heal it. There is no self-healing ever in your general world. Okay, outside of Kubernetes you will not find it, right? Even some small application goes on itself, we need to go and start it. Forget about all this kind of advanced things, right? So all these kind of things will ensure that we as an admin team can be very, very happy. Once you completely move to Kubernetes, right, you will be very much free. You will not have much work. Okay, yes, you can trust me. Okay, once you containerize everything and once you run on Kubernetes, right, very hardly you'll have some issues, because anything happens, it is fixing then and there in the next second itself, not even minutes or hours. Okay, so but to do this, it should stores this somewhere, that I should always maintain 20 replicas. Is Kubernetes should remember, right? See, first time when you tell Kubernetes to create 20, it will create, but to maintain the desired state, Kubernetes should store this. Okay, Gopi asked me to ensure 20 replicas to be always there. That is your etcd. The etcd is a highly available distributed key value store, which is going to store the state of the Kubernetes. State means, okay, in my server, in my cluster, there are 4 servers, 4 worker nodes, 3 master nodes. Okay, this many applications are deployed. Each application, this configuration, this Docker image, all that configuration is stored in etcd. Etcd is a small database, which is a key value store, which stores the state of your Kubernetes cluster, so that if it is deviating, it will verify with this. Okay, current state is this, my desired state is etcd. Is desired state current state matching? If not, it will take necessary action to ensure that your current state is always matching your desired state. Okay, that is why it is desired state management. You don't need to do anything. Kubernetes will continuously check itself. Okay, Gopi asked me this, is it maintained or not? Okay, the etcd will store this state information, whatever the configuration which is supposed to be always properly running. Now scheduler is a very, very intelligent thing again. See, in a company, right, again I told you, in a traditional company, if you're all admins, right, I don't need to again go there, but if you're all admins, you all know that again I'll continuously tell that a, a dev Oracle DB server, what it will do? It will always run Oracle DB only. You can't simply run what you call Java here or Tomcat here or some website here, right? Why you can't simply run? Because you don't have anything installed on that. Again, you need to bring it, again, you need to install, again, configure. Again, you know the problem of conflict will come. So today, all our servers are pets. Okay, there is an analogy also. I want you to go and again learn yourself, which is pets versus cattle or cattle versus pet. Okay, the cattle versus pet is a very, very interesting thing. There are a lot of things you'll understand. Okay, this is not any technology, this is theory. Okay, so you should understand the meaning of cattle versus pet. It gives you a lot of knowledge. Okay, when you start reading these articles, right? What is pet, what is cattle, right? When in terms of modern infrastructure, servers means you're not going to learn about a pet and cattle like that. You will learn the analogy. Okay, it's very, very useful. Go and learn. Okay, but I'll tell you in a single line. So you have two pets, for example, two dogs only. Okay, you have two dogs, right? Maintaining dogs is a something specialized thing, right? You can't expect both the dogs to behave the same way, right? One dog will have a different mood, one dog will have different mode, one dog will tell I'll not do this, other dog will tell that, and you'll have some special attachment, or every dog will not behave the same way. Or not only dog, even you take a cat or you take any pet. Okay,
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
what happens is you do specialized care for each pet, right? You have a cat, you have a dog, or you have same two dogs, same breed, but you do specialized care, right? For a pet you always need a specialized care, but for cattle you don't need specialized care. If you have 10 sheep, you ask them to eat, they'll start eating. Or right, you can control cattle in a large numbers, right? One person will ensure that 100 goats are controlled, but one person cannot maintain 100 dogs, right? It's impossible. That he can't even maintain beyond number 2 or 3, because that is how it is, right? There is a specialized care needed for a pet when compared to cattle. Hundreds of cattle can be maintained by 2 3 people only, or one person only. That's the same analogy when it comes here, right now these are all pets. I need specialized care for this because this guy runs only on this. But when you go to Kubernetes, everything will become cattle. Cattle means for you everything is a server, that's all. There is nothing called application server, web server. There is no production server, non-production server. Everything is a server for you. Okay, if everything is a server, then how will you deploy? I already told you, when you are in the Docker image, everything you need is already with you, right? Now the last question comes is, who should run where? Who will decide, right? Someone should decide, right? Someone should actually decide where your application run, right? Today we are upfront deciding, okay, this is dev environment. In the dev environment, this is database server, this is web server. In production environment, this is database server. So today we are upfront deciding, okay, this 5 are for database, this 20 are for web server, this 100 are for app server, and inside app server this will run customer care application, this will run sales like that. You upfront decide everything. That is why I told you the panic situation, right? If one of the server goes down, that server will do that only, means that specific work. Otherwise the application will go down. In Kubernetes, for you everything is a server, that's all. One server, that's it. There is nothing called environment like dev server or application server, web server, backend server, front end server. Why? Because the Kubernetes has something called scheduler. Scheduler means, so normally, right, whatever we are doing, this guy does hundreds of times efficient. So when you are deploying one pod in Kubernetes, right, you don't need to decide on which server it should stay. You just decide whether it should be created or not. Once you ask Kubernetes to create, now in the Kubernetes, the scheduler person will be what you call consulted, and this guy will go to all the servers which are in your Kubernetes cluster connected, right? And it will go to each and every server. It will check the RAM and CPU how much available, and then it will see how much this person needs, and based on the container pod needs and the availability of RAM and CPU in all servers, it will only decide where the pod should be running. That is why this is cattle. So Kubernetes only will manage itself. Okay. Gopi is asking me, let me schedule on some server 05. You have 10 servers, server 1 to server 10, but it will decide on server 5. Now, once server 5 has some issue, again the scheduler will come into picture, and again he will decide that since that server 5 is due to like shutdown or crashed due to some xyz reason, he will now tell that pod to be scheduled onto server 06. So automatically that will be created on server 6 up and running, and the traffic also will be automatically managed by Kubernetes. You don't need to worry, okay, if I am moving one application from server 5 to server 6, do I need to make any changes? You will make zero changes. That is why Kubernetes is powerful. You don't need to worry, because all those kind of basic unnecessary silly things you can forget about. Okay, you can be relaxed. Normally that won't happen. If one of the server goes to a company, right, you will if you're already in infra management, right, you will know the headache. If one of the production server crashes, everyone will go into panic mode. But that doesn't matter. Even anything goes down, it's fine. So scheduler is that intelligent tool who only decides where it should create, but he will not create. Now controller manager will take the final decision whether it should be created or not. Scheduler will only decide, guys. It will only do the decision of where it should run. He'll not even tell to run or to create. Scheduler only does scheduling. Now controller manager is a person who actually controls whether it should be created or not. Like node controller, replication controller, endpoint controller. These controllers do the go ahead. Okay, yes, user has asked me, I have first stored in the database, then it is in the API server scheduler control manager. So control manager will go ahead. But where is your pod running here? In this architecture, where your pods are going to be scheduled is your worker node. Your worker node is where your application will be always running, which are your containerized application running inside pods, right? They'll run in worker nodes only. The master node will not run anything, because the master node is there for the intelligent decision management. So master node will not do any hard work, it will only do intelligent smart work. Okay, so the worker nodes is where your actual pods will be running, your application pods will be running. Your master node will not do that heavy lifting at all. It will do that intelligent decision management. The Kubernetes heart is here. Okay, everything, the whole brains of Kubernetes, but the working is here. Okay, on the worker nodes. Structure control manager and the worker components now. Okay, in the worker components there are only two components: kubelet, kubeproxy. The kubelet is the main hardworking person. Okay, he's a worker, he's like resource. All those people are managers. This is where you'll see the people who are working. The kubelet will get the work from the API server. Okay, I told you that API server, your person who is communicating, the kubelet will get the instruction from API server, what pod, how much thing, everything, and then it will create based on the specifications mentioned, and then it will reply back, okay, the work is done. And continuously also, if there is any state change, it will respond back. Okay, if pod is gone, this will tell pod is dead. The kubelet is a person who is responsible to actually create the pod for you and run. Okay, the kubeproxy is for the what you call if there are 100 pods running on a server, right, the request routing will be happening directly from the master to kubeproxy to the pod. Okay, so kubeproxy is kind of a router on a node level. Okay, which will help forward the request to the appropriate pods. Other than that, kubeproxy is nothing. Okay, kubeproxy is not doing any work. It's only about properly forwarding the connections. Okay. Now let's see the complete life cycle of an object creation. Okay. Let's see that it should be there somewhere. Yeah, this is an ideal diagram. Okay. Okay. You are a user. You only can talk to API server. You can't talk to etcd. You can't talk to scheduler. Okay. So first you tell create a pod. Okay. API server will respond back. I will create. Then the API server will take your requirement and store in etcd, and etcd will tell I created. Then right after that, the API server will tell scheduler, see there is one pod which is there. It is not scheduled. This guy will schedule and tell back, and then again where it is scheduled, it will be returned to database and come back. Then again it goes to the controller. The controller will tell the API server. API server will again tell to kubelet. Kubelet will go to docker. Docker will create a pod and it will create it. It will update the API server. Again API server will update that information in the database and close it. So this is the complete end-to-end interaction between all of the components: API servers, etcd, scheduler, kubelet, docker. These two are on the worker, these three are on the master. Okay. So this is a complete one. Step 1, step 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are total 16 steps. Okay. But you never will encounter all those things. But this is what happens when you create a pod internal in Kubernetes. This all things will happen. Okay. Clear? So when you install Kubernetes, the Kubernetes installation itself is one more Herculean, what you call a big thing. So when you install Kubernetes, there are two ways we can install. One is our own managed, what you call installing by ourselves. The other is a managed Kubernetes. Means someone is going to manage the Kubernetes behalf of you, or you only install and manage yourself. So for example, you're on your on-premises. Your company does not have cloud yet. You are maintaining your own data center. You have your own data center. That's your ownership. All the servers have there. That's on-prem data center. On-premises data center, you will install Docker yourself and manage everything. You are responsible completely. But when you go to cloud, again same thing. You can create EC2 instances, Linux instances, install Docker, install Kubernetes, maintain them. But that is not efficient, because installing managing Kubernetes is actually a little bit painful process, and it's a complicated process. So that's why the managed Kubernetes is an option today everyone is using. Okay. In a managed Kubernetes, you can automatically tell AWS to create a cluster for you and give it to you right away. It will create and give it to you. You don't need to go through all the hassle. Okay. So here what happens is you are going to create managed cluster. So in the cloud, because since we are, the whole world is moving to cloud, right? So talking about on-premises is not much of a useful thing now. So means when you are on the cloud, right, you creating a managed Kubernetes cluster is a better choice instead of you creating empty Linux instances and installing and downloading and managing. And there are some critical features also which will miss. What is managed cluster? If you all know what is RDS, I will assume that you all have little basic AWS knowledge, not only AWS, some cloud knowledge. So what is PaaS, guys, in the AWS? Not only AWS, what is PaaS? Platform as service, right? If you all know, but I'm not going to go into what is platform as service to tell now. But a platform as service is nothing but someone install, configures everything to you and gives you that as a platform to be used. So RDS is one of the most foundational example of PaaS, AWS RDS. Today, right, you don't need database administrators at all. The role of database administrator is completely dead now. Okay. Why? Because with a simple click, I will have a highly available, efficient database running on the cloud, and I will never need a database person, because RDS means managed database. You will go to AWS and tell, see, I need a HA, highly available Oracle database, install, configure, setup, permissions, backup, restore, everything, patching, all will be taken care by Amazon. You don't need to do anything. You just need to do some basic clicks or write a 10-line Terraform program. So in the same lines, AWS has something called EKS. EKS is called as a Elastic Kubernetes Service. Okay. Same way you will have two more things called as AKS and GKE. AKS is Azure Kubernetes Service. GKE is called Google Kubernetes Engine. These three are called as the managed Kubernetes clusters. What does it mean? Managed Kubernetes clusters means it is about what you call you don't need to provision, install master component, worker component, join together, install pod network policy, all those things you don't need to do. Okay, it will automatically take care of everything. Okay, now, and doing this is highly efficient, and there are also a lot of scaling advantages. Okay, so that is why what you call is creating a managed cluster is a good decision. Not only good decision, you will end up using managed cluster only today. Okay, you won't create your own cluster. That's going to be, it is going to be there, but it's going to be expecting you to manage a lot of unnecessary things. But this is a more popular choice. Okay, an EKS cluster is. So, but you also can install, but we will go through both. We will create a managed cluster and also uh, a normal installation. Okay, and if you want to install Kubernetes on your laptop, Minikube is an option. Okay, the Kubedium is a manual installation. Minikube is only for laptops and Mac, only personal. And managed Kubernetes clusters are for the cloud. On the cloud also you can use Kubedium. On the cloud also you can use Kubedium. What is how I'll show you. I'll show you the bare metal, means the official way of installing Kubernetes is what we'll do. Okay, then later we'll see other options. Let's go and install Kubernetes the official way. Okay, so what is official website first? Kubernetes.io. The Kubernetes.io is official website, and if you're writing certification, you will be given access to this website. You can actually use this website, and you should be upfront knowing how to what you call browse around on this website. Which links are there? How to quickly go to somewhere? How much information is there? It is very important for you because this will help you a lot in your in your certification, because you can actually open this website while you're writing your certification. So your Kubernetes certification is kind of an open book certification. Okay, so but if you open any other website, you're that on the spot your certification will be invalid or revoked. So they will allow you to open Kubernetes.io, but that doesn't mean that okay, you can open whatever you want and start doing it. Everything will be recorded: audio recording, video recording, screen recording, that recording, this recording, everything will be there. You can't again simply tell them I did not open. They'll have proof of everything. So we should not play with that. Okay, by mistake also you'll open, that's it, gone. Okay, so you should be very much what you call not tempted to open google.com. Okay, but you can open this on 20 tabs, like same thing, you can open so many tabs and you can use it like that. You can open like this one will be on what you call documentation on for example, but you can open this website. Okay, and when you write kubernetes.io, when you go and take the certification, you'll be given 2 attempts. So even though first attempt you fail, second attempt is free. So it's actually you can write exam 2 times. Okay, even though you've passed first time, again you can write. So you'll be given a chance to write exam 2 times. Okay, and the Kubernetes certification is not choose the correct answer like your cloud certifications. You will be given a cluster to you to operate, manage, fix and configure. So he will tell you this is the application, I want to write a Kubernetes configuration for it, or this is crashing, why? This is not starting, why?
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you should be able to actually operate a Kubernetes cluster. So you should do a lot of practice before you go there. Okay, it is not like AWS. I'll have some choose the correct answer. Nothing like that. It is a 2 hours exam which you should sit down and write. Earlier it used to be 3 hours. People were scared, so they bought from 3 hours to 2 hours now. Okay, earlier it was 3 hours. Now it is 2 hours. And also now exam is little bit made easy. Earlier it was little hard. Now they made little easy. They want more people to pass because they want more. You know the business logic, right? If more people are passing, right, more people, right? 1 year back no one used to write Kubernetes classification because it was very hard to pass. Now they made it easy to pass. Everyone should pass so that it will become popular, like AWS certifications. 1 year back no one used to write Kubernetes certification. Everyone used to be scared. It is 3 hours exam. There is a lot of, now they made little easy. They decrease the time. Now they want it to become popular. Okay, now when you go to kubernetes.io, our concern will be on the documentation. We don't need this community case study. We don't need anything. We'll go to the documentation. In the documentation, whatever we discussed, try understand the basics. If you still want further, you can go here. Okay, and now to set up a Kubernetes cluster, we'll go here. So here we want to set up something related to production. So let's go to production mode. So here, let's click on production environment here. Okay, then here these are all considerations. Okay, like what you should do, what it should be there, everything, like all the important considerations. Then let's click on installing Kubernetes with deployment tools. These turnkey cloud solutions are what we discussed, right? The turnkey cloud solutions means nothing but, I told you, right? Azure AKS, AWS EKS. Okay, these are turnkey. Turnkey cloud means you not doing anything, you will have the cluster up and running. Okay, but here we will learn the official way, the Kubectl. Using Kubectl, installing and creating Kubernetes cluster is the official way. So it is so official that even the Kubectl will have its own logo. Yes, the installer for Kubernetes also has its own logo here. Okay, the Kubectl is a tool which will help you create a Kubernetes cluster. So this guy is the important person to help you Kubernetes cluster wherever you can. Okay, so and it is official way, and since it is official, that is why it has its own logo, Kubectl. And Kubectl tool helps you create a Kubernetes cluster. Now what are the prerequisites you want to know? It should be a Linux server. You can't install Kubernetes on a Windows. Okay, yes, Windows worker nodes will be there, but not the Windows master node. Okay, yes, you can add a Windows server as a worker node to your Kubernetes master, but not the Windows as a master, which will never happen. Then the server should have 2 GB or more RAM, 2 CPU cores, that's a minimum. There should be networking connectivity. Okay, they should have unique host name, unique MAC address, that's basic, and some ports should be open. Yes, and the swap memory should be disabled. You must disable swap memory mandatorily. Okay, I hope you all know what is swap memory. Will not go there. Now these are the prerequisites. They are not much complicated, right? Any Linux OS, so very broad, 2 GB RAM, 2 CPU, not a very big expectation, right? So let's go and create a server and install Kubectl. And once you install Kubectl, using the Kubectl tool, I can create a Kubernetes cluster. But this tool should be installed first by us. Okay, once I install the small tool, I'll use the tool to create the Kubernetes cluster. So that is the Kubernetes installation concept. First you install all the necessary small tools. Using the tool, you'll install the cluster, and then later do the same thing on worker node and then join them together. Then you will have a working cluster. So this is the official way, and let's install the official way itself. But when you go to AWS, this is not efficient. But on premises, this is the only one of the only methods. But when you go to AWS, there are AWS specific features to be added. So AWS will add them and then expose them to us. So here we will create a Kubernetes cluster in the most standard way, and this method will work everywhere on AWS, Azure, on premises, everywhere, because that's the official way of installing. So I'm here taking an AWS server, but don't worry that I'm installing AWS. I'm just using the Linux servers here. That's all. I'm not doing anything specific to AWS here. I'm just creating a virtual machine and installing in that virtual machine. So the same process, if you have on your laptop also, it will work. or on your own company server also it will work, wherever also it will work. Okay? There is nothing specific to AWS. I'm just renting a couple of servers here, that's all. So here I'm taking the Ubuntu version 18, as I told, the most popular operating system on the cloud. So I'm using the Ubuntu version 18 here. As it was telling, it needs a minimum of 2 GB RAM, right? And a 2 core processor. So I don't have 2 GB RAM, but I have 2 core processor and 4 GB RAM. So I'll take this, okay? A T2 dot medium on the AWS, because it's already clearly told us it needs 2 cores minimum and 2 GB RAM. So here this is the nearest one, so I'm taking it. Let's take 3, because let's create a server with one master and 2 worker nodes. Okay, and what are the ports, right? Let us discuss a little bit on ports and come back 1 second. So on what is the port where the master nodes and worker nodes communicate is the 10250. The 10250 is a port where the master and worker communicate with each other. So this 10250 is mandated to be open between the master and worker, otherwise they can't communicate. Okay, and these are internal. The 6443 port is the port on which we communicate as a user to the API server. So it is going to be a 6443 port, which is on HTTPS protocol 6443 port, on which a user reaches out to the Kubernetes cluster. Okay, and 10 to 50 between the, you can call it as control plane, master node, control plane node, both are fine. Okay, you see here, these are the official names: control plane nodes and the worker nodes. So the master and slave is wrong, the documentation is wrong. So here you call worker, you can this call control plane. Okay, and or your master. Okay, so that's your ports. So I'm launching 3 servers. They'll start in a minute. The advantage is AWS, you can create servers within a couple of seconds and start right away using them. And I'll name one of it as my control plane node, and the others are worker 1 and worker 2. So all the 3 servers up and running, what we created within a couple of minutes. Let's start with the control plane. Click connect, I can connect to them. Now, when you start installing Kubernetes, let's go back to the same page here. Once you start at the top, telling what you need, prerequisites, what is a MAC address, like what is the IP tables, ports. The first thing you install is runtime. I told you to run containers in pods, Kubernetes uses a container runtime. So Kubernetes needs a container runtime mandatorily. So you will install either Docker, Containerd, or Creo. But these two are not yet much popular. I think down the line 2 more years they will become popular. But for now, the only important or the relevant tool for container runtime is Docker. So you need to install Docker first. Once you install Docker, then you should install these 3 small Linux packages: the kubeadm package, kubelet package, and the kubectl package. Afterwards, you will run the command to bootstrap your Kubernetes cluster. Okay, so first let us go and install these 3 Kubernetes components, and the first any of the one container runtime initiative when it's a Docker. So I have already placed all of them in a proper way instead of we going through all of this hassle of installation. So this is a location where all of the code we will be using part of the session will be stored. So I'll let me ping you here. So here only we'll have the installation also. Ubuntu version 18 is still the stable one. 20 is not, it's sorry, not stable, but Ubuntu 18 is more generally acceptable everywhere, all the tools. Okay, this is the location where all the code we are going to write is there, and also the installation script is here. So here, what are the link have pasted everyone? Here we have something called as a install.sh. Open this install.sh. Here there are some commands. The first one is to disable the swap memory. Then the subsequent commands are to install Docker, and then the subsequent commands are to install Kubernetes. Okay, so let us run them. Installing the bootstrapping where the will come, but installing Kubernetes is not much huge important or what you call complicated thing. Okay, let's again go through that. This part is a installation part, sorry, disabling swap memory. These are instructions to install Docker, and these are the instructions to install Kubernetes. Okay, so the commands you will see are very simple: apt get or apt get curl. So this is not something like specialized complicated things. What you will do is you will add apt repository, you will do apt get update, apt install, apt mark. Three straightforward commands, that's all. The Kubernetes is about adding a location, then telling apt get update, then apt get install, then apt mark to mark the versions to not auto upgrade. Apt mark is to ensure that whenever OS updates, these components will not get auto updated. Okay, that is why mark. Other than that, nothing. Okay, okay, the Kubernetes components are installed now. Once the packages are installed, these are nothing but three simple packages: Kubectl, Kubelet, Kubectl. Three tools. Once this tool installed, then you'll go to the next step of using Kubectl to create a cluster. So using Kubectl, we are going to create a cluster now, and creating that cluster is also highly simple. What we just do is run a single command called kubectl init. That's all. So what we do is we do kubectl init command. So let's do that. Kubectl init. This command will create a Kubernetes cluster. So what is Kubernetes cluster? This is master component. So wherever the server you run kubectl init, it will become the master. Okay, and this kubectl init will download the master components and run them. How do they run them? They also run as pods. So the what you call the surprising thing, right, is the Kubernetes master also runs within the Kubernetes cluster you are creating. So the master components also will be running inside the cluster you are going to create. Okay, it's not going to run outside, it's also going to run within your cluster. Okay, so kubectl init, when you run, will also download the Docker images and then create necessary pods for you to run your Kubernetes cluster. So this will not take much time. What it is doing, it is telling pulling images. Okay, this might take a while or two. Pulling image, so it will download the Docker images for all the four master components, and then create pods from those master components and create configuration files for all the master components. Okay, that is what this command will do, and then run the Kubernetes cluster and create a cluster, and then provide a config file to us to access it. Okay, so then once it downloads, it is going to generate some certificates. So why certificates? Because the Kubernetes, every communication between anything to anything is encrypted. So for that encrypted communication, SSL certificates are generated, and Kubernetes also has something called a certificate authority inside called CA. Certificate authority means someone who can assign certificates. What certificates? SSL certificates. That's search. Then it will create configuration file: admin.conf, kubelet.conf, controllermanage.conf, scheduler.conf. It is going to create configuration files for your four master components under etc Kubernetes directory. Then it is going to create pods. Okay, I told, right, the master components also run like a pod on your cluster, so it will get a static pod. Okay, 4 static pods. Okay, for 4 master components: API server, controller manager, scheduler, etcd. So for 4 master components, 4 static pods will be created, and inside the static pod, these will be running by loading this configuration files. So that is your master components. That is what kubectl init will perform. And then once they are created, they'll boot up everything, and within some time it will tell your Kubernetes control plane has initialized successfully. Why it is not telling completely successfully? Because after this there are series of activities we should perform before we have a working Kubernetes cluster. But out of the box now, once you read this message, your Kubernetes control plane is initialized successfully. To start using your cluster, you need to run the following as a regular user. Right now, I'm as a root user. Okay, I'm running as a root user. It is asking us to run as a regular user. What is regular user? Any non-root user. So here I will go to my exit, my Ubuntu user. This is a non-root user. Okay, so I will need to run this command. What is this command? Mkdir. It is creating a directory. Okay, that is very straightforward to understand. It is creating a directory called .cube directory in my home directory location. $home/.cube. It is creating a .cube folder inside my home directory. Then it is copying a file. This is very important. The whole Kubernetes config itself is a very big thing. Okay, that itself is a big thing. So when you want to talk to Kubernetes, right, what do you need? You see, a lot of people think that, okay, if I want to talk to something or communicate with something, I should log into that server where is it installed, then only I can communicate, is what all of our till now IT industry ran. But Kubernetes, you don't need to log into the master server to control the master or control the cluster. You can be there anywhere, even on the internet, and also anywhere within your company's network, and still manage your Kubernetes cluster. Yes, not internet, again, I don't want to go to complicated things, but within your enterprise, within your network, anywhere. Okay, anywhere within your enterprise network, or within your firewall, or within your VPN, you can remotely manage. Because I told you, Kubernetes will only expect a HTTPS based REST API call. That call can be made from the server where we are installing Kubernetes cluster, or any other server. You can still communicate, because for communication what you need is admin.conf file. This conf file is what you need. Inside this, it will have the server URL, certificates, everything. So here we are copying that file to the folder we created. Why are we copying? Because if you end up messing up the important main one, you may not be able to access your cluster anymore. So we are making copy cp command and putting this file here now. And then I'll give the permissions. The permissions are not properly there. I'm going to give the permissions. Okay, now I can run a command kubectl get nodes. So kubectl is the official command, but the kubectl is not directly talking to the Kubernetes master node here. It is only making an API call to the file. So when I run this command, I get an answer. One server not ready, whose roles are control plane and master. If you open this file .cube, which we created here, .cube, and the config file, you see, this is the file. This is important. If you don't have this file, even though you are on the Kubernetes master only, you can never communicate with it. And you see, this is the server where your REST API call will send over 172.31.18.156.6443 HTTPS. So the default way to communicate is this server, and you should be authenticating, right? That is where your what you call certificate will come. Okay, there will be 3 certificates: cluster authority data, client certificate, and also one more is your client key data. These 3 certificates will be there, and these certificates, all data is needed by you. Every time you make a call, this all will be taken and put it into your API call and send it, and then answer will come. It will convert into human understandable and display here like this in a human understandable way. Okay, So that's your kubectl. So if you have this file, you can take it with you to any other server and still run the kubectl commands, provided that you should have this folder .q folder and configure. Okay, so now I've run it. Now I can see this. You also can see the pods running. Kubectl get pods -, namespace, and the namespace name is kube-system. I'll tell you what namespace is. I see that the etcd is ready and running. API server is ready and running. Controller manager is ready and running. The kube proxy and scheduler also is ready and running. Now what does this mean? They are healthy, but the DNS core DNS is pending. The DNS will not be activated until unless we deploy this pod network policy which I told you. Okay, and this is the next one here. You should now deploy a pod network to the cluster. If you don't deploy, your workers and worker node and the control plane node will never talk to each other. Even your control plane also will not be useful, because the network is the core of Kubernetes. So that's a very big thing. So it is important that it is there. Otherwise your work server also will be not ready state and your DNS is not activated. There is nothing deploying working, nothing will work. So we need to deploy. So if we go to this hyperlink, installing add-ons. Yes, there are some add-ons for the Kubernetes, and the network policy is an add-on. So these are all the network policies you have: Canal, Cilium, Contev, Calico. You have your Rumana, ViewNet, but of all the most popular are the ViewNet, then Calico, and then Cilium. The Calico, Cilium, and your ViewNet are the most popular policies we have around. Okay, and we'll use ViewNet here. Okay, so to deploy this, you need to actually go to this company server who created it and get that rule. How is that rule exposed? It is as a YAML file. Okay, so in this install script itself, this command is you need to run this command kubectl apply. So kubectl apply will deploy a YAML file to the Kubernetes cluster. Yes, I will tell you what is YAML file, everything. What is YAML file, what is object, what is all this. But right now, you need to run this command to have the pod network policy add-on added to your cluster to ensure that your DNS will be running and active, because there is a network policy running, and that concludes your master server completion. So now let's run it. It is creating some pods. Okay, and now if you run the get pods, you will see ViewNet running, but your still DNS is pending state. But give it 30 more seconds, it will be up and running state. So now let us again run it. You see now your DNS is live running state. Okay, your ViewNet policy is also running. Now this concludes your, now if you do the kubectl get nodes, okay, the get nodes command is to get the list of nodes connected in your cluster. There is only one node now, and that node is ready. So your master Kubernetes control plane is up and running. Now the next activity is for us to go and get with the worker nodes. The worker nodes will not have this much of tasks. Okay, it is very straightforward. Install the tools and run a simple join command. So let us go to the worker one, connect, log into the server, and run all the necessary tools, the Docker and the Kubedium kubelet tools. Okay, installing these tools will not install Kubernetes. There are small tools only, so you don't worry that we are installing whole master components again. We are just installing the tools only, but we will never deploy the cluster here. Okay, we'll just install the tools and join them. So run like this, sh install. Once the Docker and the other three Kubernetes tools, Kubedium, Kubelet, and Kubectl are run, we will only perform one activity, which is in your main server. When you created cluster, when you ran this Kubedium init command, right? When we ran this Kubedium init command, at the end of the right, you will see an output calling. Once you run the pod network on the cluster, you can join any number of worker nodes by running the following as a root user, as on reach. Just copy this command, kubedium join command. Okay, copy this, simply paste it here once the installation is completed. Okay, So worker nodes is very straightforward. Just install the Docker tool and Kubectl tool, then simply paste this kubeadn join command, run it. Within couple of seconds it will join. That's all. And if you go to your master node and if you run same command, kubelet get nodes, it will tell not ready. Don't need to worry. Within 15-20 seconds it will automatically become ready. We don't need to do anything. So worker nodes is pretty straightforward. Install tools, run join command. So let us do one more thing, same for the other server we have taken here. Sorry, not this. Worker node 2. The tools are installed. Let's run this only simple join command here. So go back to the master. All of them are ready. So to ensure that your Kubernetes cluster is healthy, you need to run these two commands. Kubectl get nodes and everything should be ready, and kubectl get pods -- namespace kube system, and see all of them are running. And once all of these are, you can easily tell or publish that the Kubernetes cluster is healthy. Okay, no one should be what you call running or 0 by 1 ready or any other status. Okay, that's your Kubernetes cluster and it is up and running now. And what do you do inside Kubernetes? It's just simple, guys. We deploy our applications, whatever the application our developers wrote, whatever programming language. The process is, first we'll containerize the application by writing a Docker file, right? You write a Docker file, you create a image, and we take that image, then come to Kubernetes and provide the image name, tag name, how much RAM, CPU, how many replicas you need, and then execute it. Then Kubernetes will create as many number of replicas, everything, and also continuously monitor and manage and ensure they are always running. Okay, and as I told you, the Kubernetes master component will take all of this intelligent decision management, and the worker nodes only try to blindly whatever the masters does, it will do. Okay, now how do we leverage Kubernetes to our advantage? What is going to give you, what is Kubernetes going to give you? In Kubernetes everything is an object, so that's a fundamental notion we should understand. Okay, so pod is an object in Kubernetes. Okay, so pod is an object and we create a instance of this object and also provide all the options. So like that, there are a lot of these objects which literally are converted or what you call literally means features of Kubernetes. There is something called replica set, there is called deployment, there is daemon set, there is config map, there is secret, volume, and not volume, but what you call it, persistent volume, then job, okay, and services.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Like that, there are different kinds of objects in Kubernetes. Each object is one big feature in Kubernetes. Okay, and within the deployment and this itself, there are like a lot of features again. Okay,
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
like that, we'll have different objects. Each object is a certain feature in Kubernetes. By providing or creating an object of that pod, we will leverage that features. Okay, and you are we going to create a single pod? We will never create, because that's not the intention of Kubernetes, right? We will not just create a single pod. We want to create scalable, highly available group of pods which are together self-healing. That we'll create. Okay, but if you want to create a single pod, that's also fine. So let us go through what you call a simple definition, like what is this YAML then? I told you now this is we everything is an object, everything, right? How do you represent this instance of an object and all the options to it, right? I told I told that we will everything is an object in Kubernetes, and we will create an instance of this object and use the features of this object, and also provide our customized our options or our config. So this object representation is done in YAML syntax. So we define what we need Kubernetes to do in the YAML syntax, but what we define in the YAML syntax is object and its specification. That is why it is called object specification. Kubernetes object specification or object spec in short form is called as this YAML files. Kubernetes has objects, those are something called leverage. You want to talk to it, that's your object specification. So that object and the specification what we want is going to be defined best. Those YAML files are called object specification files in Kubernetes terminology, and this YAML file is used to define your Kubernetes configuration, what you want to what Kubernetes should do for you. Okay, that is going to be your YAML syntax. Okay, so now that we understood what is an object, yes, we'll cover all the objects and more, and what does this object represent or what it's trying to do. Now let's try to understand one object, the smallest object and the most relevant object, pod. Okay, this each object is one large feature. Okay, we will go through them, and you don't need to put the object name. You can put ABC also. It's not that you should put what the object type you are creating. You can tell ABC, but this will be either YML or YAML. So you can name the file anything you want, but the extension should be YML or YML because it is expecting that it's a YAML file. So I will put YAML. Okay, YML or YAML, both are fine. I'll put YML because I've been doing that. Now here inside a Kubernetes object specification or Kubernetes object spec, there are mainly 4 sections. The first section is the API version. Since everything is an API call, you have an API version, means Kubernetes at any point of time has a lot of alpha and beta features also running, which will be segregated from your stable features. So the stable features will be V1, and if it is unstable feature, it will be either designated as beta or alpha. Alpha is highly unstable, beta is semi-stable, and your release candidate or release is a highly stable. That is a section 1, which API version you want to hit. Then the section 2 is the type of object you want to create, right? Obviously everything is an object in Kubernetes, so you want to do something, you need to invoke an object to do that. So the kind is pod here, but that will keep changing, like either it is a node port or what you call anything. Okay, so it is going to be the type of pod. Then the third one is the properties of the pod, right? The type of object you are creating. Here you are creating pod, it is going name of the pod. Okay, any other labels are only used for distinguishing different kind of people or try to find out a specific one. You do labels, right? Like you go and give a label like cap or a pen or a some tie, right? This is something like you are giving a label to uniquely identify within a group of people. So you can give labels is optional, but the metadata name is mandatory. Your pod name is sample-pod now here, but you can't reuse the same name again to create one more pod. So once you create one pod with a name, that's it, that only that pod will have what you call that only that only one pod can be created with that name. And if you try to recreate with the same pod name again, Kubernetes will easily tell you there is already a pod with the same name running. Okay, that's your pod and the name and the metadata. Then the final thing and the most important in the spec, the specification, the actual options you need for the object to create. Here spec containers, and the containers is a high level object. Here name of the container and the image name of the container. You see here ultimately you're still pointing to that container image and container name, but the whole abstraction is done on your Kubernetes layer. So but you'll still give an input as a Docker image and the container only. Now let's exit this file. First, let us see if we have already an existing pods. But you'll right away got question. When I ran this command kubectl get pods, I'm getting answer, but I am running here. But you're seeing is in the minimum, you will have one namespace called default namespace, but here we are seeing in the kube system namespace. That is why there are some pods on other namespace, but not on your namespace. Now, no resources found in the default namespace. By default, there are 3 namespaces. 4 actually, but one is not relevant. So default kube public kube system are the ones, and the node list is not much relevant. So out of what you call this, right, you are seeing the pods only to the current namespace. Now let us apply this. So kubectl apply -f, and the file name is how you actually, okay, I did not save the file, huh? Okay, sorry. So I'm pasting this content, API version. See, these first 3 sections will never change. They'll almost be identical apart from some name. API version will always be free one. If you're creating a type of pod, it will be pod, and then the metadata associated to it. And the spec is the most important one. Now let us execute. How do you execute? Kubectl apply -f and the file name. That is how you're going to apply a pod. Okay. And the most interesting thing is when you create an object, right? Kubernetes within next second it will tell you created, but it will never tell you properly started, crashed also. That's a very, very important thing you need to remember. Okay. So it told that it has a created, but it will never create. Or what you call, if at all you have any issues. If there is no issue, it will write create. But if you're away, ensure someone, what you call the pods are seeing. Okay. Kubectl apply -f and the pod is created, but it will never tell you successfully created or not. It is your responsibility to go and again verify. Kubectl get pods. So now pod is running and ready one by one, means it is actually running properly. Okay. So apply -f will take the specification and give it to API server. API server will go to headset. Headset will store, then tell the scheduler to schedule. Then scheduler will tell controller manager. Controller manager will go to kubelet and the Docker. Okay, so here we create a single pod. How to delete it? We are going to reference it by the file again. Kubectl delete -f and the file name. Now if you do kubectl get pods, nothing. There's no trace of it.
So we understood what is Kubernetes, what it is capable of, and how to install Kubernetes, what is the difference between Docker and Kubernetes, what is the relationship between them. And also right now the Kubernetes is the de facto orchestration platform, and Kubernetes is going to become the runtime of the world for the next decade. So for the whole decade, next decade, we are all going to use Kubernetes. We don't think there won't be any other competing thing going to be there anytime soon. So Kubernetes is going to be the runtime platform for everything. Okay, so this is going to be a very long-lived tool. So this is not something tomorrow something will come overnight, Kubernetes will go. That's not going to happen. That's not going to happen anywhere in the near term, at least for end of 2020. Okay, so this is very important tool, and this is a foundation, and it's going to be there for a very long time. So you all need to ensure that you know this. In Kubernetes, everything is an object. Okay, so it is a little bit of a simple thing. There are objects, and for the object we'll create a type of object. From that object type we will create object types of its replication, or what you call if it's instance of an object. So every feature in Kubernetes is an object. So pod is an object which will help us accomplish some activity. There is one more object. So like that, there are different objects with us which will help us accomplish different activity. Now the important object, or from the start, right, let's go with the replica set. The replica set is one of the most foundational object we will end up using a lot, though not directly but indirectly. So first, let's learn directly, and finally we'll see how it is being used indirectly. So replica set is an important object, but you will not use directly. Okay, but first let's learn this. So the replica set right away gives you a lot of features, and right away gives you a lot of advanced features. So again, this is kind replica set. So last time we put kind object, kind pod. Now we put kind replica set. So this is a different object. In Kubernetes, when you define an object, you also need to provide specification, right? When you're buying something, you'll see specs, right? This much RAM, this much, same kind of thing. There's a spec. So, and the spec values will be different everywhere. They'll not be same based on object to object. If you're mounting some storage, there'll be like how much storage like that. So if it is based on the type of object, the options also will keep changing for different object. But this object's syntax, everything is very simple, and you always can copy paste from internet because it's mostly standardized. No one will have some crazy things. Okay, this is not a programming language, so you don't need to worry there will be 1,000 options or variations. There are only limited set of options. All of them will use from that options only, so no need to much confuse. And industry standard, everyone will use all these objects. So first thing is replicas. The replica set will use replication controller. So in your controller object, one of the main 4 Kubernetes master components, there is one object called controller manager. In the controller manager, there are a lot of controllers: node controller, replication controller. So the replica set will call replication controller, who is kind of a manager who will manage all these kind of objects. So replica set object, what does it do? It will create replicas. What replicas? It will create replicas of pods. So instead of you directly creating pod and maintaining, you will create a person called manager. So this replica set can be thought of a manager. I will tell manager, you go and manage those people. I will only manage you, but I don't care how you're managing them. So it's like you are a senior manager, you put a manager there. So replica set is kind of a manager who will manage the pods behalf of you. And he'll only take care of the health of the pods, creation, updating, deletion, all of them replica set will do. You don't need to directly interfere there. So I will tell replica set, you give me 2 replicas. But what replica? You should give some specification, right? That is a template. The template is a pod template. Means first you should have something, right, to make it replicas. So this template is what you will make. It is 1 into 2, or it is 1 into 3. So what should be created is for 1 object. So this is for creating 1, and this will be made into 2. If you put replicas, you'll go 4, then it will be executed 4. So the template is the actual pod template. Template is pod template. So you will give definition for 1 pod, and you will tell how many replicas you want. So here, this is a template. Now you will see this match label here. So the what is this meaning? Why two times I'm seeing label? So when you create an object, this is a replica set object. Okay, and these are the pods. So everyone will have a name, right? So replica set name is also something like this: label app equal to sales-app. Now this is the label name. Label is nothing but like sticker, right? You're putting some label. So pod also has label. So what you should do is you should ensure that the pod labels are exactly matching the replica set label. Then only the replica set will actually identify them. Okay, this pod, the replica set will manage all the pods who have the replica set name label exactly matching the pod label. So if whichever pod has the label like itself, same label, then replica set will automatically manage. And when you're creating, you should give. If you don't give the same, right, first of all, this YAML file will be giving you syntax error. So first of all, it will not even allow you to go forward. Okay. So this match label is a name for the replica set. And this label is for the pods you are going to create. It's going to create and ensure it's always similar. This is a very, very important logic. Okay. The replica set match label. And this template is nothing but this is a pod template. Okay, so this is a specification for 1 pod. So the pod and the replica set should have the name, and this is mandatory. If you don't follow also, it will throw error. Okay, so that's the, and here this is again standard containers. Why do you see containers? Because ultimately inside your pod, container only will be there. So containers. What is the name of your container? So this name will be given to the Docker container it is being created, and this is the image name, and I am giving resources. So 200 millicore and 105 MB. So for each pod, this will be, it is not like combined. This is for each pods because this is 1, right, for 1 pod. So each pod which is getting created, every pod will get 105 MB RAM. All the 3 pods will get 105, 105, 105. Or here 2 pods means 105 and 105. So this is the replica set. And once the replica set is created, replica set will in turn create 2 pods and manage behalf of you. Okay. And what does replica set give you beyond your this one? Means if I want, I can create 2 pods, right? But what is the big advantage your replica set is going to give you, which our single pod won't give you? First, replication. You cannot create pods too. Pod means only one will get created. You can't tell pod equal to 2. So pod will only create one pod, but here you have replication. Then here you have online scale out, online scale in, and also self-healing. One of the biggest advantages of Kubernetes, it can self-heal itself. It does not need the administration interference for doing the self-healing, because that is the main advantage. Once you properly set up Kubernetes, right, it is very hard for you to bring down your applications you deployed. Okay, so we'll see that. So replication first, let us see. Okay, once we apply this object, we can see replication. So what we'll do, this YAML file looks good, so I'll exit kubectl apply -f file name. Okay, and this file name I gave the object name just for identification. You can give the file name whatever you want. abc.yaml also is fine. So replica set is created with the object type replica set with the name sales-app. So first you will do kubectl get replica set to list down the list of all replica sets. So I got, you see here, desired to, current to, ready 0. So they are not yet ready. Okay, so it will take ready. So here there are three things: desired, current, ready. Desired means how many you desire. How many do you desire? Whatever you define in your YAML file is what you desire. So inside YAML file we gave replicas equal to 2, means that is what you desire. Current means how many are currently running. Then what is this ready then? Ready means how many pods are ready to serve the traffic. But if it is running, it should be ready to serve traffic, right? Then why is running? What is current then ready? So in Kubernetes, you can actually control whether a pod who is already started is capable of serving traffic or not. Also we can control. But out of the box, okay, there is some small issue from my side. This is not the same cluster. I actually deleted the cluster. Again, I recreated today. I forgot to run one important command. Okay. See, you remember I telling you CNI, right? Network, pod network policy. So I did not install that. So that's my mistake. This is a classic error. If somehow you did not deploy your network policy, right, the pods will never get scheduled. Okay, the whole cluster will be not ready. I told you, right? Kubectl get pods -hyphen namespace kube -system. The DNS is not pending, so let me fix that issue. Okay, so whenever Kubernetes is not something running, first you can see whether all the servers are ready state, and also all the pods of your kube system namespace are running state. Okay, everything is ready. So now if you go and check your kubectl get replica set, they'll be ready because they're actually deployed now. Okay, so get replica set, desire to, current to, ready to, and kubectl get pods. So here the first thing is I created replica set. I did not directly create pods. So once I created replica set, desire to, current to, ready to. So right now there is no rule. See, out of the box, any pod which is running will be automatically marked as ready. So there is nothing difference, but you actually have the chance to control it. But out of the box, any pod which is automatically started will be also marked as ready. So here current and ready both are equal here, but we can control. I'll tell you in a minute. Then status running sales-app. Okay, so now there are two pods created here. So who created these pods is, you can see the name here, sales-app. What is the sales-app? Replica set. So any pods created by a higher level of object will have the name of that higher level of object. So sales-app is an object, replica set. So that name is there, and a 5-character random digit with alphabets and a numerical value. Okay, and they are ready and running. So that is your replica set. And the first thing you should understand is who has taken the decision that this pod should go to that server, this pod should go to that server is your controller manager. You are not doing the decision. But if you want to know where it went, the get pods, right, -o wide is the command you can actually use to see little more information. So when you do get right, some general information will come. But if you want to see little more information, you do -o wide. Then little more information. What is the IP address of this pod? Okay, on which server this pod is running. So these two things you will know additionally. Okay, so one pod is running on a 8057 server, one pod is running on 84125. So if you want to see what are those servers, you can do get nodes. So the 8057, 84125. Okay, 8057, 84125. These are the what These are your worker nodes, not the control plane or the master node, because the pod will never get scheduled to your master or control plane node. Okay. So now, okay, there are two pods, they're running. So we have seen this replication. Now let's see what is the self-healing. So when you talk about Kubernetes self-healing, right? Let us assume that this pod was somehow deleted by someone unknowingly. So they did kubectl delete pod name. Okay, to delete a pod. This is also a standard way. So kubectl delete object name, object type, and object name. So object type is pod, and object name is sales app. This one. Okay, I'm deleting this pod. Now what happened this pod? You're deleting this pod. So you are deleting a pod who is managed by other person who is replica set. So once this pod is deleted, and if we go back and if you see again get pods, again there is a pod. So I did not create this pod, right? Here this pod is 15 seconds of age. So the moment you delete the pod, the replica set will replace that pod with a new pod. And where it will replace, it's not always same. Sometimes it will replace on same server, sometimes it will replace on a different server. You don't have control. Okay, because Kubernetes will see whichever server is capable of serving that, it will put it there. So sometimes if there are two pods on the same server also, we'll get. But what if the whole server went down? This 8057, right, IP address. For example, this server went down. That time also you don't need to worry. The pod will be sent to other server directly. So if server is already there, pod is deleted, it will recreate. If the whole server went down also, it is still fine. It will take that pod and create a new pod. So there is no recreating or moving. It is a new pod. So Kubernetes will not move the pods. There is nothing moving, copying, nothing. A pod is lost, it will replace with a new pod. So here new pod came. That is why the name is also different and the age is 15 seconds. Okay, that is your self-healing. What if you delete both the pods? It is still fine. It will still recreate it. So that is why I told you. Yes. Now your question will be, what if I delete replica set? Yeah. If you delete replica set, yes, the whole replica set will go. Now you deleted both the pods. So again, Kubernetes will see, and if anything is bad, it will again reconcile the state. So two new pods are again running. Okay. This time they are running on 8057. So that's your self-healing. Now let's talk about the online scale out. So you are running your application that is good in production. There are two instances running because you want HA, but due to some more load, right? For example, this weekend, right, in US, it is a long weekend because there is some Labor Day. Due to that Labor Day, they are getting Monday also off. So people may buy a little more because they have some time to buy. Now you feel that you want to increase the traffic. You feel that, okay, there will be more traffic coming in. So you'll make the replicas equal to 4 now, because for this couple of days, you want your applications to be having little more bandwidth or the processing power, so that requests will be served faster instead of waiting. Now what you'll do, now again you'll do is kubectl apply. There is nothing change you'll do. You'll still run the same command, apply command only. One distinction is, first time when you apply an object, that time you will get a message called a, when you apply this YAML file first time, you'll get created. So when you're creating that object first time, it will always tell message is created. Remember, all of these things are very, very important. Okay. Then when you again make changes to that object, it will tell configured. So based on the message itself, you can easily tell, okay, this object is already there or this object is newly creating. So since the object was already there, just some state was changed. Now, if you do kubectl get replica set, now you see desired is 4, current 4, ready 4. So you told it to scale. Now the question is, what happened to the existing 2 pods? So when you actually scale out means like less to small. Okay, you're scaling out like 2 to 4 or 2 to 3 something. So the existing pod will not be disrupted. Okay, the traffic will keep serving. That is why it is online activity. It is not disruption. So when you're scaling your replica set, existing pods will keep running. The existing traffic will be keep serving, and the application will not have any effect. That's a big advantage of replica set or your Kubernetes. So you see this age 2 minutes. So these guys are running from last 2 minutes. Whatever I created just now are the age of 57 seconds. So when you scale out, it is online, means nothing is happening. Okay. Once these guys are also up and running properly, then traffic will also automatically come to these guys also. Okay. And when you're scaling out, scale in means like less. Okay. You're coming in, scale in. So when you're scaling in, what will happen? Again, it's the same thing, online scale in. But the question is, who will be deleted? Is there any logic? Yes, there is a logic. The youngest pods will be deleted, the oldest pods will be retained. When you're decreasing the replicas, right, the youngest will be retained. So if you do get pods, there are 4 pods running. 2 pods are 3 minutes 54 seconds each, 2 pods are 2 minutes 40 seconds each. If I apply my replica set, this younger pods will be deleted because Kubernetes thinks that the more time the pod is running, the more stable it is. So that's why it will do that. Now, if you see, pods are gone, and the pod which are 3 minutes 54, like the age increased a little bit, but you see, right, the 3-minute pod, right, they are gone. Okay. And in Kubernetes, I told you there are only 2 states for your pod: creation, termination. There is nothing you can do in between. There is no stop, pause, unpause, nothing. In Docker, there are totally 7 states for a container. But in Kubernetes, there are only 2 states for you, which you can control. There is one more state, but that will be done by your Kubernetes. Kubernetes can restart a pod. You can't restart it. Okay. So for us, there's no restart concept. You create a pod, you delete a pod. There is nothing between. Okay. And it is called termination. And a pod will be given 30 seconds of grace period for termination. Very important numbers again. Okay. So means any pod will be given 30 seconds of time, okay, for itself to delete. If it is moving, then 30 seconds, Kubernetes will come and throw it off forcefully after 30th second. So sometimes when you delete, you will see terminating for 10-15 seconds. You don't need to panic because Kubernetes is giving time, that 30 seconds. And if you want, you can also increase that, the 30 seconds to 1 minute. It's up to you. Okay, if you feel that, okay, your complete transactions are a little bit time taking, but even though once it goes to termination, anyhow the request will fail. Okay, so all the requests on the termination pod will be no longer coming in. So, but if anything, it is doing backend activity, right, it can do. But request will not come. Sometimes, right, whatever the work it was doing, it needs like 20-30 seconds to complete its work, right? So it may be useful, but once if anything processed, it can't send back because that's gone dead. So that's your replica set. So we have seen 4 powerful features. Normally, this is very hard for you to implement in any kind of existing tools or anything, right? Replication, self-healing, scale in, scale out. This is all not simple. Okay. Most of the tools are not even have anywhere near the capacity to do these kind of things. But Kubernetes does in a very simple way. Okay. Like Kubernetes is so powerful. Any small things you do, it is like to be much impactful, but you don't sweat. For us, it's simply YAML file running and doing apply, that's all. Okay. The next question is, what if someone will come and delete this replica set? So kubectl delete replica set sales-app. What if someone deleted this? So if I do kubectl get replica set, there is no replica set. Obviously, all the pods managed by the replica set also gone. Okay, this guy is also getting terminated within 5-10 seconds. He'll also get vanished. Okay, yeah, he's also gone. So yes, you still have that little bit of headache where if you delete the higher level object, right, there's nothing, no one will recreate that high level object. Okay, so okay, but no one actually deletes that until unless you admin kind of people will delete. Pod, right, gets deleted by, or what you call crashed by your application running inside, right? If the application running inside crashed, also your pod will get crashed. So pod will get restarted. So, but the pods, because the replica set is actually controlled in your master server, right? But what happens is your pods will be running on your worker nodes. So if one of the worker node goes down, pod will get recreated. So that's why this is not a big concern for us, because no one will actually log into your master node. But worker nodes will be more of them. They'll actually happen all this kind of what you call go through this maintenance activities, all these things. And as I again told you, for a production Kubernetes cluster, you should always have 3 master nodes. Okay, not 1, 2, or 4, but 3. 3 is considered HA in Kubernetes, because if you only have 1 master node, if that master node goes down, you can't perform operations. See, your application will not go down. See, your worker node will be there, application will be running, but the problem is you cannot do any administration on it. Okay, you can't do deployment, self-healing will not happen, nothing will happen. Okay, but if master goes down, your applications will keep serving the traffic and there won't be any disruption in the pods and their state. But new deployment, existing state reconciliation, nothing will happen. So that's why it is 3. So if you have 3 masters, one of the master goes down, 2 more masters will be there, it will keep working. Okay.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, let's let's learn another object and let's learn little more things there. So it feels like replica set is already good enough, right? But replica set can do these four things, but one thing replica set cannot do, which we expect is the deployment. So replica set cannot handle deployment. Deployment means changing your code, right? So how do you change code in terms of containers? From the perspective of containers, what does changing your code means here? The image is foundation. That is what your code is, right? There is no code, right? Changing code, there is no code at all in here. The code is inside image. So for us, image is the main thing, the Docker image. So Docker image, I hope everyone knows the Docker file, everything. So I'm not going anywhere there. So in terms of deployment in the container world is your image. So if someone will tell, are you deploying your code in Kubernetes or are you performing your application deployment in Kubernetes, what does it mean? It means that that person is referring to that new code is in a new image. You are going to replace the existing pod from the old image and creating new pod from the new image. That is the meaning of deployment in a Kubernetes or Docker. Docker also, if someone tells deployment, what does mean? Old containers will be deleted. You bring the new image. From that new image, you create new containers. Then that is a deployment. So here also same thing. So you have old pods, and the old pods are what? Pointing to old image, old Docker image. So if someone will tell you deployment, you know that any change in the container world will be dealt with a new image. You're not going to touch anything those. That's not even possible. Whatever someone told, but that's also not done. So that's your deployment style. Okay. Now so this cannot be done. Replacing the old pods with a new pod cannot be done by replica set. Replica set cannot handle deployment activity. That is why we use an object called deployment object. This deployment object is what you will end up using every time in an enterprise. This is your number one most used object in Kubernetes, the deployment object. All our applications will be deployed using the deployment object in Kubernetes, who will handle all these things additionally with deployment, and that too deployment in a online and rolling way, which ensures that your application has zero downtime. Okay, now let's go to the deployment object. So the deployment object replica set are exactly similar. So the YAML file, nothing will look much different apart from this deployment word, right? They're all same. You'll also have match label app. Here also you'll have template label, right? So this is also again same thing. This template is nothing but a definition of one pod. Okay, this is one pod definition, and this one pod definition made into 4 here. What we saw here, or you want into 40 also you can do. It's up to you. Okay, so this is a pod template to create one pod, and we will create replicas, and again match labels label. Then what is the difference between deployment on the object is the deployment is a higher level of object than replica set. So what happens when you create a deployment is we should understand first. Right now, having proficiency in Kubernetes is very, very important, guys. That itself will make or break your interviews. So ensure that you know it. Okay. Otherwise, earlier that used to be not the case. Earlier there used to be a lot of qualified people, less jobs used to be there, IT jobs. Now it is opposite. When you create a deployment object, what happens is the deployment will in turn create a replica set. Okay, so you create deployment. Okay, you're not going to do much more than that. So what I'll do is I'll create a deployment object. Okay, so when I create a deployment object, the deployment object will not directly create pods. What it will do, this guy is again what you call manager of manager kind of thing. So he will create a replica set object, and then that replica set object will create a pod for you. Then it looks like unnecessary complex initially, because if I want to create pods, then I can ask directly replica set, right? Why should I ask you then if you are again delegating your work? Why we will use deployment without using replica set is, see, you are having version 1 application running. Okay, your application is version 1, your code, okay, which you have built and deployed through your CI/CD pipeline and deployed. Now when the time comes for the version 2 of the code, right, because as part of agile release, there are in a sprint there'll be so much active development and developers will keep changing the code. Now when the developer changes the code and triggers, the whole life cycle starts, where the code will be changed in the version control system, and then you have a triggering. Then Jenkins will get the code, compile the code, package the code, put it inside the Docker file, put in the Docker image, build it, upload the Docker image to your repository, and then you run the deployment. So when you do deployment, what happens is, if you're using deployment object, the deployment object will create one more replica set, and then what it will do is it will start replacing your new pods with the existing pods in an incremental way, in a rolling fashion. Rolling fashion means in a step by step or incremental way. So right now you have version 1 code already deployed and 2 pods are running. Now again you deployed. This time version 2 came. So what it will do is your version 1 pods will be running. It will create a new pod with the new image, right? Because the image changed, image tag will change. So image tag changed version 2. So first it will create 1 pod here. Okay. Then once a pod is created and it is healthy, then it will delete a pod here. Then again same thing. First it will create a new pod here under this replica set, and then there will be, once a pod is healthy, they will delete this pod. So here it means that while this one was creating, 2 pods were there. While this one was creating, 2 pods were there. Okay. So this is rolling update, means at any point of time your application will never go down. There is no downtime for your application. Always application will be running. So that is why we use the deployment object. Okay. Deployment will do, means deployment can handle 2 replica sets simultaneously. Once this everything is done, this replica set what you call running equal to 0, it will become, this will become 2. Okay. And if you go from same scenario again, this will become 0, this will become 2. That's why deployment will handle every scenario what we need. Okay. So that is why use the deployment object always. And yes, we can see that scenario. Now the deployment object, right, it will look like replica set, same object, same YAML syntax, nothing much. So right now my Nginx is 1.16 version. Okay. So first we will deploy this. Okay. First, once we deploy this, there will be 4 pods created. So kubectl get deployment. So deployment object, I'll do get deployment. So right now there are no objects with the type deployment object running on my cluster. So what I'll do now, I'll do apply kubectl apply -f deployment.yaml. So once I run this, first I will check again same deployment command. So there is done deployment. It is telling 0/4 up to date 4 because it is just 4 seconds, right? Yeah, it will take 10-15 seconds to create. When you do get replica set, so you see the replica set name. The replica set name came from the sales app. So the deployment object has actually created the replica set. And if you do now pods, the replica set created pods. So you see the mother name here, like the parent object name. So parent name is reflecting. So I can easily find out who created these pods. Okay. So all the 4 are running. So deployment created replica set created pods. This is all good. So first time you deploy, they are running. It's all good. Now the time for deployment came. So what you'll do, you'll open your deployment YAML file, update the version of your image. Other than that, nothing much complicated. See, once you go to Kubernetes, right, the application lifecycle deployment will be drastically simple. Okay. So 1.17.1. Now kubectl apply -f. So again, I'm doing deployment. Okay, I'm applying. But for this, right, let us run the command because you will actually know that it is running in real time, right? So we'll try to run one more different command, which will actually be displaying that status to us. So I will try to log into the same master node in say another one more tab to show you that activity it is happening because it is fast sometimes. So we can't capture it. So that's why we need to run one more command to see that. So same, I'm logging into my master only. I'm not doing anything. Kubectl. Okay. Is this sales-app only? Okay. Normally the rollout command, whenever it is not running, whenever the rollout is not happening, it will tell rollout successful. But this command will give you a different output when that rollout is happening. I told, right, incremental 1 pod, different pod, right? So normally when you run this command, it will just tell rolled out. But when you apply this apply command, right? So what happens is it will show you that what 1 pod is replacing 2 pod is coming, that output it will show you. So what we'll do is we'll run this command and simultaneously we'll run this command. Oh my God. So you see this message, rollout. Okay. So it means that why did I run this command is this is not happening like deleting all the 4, recreating all the 4. That is not happening here. So 2 out of 4, 3 out of 4, 1 old, all done. So it is actually doing incremental fashion is what I wanted to show. Okay. This normal, again, if you run this command, it will tell rolled out. But during rollout, this will tell you like this. So now if you see the output, the first thing is your deployment will look same. Your deployment will still 4 only. But where do you get that major difference is your replica set. You will see now 2 replica sets. The D966 you see here, the D966 is the old replica set. Okay. The D966 is old replica set, which are 4 pods, but now it is decreased to 0. And a new replica set is created with 59C has 4 pods. And if you do -o wide here, you will see that this replica set had the image version, sorry, image tag 1.16.1, and this replica set has image tag 1.17.1. Okay, and if you now run the command get pods will be having 4 pods, but they will be from a different replica set. Earlier they were from D966. This D966 where now we have 0, and this 59C has 4 pods. Okay, so but you should understand is this did not happen like delete 4, create 1, you have downtime. No, one after the other. Okay, and it's like what, if you have 100 pods also is going to do one after the other. No, it will do 25% one time. So that is the default percentage. So how many pods you have, it will take 25% of them, and it will do that rollout 25% each iteration. So any number of pods within 4 iterations it will complete. But what if you want to do in 2 steps, like first time 50%, next time 50%? That is also possible. It will give you the chance, but out of the box it is built to do 25% rollout each time. So if you have 100 pods also, 25 will be done one time. Within 4 iterations it will be done. Okay, but where did we give that? I did not give anywhere in my YAML file, right? The 25%, nothing, because one important thing you should understand in Kubernetes is there are a lot of default values, even though you don't give, are automatically applied. So that's an important thing you should understand. So there are a lot of default values, right? Even though you don't apply. So the first thing is the deployment did not have anywhere that 25%. So one more important thing which will be useful when you're writing your CK exam, right, is in CK exam, they'll ask you to write deployment. Like this, they'll tell, can you create a deployment object with 2 replicas like that, like that. So there are 2 ways you can do that. One way is open the Kubernetes.io website, because you are entitled to open. No one will tell you you're copying, because part of the exam, you can open Kubernetes.io website and then search here and there. Okay, no question asked. You're happy to go to Kubernetes.io website and then what you call search for the whatever you want to search. So that is one way. Okay, you are completely given choice to go to the website. And okay, so it is very easy. You have a search somewhere in Kubernetes. Let's go to documentation. I remember there's a search somewhere. Yeah, you have a search here. Hit enter, then you will get the deployment answers. Okay, you can open it and copy that YAML file, and in your exam you can paste that YAML file and complete your task. Okay, and yes, you will be asked like that, because the Kubernetes certification is a interactive certification. It is not like choose the correct answer. So now you see I got deployment. I will copy this code, I will paste it. Fine. There is one more way of doing this. Okay, is a
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
through imperative way. So when you are creating Kubernetes objects, right, there are 2 ways we can create. 2 ways to create Kubernetes objects. I am telling you only one way, okay, which is a declarative way, which is a standard way. Okay, there is one more way which is not a proper way, which is called imperative, and it is never used. Okay, it is never used. No one uses it, but still that is there. And that imperative way or imperative method is only for some kind of demo purpose. The demo purpose also it is not useful, but for some reason it is still there. Okay, what is imperative method is, instead of writing YAML file, you can run the command kubectl create deployment like that, but you have a very limited choice in creating that object. Okay, because you can't pass all these features into this command line. Not at all possible. Only 1 or 2 feature it will allow you to pass. So whenever you create a Kubernetes object with the kubectl command, it is imperative method. And whenever you are creating Kubernetes objects using the YAML file, it is called as a declarative method. Okay, so we will never ever use imperative method in any place in a company. No one uses it. If you are using, people will think that you don't know Kubernetes. It's that bad. Okay, so if you use also, someone will tell, what, you don't know Kubernetes, why are you using that? So it's not used at all. But in your certification time, it will be little useful. Why? Because what you will do is, let me show that command. because I also don't use it. So I also need to Google it. So get. Yeah, so this also you can do. Now, right now we have kubectl get deployment. Okay, so there's only one deployment. So when you run this command, kubectl create deployment nginx -- image equal to nginx : 1.16 1.17.1 whatever it is. Okay, so there, so when you do like this, it will create a deployment object. So kubectl get deployment. Now you have one more deployment, okay, with a scale equal to replica equal to 1. Now why did we learn this is once you create like this, you can actually see the YAML file which was applied to this. So kubectl disk get deployment name -o YAML. So this is again a very interesting thing. When you do -o YAML, it will print you the YAML used for this create. You see this lengthy YAML. I did not write all these things, right? But still, these are the default option. You see strategy, rolling update strategy, max search 25%, max unavailable 25%, type is rolling update. Okay, I did not do all these things. Why? Because actually when you run kubectl command, right, there is a lot of things happen actually. So most of the people will never concern is the first thing I told you is the Kubernetes. When you're talking to Kubernetes, right, I told you you only can talk to your API server. API server is the only component in the whole Kubernetes cluster which will actually even respond or communicate with the user. Okay, and what is the primary method in which Kubernetes master server or the API server is going to communicate with us? What is the protocol? What is the port? The three things: port, protocol, and type of method of communicating. These three things, guys. I keep giving you a ton of information. It is your responsibility to go back and sit and again create it. So the Kubernetes API server communicates on 6443 port. Okay, protocol, method. Okay, so the kubectl command is this making a call on 6443? Is it making HTTPS call? No. Then what does kubectl command do is when you do kubectl get deployment, what it will do, or if you do get pods, right, what it will do is it will convert your simple command into a REST API call and run this method against Kubernetes cluster. That is what happens. Everyone will think that okay, I'm running kubectl command. It is a CLI command. No, you are running CLI, but Kubernetes will not talk to you on 22 port or all TCP port, nothing. It will only talk on secure HTTPS 6443 only. Your call will be converted and made. That is why you also can run curl commands also to Kubernetes. If you're enthusiastic, you go and Google search how to run curl command to Kubernetes cluster and get answer. So what happens is when you run kubectl command, right, when you're doing, for example, kubectl apply deployment.yaml, what happens is, okay, you wrote YAML, which is 10 lines, okay, 10 lines or 15 lines YAML you wrote. So what you'll do, your request will go to API server, right? When you run kubectl command, you are actually interacting with the API server. So you submit your YAML file to the API server. Inside the API server, something's happen is the API server will validate your YAML first. Okay. If YAML is good, then what it will do is it will fill out all missing default parameters. Then it will store in etcd. Okay, so these are all very, very deep things, but so you should know because you did not give that object, but somehow this object, this value is there. Strategy, because that is built into the Kubernetes at somewhere. Okay, so this output, right? The output is if you do -o wide, you will see wide method like wide. Okay, you also can see -o JSON also. Okay, till now we are all using YAML everywhere. Showing YAML is good, right? But why did JSON come? We are not using JSON at all, and no one will ever use the term JSON anywhere near Kubernetes. Okay, but JSON you'll see everywhere because any valid JSON is a valid YAML file because YAML is a mother of JSON. Okay, so if a file is a JSON file, it is automatically YAML file because YAML will understand JSON because it is its kit. Okay, so that is why you'll see JSON everywhere. Even though we don't use JSON, JSON will be there everywhere because a JSON, a valid JSON is also a valid YAML file. But a valid YAML will not become JSON. Its opposite is not true. Okay, clear? We will be concerned about YAML because we'll write. One more thing I'll tell you, I means extreme things, but don't worry, is you also can write a JSON file and submit the JSON file to Kubernetes. It'll understand. Okay. You wrote YAML file, right? You also can write a JSON file. Means your syntax, right? You can write in a JSON syntax also instead of YAML syntax and apply. It will still work. No one will ever do that. In Google also you'll not do, because it is possible, but no one will do that unnecessary thing. Okay, but it's still possible. So when you do kubectl get deployment, right? Even though you don't fill out some basic option, will come. So let us do the kubectl get deployment, your sales-app, and then -o YAML. So for this also, you see the strategy rolling update. I did not give this, right? In our YAML file, this is not there at all, but still it is added. Okay. If you want, I will show you the YAML file we wrote. So this is our YAML file, and there is nowhere that. Okay. Here, everyone, this is something you should understand. These are all very, very base fundamentals. Clear? What if you want to control that? You're not comfortable with 25%. You want 30%. You want 40% or 60%, whatever it is. So you can explicitly define it. Strategy, type rolling update. Why type? Does it mean there is one more type? Yes, there is one more type, but it is not at all useful. I'll tell you that type. The rolling update is a default strategy type. So strategy means your deployment strategy is what? Here my deployment strategy is rolling update deployment strategy, which will perform in a rolling fashion. So here 50% means 50% of the pods will be created, and other 50% once they are healthy, it will be deleted. Again 50% created. So 2 iterations, all of your pods will be running with the latest image version. Now you can put 10%, then it will do 10. If you are having 10 pods, if you do 10%, one pod will happen. So that time it will become little time taking process. Okay. So rolling update. There is one more type of strategy which is called as recreate, which is not much useful at all. So here the strategy type will be recreate, but you don't have any percentages here. Why you don't have percentages? Because recreate means it will delete all at the same time and create at all the new at the same time. Recreate will actually end up having downtime for your application. Okay. If you feel that, okay, my application is down also, I don't care, then use recreate. But I don't think no one will want that. But for some reasons, this is also useful in some situations. Then you have recreate, but very rarely people use this. Okay, that's why this is also not the default type. Recreate means all of them will be first thrown out and then brought in. Okay, which is something not useful type. Clear? So all the 3 examples are there here. So the deployment object is a fundamental object you'll always create. Okay, for each application you'll have one deployment YAML in your company. Okay, so if you're having 10 applications, you'll have 10 YAML files, and again the whole management of YAML files is again a different story, right? You'll end up having, slowly you'll be overwhelmed with the YAML files. Okay, once you start going to microservice architecture, managing them is also an important thing. But deployment is this. Now let's see the kubectl get deploy. Everyone understood that logic, right? Kubectl create logic, the command we brought in, which is not much used, okay, at all, until unless you do this kind of testing. Okay, so some people write, see, it is easy to remember, right? I think this you can remember, right? Kubectl create deployment name -- image. I don't think this is very hard for you, right? So some people, what they do, instead of going to Kubernetes website searching, they'll create this right away. It'll create. Afterwards, inside they'll change the image name and they'll apply it. So okay, let's remove the deployments. Kubectl delete. And what is the best way of deleting an object in Kubernetes is through the YAML file you created. So don't try to directly delete them, okay? Because sometimes there may be some associated objects you will not properly clean up. So the efficient way of creating Kubernetes is a YAML file. Efficient way of deleting Kubernetes object is also YAML file. So always define whatever you want in the YAML file, apply that YAML file. Once you don't want that, you do delete -f and the file name. So it will be proper. So the clean way of creating and the proper way of deleting them is through the YAML file only. Okay. Yeah, within a minute, this also will go. Now, once you're done with the deployment, what are the next objects we can see? Did we cover namespaces? The namespace also a very fundamental thing in Kubernetes. Okay, I did not come to namespace because the moment I tell namespace, it will become overwhelming. So now let's step back a little bit and think about the. See, when you have one Kubernetes cluster, right? What you want is a same Kubernetes cluster you want to use for multiple applications. That's normal, right? Because you can't create one cluster for one application, then you're gone. You'll really go crazy that time. And also it is a huge amount of resource wastage also. Sometimes if you don't plan properly, Kubernetes will end up taking more resources. So now what you'll do is your company will have 4 environments, right? Dev environment, integration environment, what you call user acceptance testing, UAT environments, and a production environment. Sometimes some people will also have pre-production also, like 4 5 environments you'll have. That's all fine. Now when you have so many environments, right, obviously we'll have 5 10 20 30 based on a company size, you'll have applications. So when you start deploying the application, if you want kind of a segregation, right, or you want to segregate them, is it possible in Kubernetes to create compartments? Like in train you have compartments, right, like same compartment like that. So in a bogie you have compartments, right, like that. Is there a way to virtually break my Kubernetes cluster into multiple virtual clusters? Yes, it is possible through the namespaces. The Kubernetes namespace, right, is a way to virtually, Microsoft is paying a lot of money. So namespaces are intended for use in environments with many users spread across multiple teams or projects. Okay. So the namespace is a way to divide the cluster resources between multiple applications or multiple users. Okay. But most of the time, the applications will come. So you're having 10 applications: sales, finance, customer care, what you call business development, or user facing, or account section, right? Every company will have at least 30 applications. That's a minimum. You join any company, you'll have 30 applications. The more bigger company you go, the more number will come. You go to very large company like Amazon, you'll have thousands of applications. But yes, there will be thousands of people to maintain. But yeah, based on the company size, you'll have. But if you go to banking project, right, you'll have 30 applications. Means forget about these very largest companies. But you go to any standard company, right, you'll have 30 applications. That's a standard. So now these 30 applications, you want to compartmentalize them. You want to create a kind of a virtual cluster. So the namespace are intended for use in environments or creating here where you have multiple applications sharing the same cluster. So the namespace is very much useful, and the namespace will span the entire Kubernetes cluster. So what does that mean? So you have a Kubernetes cluster. So we already spoke what does Kubernetes cluster mean. A Kubernetes cluster means a master server, and you may have 10 worker. How many worker nodes you can add to a master? No limit. But theoretically 5,000, but you can still add more also. But 5,000, after 5,000 you'll start getting some performance issues. But you can add 5,000 worker nodes to a master node, okay, and still expect it to work flawlessly. Once it goes beyond 5,000, some performance issues will come. But I don't think you will add 5,000 servers to one cluster. Okay, so that theoretical limit is also like 5 lakh pods. So you can create 5 lakh pods in one Kubernetes cluster and still expect it to run flawlessly. After 5 lakhs, yes, little bit, but 5 lakhs means, right, number itself is like unimaginable. So, but still it is possible. But I'm telling, out of the box, you don't do anything. That is the limits. But once you do little bit performance improvements, you can go to a million containers also, like 10 lakhs, 20 lakhs, 30 lakh pods. So this is my Kubernetes cluster. A Kubernetes cluster where you have a one master connected to worker nodes. Until unless your master is not connected, then it's not called Kubernetes cluster. Okay. Now this is cluster. And I told you this is my API server. Okay. This is my worker node. Okay. These are my worker nodes. Okay. 1, 2, 4. There are 4 worker nodes. This is all good. And I always told you, whenever you create a pod, you will first talk to API server. And API server will do all that thing. But finally, what happens is your pods will get created in your worker nodes only.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Which we know, right? Your pods will not get it in your master nodes. Now this is what happens. Now the namespace means it is kind of a small virtual wall you have like this. Okay, so this is a namespace. This is one more. You can create as many number of namespaces you want in a Kubernetes cluster. Okay, So the namespace will span the entire Kubernetes cluster worker nodes. So once you create a namespace, it is about you segregating the resources. So this is sales namespace. Okay, this is finance namespace. Like that, you can have namespaces and deploy your applications into that namespace. Okay, now what is the use of this namespace? The first thing is people will get right away question is like, what if the pod in one namespace can talk to this? You can talk out of the box. There is no restriction. A pod in this namespace can reach out to this namespace and communicate. Nothing is blocking. But if you want, you can enable. But out of the box, uh, there is no restrictions, communication restrictions, network restrictions. Nothing is there. But it is a way of easy management because you can manage the namespace in an efficient way, and also you can allocate resources. But out of the box, the pods can take as much RAM as they want, and you also can put restrictions on a namespace level. So this virtual space, right, you can restrict how much virtual amount of capacity I can give. For this namespace, I can tell I will give you totally 1 GB RAM and 1 core processor. So what does it mean is all the pods which are being created under this namespace, right, will be having only this much maximum amount of resources to be taken from the any of the workload. This is combined, not for per server. 1 GB RAM should be shared between all the pods in all that namespace. So you create namespaces for efficient resource management. Okay, and it is also very easy or clean to remove. For example, you want to delete the whole application, you delete the namespace, every object will be automatically deleted. So that is also one good thing. When you want to do some experimentation, you can experiment in a different namespace so that it will not make any problem to your actual useful namespace. And you can create namespaces, you can control namespace resources. You also can further control. For example, you only can create 2 pods. I can put restrictions also on the amount of resources we can create on the namespace. So once I create a namespace, I'll tell maximum 2 pods only can create in this namespace. That's all. If someone will try to create more than 2 pods, it will tell, sorry, I will not allow you to create. So resource level restriction, object level restriction. Okay, how much can be maximum RAM can be given, everything you will have restriction. So that what happens is your Kubernetes will be starting to be called as a multi-tenant. This is a very this is a term not many people will use always, but when you go to starting extreme cases, you'll see a multi-tenant. Multi-tenancy is a very big word in the IT industry. That's not a simple term, but if you want me to tell in a very simple English, efficiently managing the same resources for multiple independent, completely different people or different applications, right? So this is sales application, this is finance application. Sales application developers are separate, everyone is separate. Finance application developers are separate, everything separate. But they are sharing the same resources, but still I provide them a level of isolation where they don't fight each other or kind of network, anything can be there, I can still control. Okay, so when you start creating namespaces, dedicatedly providing to a set of users and ensuring that they all are properly managed, that is called as a multi-tenant Kubernetes. But again, it is there. If it is possible, it is possible, and you always do multi-tenant because in your company you will not have one application, right? There will be so many applications. So when you're doing that, you call it as a multi-tenant Kubernetes. Okay. So you can create as many number of namespaces you want, and then you can control resources, you can control everything. Okay. Okay. So now let's see how can you create a namespace, how to switch a namespace from one namespace to the namespace. Okay. First thing is kubectl get namespace. Yes, namespace again, everything is an object. So that simplification will always have. Kubectl get namespace. Out of the box, when you create Kubernetes cluster, you will get 4 namespaces. The default namespace is a user namespace, means you will be already directly landing in the default namespace. You see, no resources found in default namespace. So when you get command, it will not do get from all. It will only get from the details from the namespace it is currently residing in. And what is a default namespace you'll be directly putting in is a default namespace. So if you want to see the resources of another namespace from one namespace, that is when you'll do kubectl get pod -hyphen namespace kube-system. The kube-system will have all of your management pods. And where do the management pods run? In which server your management pods will run? These all pods you see will be running on your master node. Okay, so will be running on your master node. Okay, and the default is our, and the Q public, Q node release, these are for future purpose. So there's nothing running here. Okay, it is for some future use they created, but it's not, that future use did not come. Okay, so default application related kube system, your Kubernetes cluster administration pods. Okay, so by default these are the 4 you'll get. You want to create one namespace. So kubectl namespace is so small you don't need to write a YAML file. Okay, but if you still want, you can go to a namespace folder. The YAML file will be this 4 lines YAML file. API version, kind, metadata. There is no spec for namespace because it's a very high level object. It does not have any specification. API version, kind, namespace, that's it. To create a namespace, these are the 4 lines you'll ever need. Okay, so if you want to create a namespace, you can do kubectl apply -f namespace or create namespace name. So lot of time people will do this also, because this is enough, because it will not have special options also to be given. So either you do like this or you do kubectl with your standard way. Okay, and always learn YAML file. Don't learn the create command. It's not good. So kubectl apply -f namespace. That's it. It has created a new namespace for you. Now you do kubectl get namespace. Now you'll see one more 5 namespaces development. Now, but you're still in the default only. You need to switch yourself from one namespace to other namespace. Okay, so once you create a namespace, how do you switch? Switching is important. So to switch from one namespace to other namespace, you need a context. So you can't directly switch from one namespace to other namespace. You need to actually first create a context, map that context to your namespace and switch your context. So once you switch from one context to other context, whatever the namespace is associated, it will switch automatically. So to switch from one namespace to other namespace, you need to have a context and you need to switch the context. Then that automatic namespace will switch. So default namespace already has it, but we need to create our own context. So kubectl config set -context. Your context name can be anything. It doesn't need to be your exactly equal to your what you call I can tell dev, okay, or develop, anything. Your context name can be anything. It's not need to be exactly same as your namespace. So I am creating and mentioning my namespace and cluster, my cluster name. So these are the details. Okay, cluster namespace user. Now context is created. Again, if you do kubectl config get context, now I created one more context. So earlier there was only one context, but for the default namespace, now I created one more context. My context name is develop. So I'll do now kubectl config use -context, and then I will root develop. So if I am using this context, means I am using the namespace automatically. Now, if you do kubectl get pods, now the difference, last time when you ran kubectl get pods, we got no resources found in default namespace. Now we are in a no resources found in development namespace. So this is something you should remember. Context, get context, set context, use context. So if you want to switch from one namespace to other namespace, you need to set a context and use the context. Okay, and switch from one namespace to other namespace. And how many contexts are there? Get context. Yeah, this is the only way. There are no other options. This is how you actually switch from one namespace. But the other question is, what if I want to create object in other namespace by sitting in a different namespace? Is it possible? Exactly possible, and also very simple. So for example, if I do get pods, obviously it will check in the default namespace, but we also can do -f namespace default. So it is telling it now, it is checking in the default namespace instead of your current namespace. I am telling how many pods are there. Can you check in the default namespace? Now this is something I can know. What I'll do is I will do kubectl apply -f namespace. Now what is happening is I am actually applying this YAML file on this namespace. Okay, so yes, you can either create you can actually create object or multiple objects which are part of your YAML file on a different namespace. Now if you do first thing get pods, obviously what you'll get now, if I do get pods here, how many pods should I get? So when you do get pods namespace default, that time you'll see that pod. Okay, so you still have a pretty much control of other namespaces when you're in your namespace. Okay. The only thing is we will not do all these kind of things. Why? Because there is a very basic way of handling all of this by mentioning your namespace in your metadata directly. That is how we do in enterprises. We don't do all these games. I'll tell directly your namespace development. So irrespective of wherever you run that YAML, it will always get deployed to this namespace only, right? So now your team member will deploy from system namespace, lease namespace, it doesn't matter, because inside this YAML, it is told that you should create in a deployment. Okay. So that is what we do in companies. We directly define the namespace inside our YAML only. No headache. Okay. No, nothing to worry that, okay, where it is creating, where I'm running, that all will be eliminated. Okay. Okay, now let's see another object, daemon set object. So what is this daemon set object? The daemon set object is also one more object type, which is higher level object. Okay, the daemon set has a specific use case. So deployment object, I told, right, that is always used for all our applications. But there are sometimes some requirement for you where for each worker node, you only want one pod to be created. Okay, how does it work? You only want one pod to be created per each worker node. So you have 10 worker nodes, you only want 10 pods. Then you have 20 worker nodes, you have 20 pods. Why do we need even this special requirement? Is there are some kind of applications we deploy to our Kubernetes which are related to monitoring, okay, or your logging, right? Or any application where there is a dependency, or where there is a requirement that only one instance should run, only one instance should run on one server. Okay, that kind of things will be there, right? Because there are so many different situations. So in these kind of situations, what you need is you want one pod for one worker. You don't want to deviate from this logic. This is standard. In that situations, the daemon set object will be used. When you create a daemon set object, you don't need to tell replica sets how many things. What it will do is it will go and check. Okay, this server has 2 worker nodes. So I'll create only 2 pods, one for one worker node. If there are 20 worker nodes, it will automatically create 20 pods, one for one worker node. So daemon set is in this situation, when you have a requirement that you want to create only one pod for one worker node, nothing more, nothing less. And the daemon set is also intelligent. Tomorrow you add 2 more worker nodes, right? It will automatically detect them and go there and create pods without even you asking it, because it is an intelligent object. So tomorrow 2 more servers also get added. You don't need to specially tell daemon set someone is there, go, nothing. It will right away identify them. Okay, they are also 2 worker nodes. Let me also schedule 2 more pods there. Okay. So in these 3 specific situations, the daemon set will be useful, and it is common sometimes that you'll also end up using daemon set. Now, the daemon set object will look a lot similar to your deployment object. The only thing will be missing is your replicas. If you try to give, it will be error because there is no replicas option for this guy. So kind daemon set, label name, metadata name, and then match labels. Labels should exactly match what is your pod name. Oh, sorry, what is your container name? What is your image name? Okay, since we do not give replicas, but what we should understand is kubectl get pods. There are no pods. Okay, so kubectl apply -f daemon set.yaml. Now kubectl get daemon set. So there is one daemon set created: desired, current, ready, up to date, available. It will have little more, but they are again simply same. Desired equal to what you desired, how many are running, how many are healthy, how many are available. Within a couple of seconds, everything will be 2. Okay, good. Now, if you do kubectl get pods -o wide to see little more detailed information. So they are uniquely created under this. You will not see both greater than 57 or both under 125, one on each. Okay. So in these situations, the daemon set will be useful.
The next service which we will discuss is what is called node port. So practically in node port, what you do is you still have a pod running. It is internally running on port 80, no problem. But I want to access it at a port on the node level. Okay. So in this case, I will be able to access it through Chrome also. Of course, I will need to use public IP of the node, and I will specify the port. The only problem is this port cannot be in the earlier ranges. It has to be in the higher ranges of 30,000 to 32,000 some number. Okay. So they come from this range. Only those ports can be used at the node level. If you will create a service of this kind, practically you will be able to access it from Chrome also, because you want your service to be exposed. So now if I will expose the same service on using the cluster IP concept, let's see what will happen. Okay, this is the whole power of loosely coupled architecture. There is a node port service file already created. So see what I'm saying. It is again having the 4 top levels: API version, kind, metadata, and spec. Selector stays the same, name is something else, but type here is node port. So that makes it service. And you see one additional things get added. It is 31,000. And there is the same port, target port. Okay, they stay, doesn't matter, but mainly we are interested in this node port. So I am saying I want it to be accessible on 31,000 port. So if I will run this kubectl create -f node port service, let's see, kubectl get service, you will see a node port service gets added and it is on 31,000 port. So first let's stick to 31,000. So let's take the node IP address, public IP of node, which is 54.221.122.223 and colon 31,000. So I will, and you see hello from 41S888. Let's refresh this. If this changes, you see 8MN4M, it still stays 8MN4M. Okay, now it is somehow not moving from it. Okay, there is maybe some port affinity or something. I can open an edge or something and you will see maybe a different. Okay, let me open an edge. Let's try. You see, it is 41S88. If I will open incognito window, you see it is 8MN4M. So basically, I hope you're clear. This is how your pod got exposed in outside using node port service. So in node port service, what happens is you have pod running, one or more. Internally, they are using 80, but in this case, I connected it to 31,000. I could have connected it to 31,010. By the way, if I don't define it, it automatically assigns a port also. But out here, I'm assigning. And in this case, I can use the external IP of node colon whatever this port. Okay, this is another level of service. What it does is it actually encompasses and gives you. Now, first of all, if you want to practice this kind of a service, external load balancer, it will not work in your local installation, because problem is in your local installation, you don't have anything which is running which can support this. In this case, actually, you get an external IP configured. So this is something which can be only done in a managed kind of a service. So either EKS or AKS or GKE kind of a platform is required to practice this load balancer service. I will show you that if I will try to use this kind of a service, because it uses the external load balancer concept, it needs a publicly routable IP, and we don't have that kind of a service running in our environment. This service will stay in pending. But the moment I will start the same service in the EKS installation that I have, you will see the magic of it working and you will be able to access it. Okay, so first let me show you what it looks like and whether it works. So we will try to initiate this in our environment first. Okay, so there is already a file which is available for this load balancer. Now in this, the type changes to load balancer, nothing else. And it doesn't need, of course, you can put a node port if you want, but technically I'm not interested in node ports. I'm not putting, but I have put a port. So let's see if I will do this kubectl create -f load balancer service. So in this, if I will go and look for service, you will see there is an external IP which is pending. Okay, others anyway had it none. This needs this IP, and how much ever you wait for it, it will stay pending only. Okay, because technically there is no service of external load balancer which is running in my environment. But the same thing, you will see the behavior will change and you will get a DNS name behind the scene, which will be an IP, but I will be able to open that from anywhere in the internet. Okay, of course, a further DNS setting may be required, but technically this service actually cannot be practiced. And out here, I will install the load balancer service and let's see what happens. Okay, so first of all, let's go to website and I will go to Kubernetes. Now, when I am on this session, guys, please be aware, I have moved to what? This is the Cloud Shell, but it is the EKS service. Okay, be aware. So kubectl create -f load balancer service. Okay, kubectl get service. You will see immediately you get this kind of a IP, a long one, which is ABF1D, not a very user-friendly name, but US East 1 elb.amazonaws.com. So practically, I can curl this. Let me take this, copy, paste, colon 9999. Okay, it takes some time to do. Okay, it will not do it immediately, but technically, let's wait for a few minutes, and I will try to open this here, colon 9999. Of course it has come, but the service is still being set. Okay, so let's give it few minutes. I will do curl. Let's put it on watch. Could not resolve host. Yeah, this is also working. So now it's volume, secrets, taints and tolerations. Okay, this is the topic that we wanted to cover for today. So first is volume, but technically volume is like a network drive kind of a thing, and there are like maybe 10 or 20, 30 different kind of volume implementations in Kubernetes because it's open source. So a lot of people support it. Again, there is a request for elastic block storage, which is a AWS concept. We will look at this volume, which is more persistent volume. So this has things like PVC and PV, persistent volume claim and persistent volume. Please be aware, guys, these are relatively advanced topics. Of course, we will start with something called empty dir. Okay, this is a default kind of a volume. It normally has a thing till your pod is running. If you have multiple pods running, they can access a volume which is common between them so that they can share things. Okay, so this is the concept of what is called empty dir or empty dir, whatever you want to call it. So we will look at first this volume, but before that, let me try to just give you an analogy, guys. Remember, volume is a concept like if you are aware of your enterprise world. Normally, if you know whether a pod or something or a Docker container, they have a volume of their own, but the moment that pod or container gets destroyed, whatever you did there, it gets deleted and new container will have a new file system. But if you want to retain beyond the life of a pod or a container, you need a concept of volume. In an enterprise world like my organization, which I was part of, I usually used to see a drive like a G drive, and there was K drive and whatever I have mapped, they were network drives, which were, even if my laptop gets formatted, they stayed there, right? Because technically they are not on my laptop local hard disk. If I format this PC, the C drive data is bound to go. But any network drive which doesn't reside here technically stays. Those the same concept is of volume. Now, just like in services, you have load balancer, you have node port, you have thing like a cluster IP. Similarly, there are different implementations of volumes. The simplest volume is that is which is local to a pod, and the life of it is as good as pod, but it is mainly used to share data between two containers running in a pod. I think there was a request where people said, okay, how do we run two containers? So I will simulate a scenario where we will create a pod which will have two containers inside. So what I will do is, in general, in a pod, we saw only one container. I will start two container in pod, and using the concept of empty dir, which is a very strange name, but it is a local volume kind of a concept, which is inside the pod only. We will declare something and we will show that you may do change in this volume at one place and it will be visible to another container. Okay, this is what we will see. This is empty dir kind of a volume. In general, containers have their own file system. They are not accessible across. But as pod has an implementation of more than one container, and if you want to share, you can consider create a volume and this will be shared across the containers. Okay, it has a very specific implementation requirement only when you want it to be shared across containers running in the same pod. Okay, let me open the document. So in this case, we create a volume. So how do we create this empty dir volume? Is everything we are using only declarative way. So we create a volume which is called, let's say, whatever name we want to give this to volume, and this is of empty dir kind. Okay, so this is how you can declare a volume. Okay, so this is a YAML file which has multiple kind of things. I am looking at it, so you see what it is. So this is the way to declare an empty dir kind of a volume. And this is YAML syntax. Okay, and technically when you start, so again, this has API version, kind, spec, and metadata, the same for high level things. It's a pod, right? Because the kind says pod, and the name of the pod is shared wall. Now you see, so you have one container called C1, one container called C2, and that's it. So practically two containers. So both are CentOS 7, right? And how do you implement the volume concept is using this declarative way, volume mount, and you give it the name and you say it is mounted at this path. So what is happening here? Let me graphically represent this so that it will be clear. So what we are doing here is, let me represent this. So there is a pod. Inside this pod, there is two containers, one of them called C1, one of them called C2. I created a volume of empty dir kind. I called it exchange. Okay. So this is some place here. And in C1, I am mounting it at a path called /tmp/exchange. And in C2, I am mounting it at a path called /tmp/data. Okay, so let's see what will happen now. So I will try to use our own thing just to see if it, or maybe it is better that I practice this on our cloud shell, okay, which means EKS. Let's try it here. Let's see, it should work here, okay. Okay, it is still coming. Okay, by the way, no harm in trying it here, okay. I think this should work here also. So let me try it here. So I will create a file from scratch. I think empty dir is possible to practice here also. So I will take this wall.yaml, and in this I will copy this whole text which is ready made. So practically I put this here. So again, guys, there are some commands. I would like you to ignore it because this is a CentOS. So I want it to be up for 10,000 seconds. So I'm doing it because otherwise it will go down. So I have used some, again, I've taken Intellipaat help to kind of see what kind of demos they wanted. Main important is this volume mount at this point. In this container, volume mount at this point. And this is the definition of volume, which is of the type empty dir. Okay, so let's see. It's a self-sufficient file.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So I will write and quit, and all I will do is kubectl create -f wall.yaml. So let's see, kubectl get pods. So you see share wall is coming up. It is 0/2. Till now you always see 1. So what means 0 means 0 ready out of the 2. Okay. So let's do again. And now you see it is 2/2.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this means both the pods are ready. Of course, they are being represented by this, but it's two containers. Okay, both containers are ready. Till now, you see always it was 1-to-1, but this is how you will see if it is two containers inside one pod. Now in this, let's see where is it running on Docker. Okay, this particular pod. So let's see Docker PS. You see both of them started 54 seconds ago. So remember, these are two containers. One of them is this, one of them is this, and they are both sharing the volume inside the pod using empty dir concept. Now, technically, we have always been interacting with containers. But now, guys, for a change, I will interact with the containers through the pod way. So let's see what changes in that case. So first of all, if you are using it Kubernetes way, so the command will be kubectl. Now, the problem is it will look very similar, but technically, let me show you what I'm doing here. So I am saying kubectl exec instead of docker exec. This stays the same, and I am giving it the name of the pod. And because it is a pod which has two containers, and when I'm executing, I have to connect to one of the containers. So I am saying -c c1, and then I'm saying dash dash space bash. So this is a very similar command. If I wanted to fire it using Docker, remember what will be the command? It will be something like Docker exec -it. Let me pick up the first container name, the C1, and I will say bash. So if I run this command, remember this is the Docker imperative way to connect to this container. While if I want to connect it Kubernetes way, I will do kubectl minus this. Both of them will reach exactly the same place. Okay, let me show you. I do this and you should see a prompt which is referring to the container one. Let's give it some time and I will run this command also. So out here, this is faster for sure. Kubernetes takes its own speed time, but I am on the root at share wall. And out here, okay, this will not work from this machine because this is master. Okay, I need to connect to node. So somehow, but I'm not sure whether worker will work with kubectl. I doubt you can run kubectl from there. Okay, this will anyway not work, right? So this should work from here. Okay, so practically I'm saying exec -it share wall. That is strange. Let's see whether kubectl is connected. I think I will need to shift to EKS because out here the configuration is not perfect for volume mapping and all that. Okay, so let me try it once more. Otherwise, I will shift to the EKS because that is where it will work for sure. So let me see if I say kubectl get nodes. Yeah, so I see I'm able to access this. Kubectl get pods, kubectl describe pod share wall. So everything seems okay. It has two containers, container 1 and container 2, but somehow still when I say kubectl exec -it share wall dash dash bash, it says please choose. So C1 default container C1. Okay, this is stuck. So let me try once more. So see kubectl exec -it share wall -c c1 dash dash bash. If this is not working, there is a problem. So let me shift here. Okay, let's see what is the case here. Kubectl out here, I think I already have this pod running. Perfect. You see share wall. I started it exactly the same way, but out here that command will work. Okay, so kubectl exec -it share wall -c c1 dash dash bash. Let's see if this works. Perfect. You see you have reached there. So now in this, let's see in container 1. So it is a temp exchange. So TMP exchange. Now this has some file data. It's fine. I will remove this for the time being. I will create some file. Okay. Let's see if VI works. So my file from C1 and I will put some data here. This is data coming from C1 container. Okay, fine. So I have saved a file in the path, which is basically mounted temp exchange. Now I will exit out of this container. Let's connect to the other container. How do you think we'll need to connect to another container to see whether I'm able to access the same file from there? C2. So let's see. So let's go to temp data. What should I see here? The same file. You see, cat, this is data. So this is the whole point, guys. In general, none of the other places are like this. Okay, technically, if I will go at some place which is not mounted, let's say I will do, I am on the root directory. I touch a file here. I come out of this. I go to container 1 to see whether this file is existing. So let's see. I will go to CD. It goes to root. I do ls -lrt. Do I see one? No. Why? Because remember, at the end of the day, considering the Docker principle, both of them have their own file system of containers. Okay, a logical file system inside the pod. But if you want to share, you can do this setting of volume mount. And this is an empty dir kind of a volume which is inside the pod. And practically you map it at whatever path you need and you are good to go. I hope this is clear. Okay, so this finishes the kind of a demo of a empty dir. This is for a very different use case, which is when you want to share data between containers running on the same pod. It's a very relatively very low level volume mapping. So in this case, all you can achieve is this. But if you need something like this, okay, which is, let's say you have pod. So there is pod 1 and maybe there is a pod 2. And they may have container inside one. Okay, so both have container inside it, whatever container. Okay, and you want a file system which is outside the scope of pod, and you are able to refer to it this way. Now this is very different. Okay, this needs some implementation of NFS or volume or something. So out here, one of the solution for AWS is what is called elastic file storage. This is a network volume kind of a thing. So you can implement this, which can help you share data between two different pods. Let's say whether the reason for it is database could be one of the reason, the DB tables or whatever other use case you have. But this is a very different setup. It is slightly more complex. In interest of time, I have already done setup of it. I have prepared a document of it. You can try it, but it is relatively more complex to set up. Empty dir can work only within this level. Okay, somewhere here. This is empty dir, while this is something which can work across pods. Okay, so let's see. Let me open the documents for what is called persistent volume. Okay, so creating a EFS persistent volume kind of a setup. So this needs slightly different setup. So practically, guys, this takes help of a service which is called EFS. Okay, so technically you will need to go look for a service called Elastic File Storage. Okay, this is a file storage service for AWS. You will need to create one service here. You see, technically I have already created this service, but creating a file system is like you give it a name. You choose some kind of a virtual cloud. I may choose my EKS cloud because this is on which my EKS cluster is running. And practically you may choose regional one zone. So not very complex setup, but you will need to choose this right. And eventually you will get a what is called a network file storage. It's a EFS. Now, once this is set up, you basically have, let's say, this part ready. Okay, I've created a mess here. So let me just do some cleanup. So let me start again. So practically what I have done is right now I have created this in EFS. Okay. Of course, when I'm starting pod, there is still a relatively complex setup that you can access this volume. Okay, because this is outside. Okay, it is not that straightforward like empty dir. Okay, it is relatively much more complex implementation, and you will understand why. Because this is totally a separate service. Security group will get involved. A lot of things will get involved here. So technically you will need to do a lot of setup. It's a relatively very advanced concept. It is not that easy to implement, but overall you will need to look at networks. You will need to set up the right security groups. There is a concept of what is called something like mount targets, and it is available. So you will need to look for this kind of a documentation. Let me show you something like AWS EFS provisioner or something. Okay, so let's see. Yeah, so I have used this, but practically it is, I have mentioned all this. Okay, so technically you have created, so out here I have mentioned this one sentence: create a EFS and see to it that it has same security group as EKS cluster, because it has all those steps. After that, there is a lot of steps that are required to practice this setup. So I am downloading some kind of a repo, and I am doing kubectl create -f. Some kind of a role-based access control is required, guys. This is very advanced topic, but in interest of if people wanted to understand, I'm doing. And there is a very long YAML that you will see here. Okay, it will go on and on and on, because to implement this, you need this. So technically it is going all the way till here. What all is getting created here? Let me show you. There is a something called PVC is getting created here. Then there is something called storage class is getting created here. Something called, I think this is a deployment is getting created here. A service account is getting created here, and something called a config map is getting created here. Okay, so we are not covering all this. But because EFS is required, practically I have taken this effort to set this up. Only thing you need to change in this is technically this name, and of course, if your region is different, okay, let me mark this as red so that you are aware what you need to change. If you remember, I discussed a repo called GitHub P Benival, and there was a repo website. In this only, I have created a folder called volume, and in this I have put those. Okay, so the earlier one, this v1 is practically the empty dir. Okay, so the whole thing I have put here, but practically that YAML is available to you. The further instructions will be available in my PDF. So the same way for persistent volume, whatever I discussed, all this is mentioned here, but be aware you may need to change this and this depending on whatever EFS you created. How do you reach upon this is when you will create that EFS service, you will reach this kind of a name, fs dash something. So what you will need to do is take this generated name and go and change it at this place. And in general, if you are not working in North Virginia, which is the default mostly, you will need to maybe update your region name. These are the only two things you need to change. That is why they are highlighted in red. Rest of the things are standard. So you can follow this process. Okay, so technically you can understand what is happening here. So you will need to repeat this process. I have already done it for you so that we can directly practice it. After this, what you need to do is you technically will need to run this kubectl create -f, whatever the name of this. So I already ran it here, because of which you will see that you practically have this. Let's see, kubectl. Okay, let me come out of it. Kubectl get pods. So you see there is a pod which is running. We created a deployment. It is called pv deploy. So let's see, kubectl get deploy. Yeah, so you have this persistent volume deploy. So technically how many pods it has? Only one. Let's see, kubectl get pods. So this is the deployment pod. Okay, so let's see if I will connect to this kubectl exec -it. Let me take this pod -- bash. In this, let me show you, we created this now. So let's see if I will go to temp persistent. I see something here. Okay, this is some kind of a file. Okay, it is some content. I put hello world. I thought I put hello world. I will put another content. Okay, so let's say echo new hello world in live class greater than new file. Now let's see how many files do I have. But technically, remember, these files, even though they look like in the file system of the pod or the container, they are getting stored inside this. Let's see. I don't think you will see the content here, but technically I can tell you that they are getting stored here. Okay, so technically it is getting stored somewhere here. It will be proved by fact that, let's say, if I will go out of this container or this pod, and technically if I will delete this pod. Okay, so let's say if I delete this pod, the pod name was pv deploy. Let's see how the persistence of data works. So the moment I will delete this, technically a new one will get created. Okay, let's see. And in that, if I will go to this path temp persistent, it takes few seconds to delete it, but a new one will get created and we will see to this path. And because of this pv concept, okay, you should see both files at that path. Okay, so it is deleted. Let's see, kubectl get pods. So you have another one running since 40 seconds. So let's say kubectl exec -it, copy, paste, bash, cd temp persistent. You see both the files. So this is like a perfect example of database. Even if the pod gets deleted, we start a new pod and the same happens because of the declarative way. So it doesn't matter if this pods get deleted, if another one will start, that will also refer here. So whatever is the mount path, which was temp persistent, if you will go here, you will see the files that you have. So this is a perfect example. If your database gets deleted, a new one gets started for stateful application, the same mount will happen. And because it is a network file system, you will see the same files. Okay. There is a connected concept like volume, which is called secrets. Okay. So it is very similar concept to volumes, but volume mostly can have data. Secrets is mostly if you want to encrypt your data. So it's a very similar concept. Rather than creating a volume, you create something called a secret. And that secret can be referred by your pod whenever it needs it through whatever value it has. Okay. So in general, your DB password kind of a thing can be used to store using the concept of secrets. So in this, all you do is, let's say if you have some kind of a key, I said this is most secret key. Okay. So let's say this is the value of your DB password or whatever you want to store. You can store it in one file for the time being. And what you can do is, this is a simple text file, so not very safe. So normally you should not store this. What you can do is you can create an entity called secret from file and do this. After that, you are welcome to delete this file. Technically, you rather than from file, you could have directly put this text also. Okay, but just to show you one way, I looked at Intellipaat document. They talk to declare it this way, so I kept it just for the sake of consistency. After that, when you are creating a pod with the name whatever, so when you create a pod, you want to consume this secret in your pod. So what you will need to do is, you will need to do volume mount, very similar way to that, but it's a volume mount which is based on this path. And you see volume is referring to not an empty dir or a EFS. It is basically referring to a secret called API key. So what it does is, it basically gives you access to whatever you stored in this secret. Okay. So technically I have already done this. I created this. This is the most secret key. I created a secret. I can show you where is this secret. Okay. So technically it should already be here. Kubectl describe secrets API key. So you see it has some kind of 19 bytes of data, but it is opaque. I can't see it, okay, directly in general. Of course, there may be some way to see it, but technically it is encrypted data. I don't see it, but whenever I want to refer it, I can create, when I'm creating a pod, I can do volume mount just like a volume, but only in this case, the volume is referring to a secret. So what will happen is, because of this, if I will create such a pod already exists. So I will say kubectl exec minus it. Already I created a pod using this consume sec. Okay, it is here. So I will say consume sec dash dash bash. And now in this, technically, if I want to, I can see where is this API, but technically I will be able to see the content of this inside this pod, okay, by this command, because it is mapped to temp API key. How do I know that? Let's see, where is it mapped? Temp API key. And the name of the file, I know API key text because I only did it. So practically, if I will do this, I will see the unencrypted value. This is the most secret key, because this is the value with which I created this secret. So practically, it's a very similar thing to volume, but it gets stored in encrypted way. That is a high level difference. Okay, so this is technically volumes for you. Okay, and now we will talk about rolling updates, okay, with the deployment. So let's see if my cluster is ready of EKS. I just created another one. Let's see if right now I see it seems to be active. Let's see. Okay, it seems to be 2 T3 medium are running. Perfect, good enough. So let's go to our cluster, which is Elastic Kubernetes Services. And I will go to my EKS cluster. We have 2 nodes there, and these are the 2 nodes. Okay, configurations, fine. So we have everything good. So in general clusters, my EKS cluster, okay, compute details. So let's start it. So I have a Cloud Shell. Okay. In general, we will give this command, which is AWS. In general, it is EKS dash region. Region is US dash east 1. and update dash kube config dash name of our cluster, and name of our cluster is my EKS cluster. So let's see if everything goes well. We are good with it. So perfect. So let's see kubectl get nodes. So we should see 2 worker nodes. Okay, so practically we have 2 nodes. Now on this, let me go to our website and let's see our Kubernetes file. So I will do this deployment. So let's say I will say, let's see our deployment file from last time. So we have pbeneval website version 1. Fine. So let's say kubectl create -f deploy. So basically we create the deployment, which will create kubectl get deploy. So you see there is practically 0 out of 10 ready. Let's see how many pods we have. So we have 10 pods running because our deployment has practically replica equal to 10. Okay. So this is what we did last time. So in general, we are good. So, and we have this. And let's start a service of load balancer kind, because we can do that here. So I will say kubectl create -f load balancer service, which will be connected to the same 10 things. So let's see. So right now, if you will do kubectl get service, you should see your external IP. So let me take this external IP, which is this, copy, take it here, and 999. Okay. So practically this should come up soon, because this is 1, 2, 3, 4 nines. So let's wait for a few seconds and let it come up. Okay. So this is external IP load balancer 999. In general, let's see kubectl. Okay. So you see, by the way, it is already showing version 2. So anyway, we will see what we can do about it. So technically we are on this version 2. Now what I will do is, in parallel, I will go to, let's say, something like EC2 cluster. Let's create another version of this thing. Okay, so what I will do is I will start our one of the, let's say, the master machine. Okay, so I want to start that so that we can create another version of the Docker. Okay, so I will try to show you what we did pictorially. Just give me a minute. Let me start this machine so that we can do that. Okay, so let's see what we are trying to do. While this machine is coming up, let me open a whiteboard just to show you what we are trying to do here. Okay, so technically what we did is, till now what we have done is we have started a EKS cluster. It has 2 nodes practically as part of the setup, and I started 10 instances of our service. Okay, the web service. So basically 10 of them. Let's see where they are running, whether they have been divided between the 2 instances or not. So let's see kubectl get pods -o wide. Okay, kubectl get pods -o wide. So you will see 1 on 82, 2, 3, 4. So 5 instances are on the first node, and another 5 pods instances, 1, 2, 3, 4, 5 are on the second node. Okay, so technically, and why 5 each? Because there are 2 nodes only, right? So if you will see, there are 2 nodes. So basically, if you run 5 pods, it gets divided between the 2. But technically, if you want to change number of pods, let's say if you do replica equal to 5, and if you will say kubectl apply -f deploy, so practically it may give you this some kind of a warning. You can ignore this, but technically if you will see your pods, now there will be only 5 pods running very soon. Let's see. So you see 5 are getting terminated, and what will be left is only 5. So 5 are terminating. So only 1, 2, 3, 4, 5 will be running. Okay, in general this warning can be ignored. Okay, it is not something that will make or break things. Okay, technically it gives you the desired result. Okay, you have 5 running pods. Okay, so right now it is 5 running pods, but we have come here because we want to see now. What we will do is we will do what is called change of version. So we will do rolling updates. So what does the rolling update means? Let's say we get a new version of our image. Right now we are on which version? It is version, let's say 1. How do we know it is version 1? Let's see in deployment. So we are on version 1. So what we will do is we will go to hub.docker.com, and in this let me see if this website has a version 2. So right now it doesn't have a version 2, it has a latest, but no problem. I will do a v2 of this, okay, so that we can change it. But to do that, we will need to access some kind of an environment where I can build new images. So let me quickly start a instance of the master so that I can play with the Docker. Okay, so let's see, because this machine has a Docker. What I want is basically a version 2 of this on Docker Hub, so that then I can use Kubernetes deployment to show that to you. So let's see. Practically, I will need to go to the instances and the master. Master seems to be running. I've taken this 58. Seems to be okay. Let's see firewall. So basically it could be a firewall issue. So let's see what is the kind of firewall that I have here. So on this instance, if I will go and try to see security. So let's see the security group. So we are on this security group. Out here, let's do edit inbound rules. So practically our 22, okay, so it seems to be may have changed. Yeah, so this changed. Okay, so I'm basically changing the rules so that I can connect to it. So now let's see if I will try to connect to it. Yeah, it's working. So now let's see if I have a website here, and in this website what I will do is I will change the index VML, and let's say I will do something like hello to Intellipaat DevOps batch of, let's say we change it to, now we have reached month of November. Okay, so I will call it November 29 from new version, and we will call it new version 3. Okay, so I will jump to 3. So with this, what I've done is I have changed this, and let's say I will say docker build -t p benewal / let's see what is my image in hub.docker.com. It is website. So I will call it website v3. Okay, so let's call it v3. Okay, I didn't give a dot here. So let's see if this builds a new image. So docker images, perfect. I have this. So I will say docker push p benewal website v3. So if everything goes well, you should be seeing a new version very soon here. Of course, I've skipped 2 just for the sake of it. Doesn't matter. We can keep it anyways. So we have a v3 now. Okay. So now let's see how will I kind of, so what I want is that we have, let's say 5 instances running, 2 here and 3 here. Okay. What does a rolling update means? Out of 5, maybe 1 or 2 instances will be updated. The new instance will be brought up, then another 2 will be brought up, and then few will be brought down. So this way you will not get any time if you will do rolling updates. That is the whole point of the deployment entity. So let's say if I will go to our Kubernetes cluster, and in that I'm going to change the deployment to.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Version 3. Okay, this is how you do. So I will change this to, let's say p benewal website version 3. So right now you see that there is this image. So this should change to November, and this should change to version 3. Okay, without doing anything. All I need to do is give the apply commands. Okay, so let me now open the document which should have been shared with you last time. So in that, there was towards the end, there was something around deployment. Okay, so let's see how do you do deployment. So what you do is basically you say apply -f. So this is how you change your deployment. So I will do this. What it will do is it will start applying this. So it will realize version 2 has changed to version 3. And to see it in action, I will kind of take this. Okay, so let's say record. And the moment it does, let's see how it is doing. Okay, so now this is interesting to see. So there is 3 out of 5 new replicas have been updated. 4 out of 5 and then the old replicas are getting terminated. So without any downtime, what you will see is the moment I will refresh this, you will see the changes in this. Okay, that you see it changed to November, this changed to version 3 seamlessly. So that is the whole point of deployment. Okay, you can see what happened to your deployment. So this is an example of what we call a rolling updates. Okay, so technically if you will run this command, it will show you that there is a new apply. And let's say for whatever reason, this is the importance or the magic of Kubernetes, how it is doing deployments. Let's say if you are not happy and you want to roll back your deployment of production, technically it is as simple as giving this undo deployment command and say you want to move back to revision 1. So which means, let's say this has a problem and the customer doesn't want it. Because you are using Kubernetes, all you need to do is give a command which will say, please revert it to previous one. So if you will see right now, the reverse also happens in general in the same way. Okay, so you will see in general, it has successfully been rolled out. And technically, if I will refresh it now, you will see this changing back to October and this changing back to version 2. Let's see, you see October and version 2. So using the concept of deployment, replica set, and pods, you can do kind of a CI/CD with zero downtime. Okay, so how you can make it fail is, let's give it an image which doesn't even exist. So what I will do is, let's make a failure case. So what we can do to make it a failure case is, let's give it an image which doesn't even exist. Okay, so I will give some image tag which doesn't exist. And I will say to Kubernetes that, okay, please apply this. Okay, so I am saying apply this. So you will see that it will try its best to apply, but in general, if it will not be able to apply, it will say it tried. So 3 out of 5, it is trying to do some updates, but eventually it will realize that this is not a valid update and it will move back to this. Okay, so it is trying to see whether something new comes, but practically it will not be able to do it. Okay, this site should not get affected in general. Okay, if everything goes well, you will keep on seeing the same message. And practically, if you will see what happened to your pods, let's see, get pods. So you see it is trying, but it did an error image pull. And because there is an error image pull, it stops. Okay, so it keeps these instances running. Okay, it has by mistake terminated one of them, which is okay, but the 4 still is running because it is still trying. Okay, after a point, maybe the 5th will come back again. But right now, it is not destroying any further because this is failing. You see, these are various statuses which are coming, and eventually it says error image pull back off, and also basically in general, you will not have an effect on your running business if there is a problem. Okay, so now with this, we have seen enough of command line. We would also like to see a bit of dashboard because there was a specific request. So I have created a document for a dashboard also. So we will right now try to work with dashboard, but dashboard first of all needs installation. Okay, so technically installation of that, in general, it needs some kind of a setup. So you will need something like this. Okay, I am not going to do this on the EKS cluster. For this, technically, I already have a running, let's say, worker and my own worker and master node. Okay, so I would be using that to practice it. Okay, so technically, there are 2 installations that I have. If you will see right now how many EC2 clusters I have, let's see. So right now you see 5 instances. So practically what I have done is these 2 instances, the T3 medium, they are part of my EKS cluster. And I have created some kind of a temp master and a temp worker node to kind of practice it on my own installation. And this master is purely for Docker. Okay, so technically, of course, you can play with the EKS also, but remember in EKS, you already have a pretty rich cluster functionality. So dashboard is not a thing which you will normally be doing, but for your own installations, if you want a dashboard kind of a feeling, you can do that using this. So let me connect to the master of mine just to see that if it is working. So right now I'm connecting to the my own administrative master. Okay, so let's see if I will go to this master and take this public IP and let's try to connect to this master. Okay, if we are able to connect, let's see. Yeah, seems to be this master is getting connected. Okay, so this is done. So let me open the next document, which is the dashboard. So how do you create a dashboard is, after looking through a lot, I found this that you can do. So there is a full-fledged kind of a implementation available here. It is not very popular thing these days, because if you are doing EKS and all, you don't need this. But technically, you have something called a GitHub Kubernetes dashboard. Okay, so it has various things. I will just show you. So namespace is very much like a folder concept. By default, everything that we create is created in the namespace called default. But if you want specific installations, I have installed all the things of the dashboard in a namespace called dashboard. So it has something called a new namespace creation. You have something called a service account getting created. You have a service getting created. You have secrets getting created. So it is a pretty complex setup. You have a config map, you have a role. This is the reason we normally don't cover it, but because there was a request, I'm trying to show you. This is a ready-made file available on GitHub. Practically, there is a cluster role binding, there is a deployment and all that. So to create this dashboard, these are all the kind of things that you will need. Okay, so it is whatever number of lines. Okay, so it is pretty long manifest file, and practically in one shot, it kind of gets you the installation of this. So let's see if this is already installed. So let's say kubectl get namespace. So you will see there is a namespace called Kubernetes dashboard. So what I did is, in an offline mode, I ran this. So the moment you do this, basically all the things get created. After that, I changed this also. Okay, so technically, if you will run this kubectl edit service, what I did was, in this, technically we have to change a cluster IP to node port service. So what you need to do is open this and change, because by default the installation that comes is actually cluster IP, but that is not going to help us. So I changed it to node port as the instruction says. And practically with this, what happens is I can get the dashboard details using this kind of a. So basically what I can do is, let's see if I will run this service. So I see this Kubernetes dashboard service. So just this one command creates everything for you. You just need to run it. It downloads this YAML from GitHub, and in a very simple way, it creates everything that it needs to be created, and practically you are good to go. So you have a dashboard. You can see the port IP is 30060. If you want to access this, you can kind of use this. Let's say you can take the master IP or node IP and do 30060. So let's see if I will try to do that. So if we will go to our EC2 instance, we will take our IP and we will say 30020. Okay. Colon node port. Okay. So let's see. Now, first of all, we will need to see if the port is open or not, or I will try with actually. Let's see what is the kind of a security group which is enabled on this. So I am on the master node. Master node has a security group. Let's see, security group has what kind of inbuilt roles. Okay, so what port is it? 30060. What did I type? Okay, 20, typo error, 60. So you need to go to HTTPS. Yeah, advanced, because the certificate has a problem. So you should eventually be reaching the dashboard. Okay, with this, proceed to this. So you will reach this. Okay, so practically to access this, you need a token. Now again, this is a graphical interface for doing all the kubectl commands and everything. So now to how to get this, let's say this is clearly explained here. You can say something like token is equal to this. So let's see, I will run this command anytime. If you want, you can access this. So I will go to this master machine, run this, and I will say echo $token. So I will see a long thing. I will just take this and I will paste it here. Okay, sign in. So with this, I will reach a kind of what is called a dashboard. In this, you can create your deployments also from here. Right now, you will see there are few deployments running here. Okay, so technically, let's say if you want to do rolling updates or something. So right now, remember, this is not my EKS cluster, guys. Be aware, the earlier demo which I did for rolling updates was using my own. So there is one, I have a EKS cluster. I ran that demo on this. Okay, but this is now my own installation where I have a master I have a worker node. For dashboard, I move to this installation of Kubernetes. The rolling update I showed you, this I showed you on EKS, but dashboards I am showing you on this my own installation. So be aware there are slight differences between the two. One of them is a PaaS service. I'm trying to show you the flavors of both together. Okay, so for dashboard, I moved here, and let's say we have some workloads running. Technically, rather than doing this, I can delete them from here. Okay, so rather than saying cube delete or something, I can technically delete them from here also. Okay, so if I will go to deployments, and we will see deployment. So let's see what are the kind of deployments which are running here. So let's go to our command line kubectl get deploy. So you can say kubectl delete deploy, and I will do demo, and I will delete Nginx, and I will delete the web deployment just for the sake of it. So now let's see. So in general, cap websites and cube, you see all deployments are gone. So technically I can go and say create here. Okay, so I can create also new resource rather than doing from a command line. I can say create new resource, and I can put my YAML here. Okay, so technically I can write the same YAML which I wrote here, and I can put it here, and I will say upload. So what it will do is it will basically create this deployment. Let me show you kubectl get deploy, and you will see this deployment coming up and pods. So practically you will see, okay, there are terminating pods. Where is the deployment pod? So this is 0 out of 3 ready, get pods. So why is pods not getting created? Let's see. Terminating. The earlier ones are still terminating. Okay, so let's give it some time. How many pods do we have? So these are P Benival 3, and these are still getting terminated. Okay, it is a bit slow, but technically very soon you should see that these pods should come up. Okay, so get pods. Now, why are they pending? Let's see. kubectl get nodes. I think kubectl and describe node, this is not ready also. Let's try to see what has happened to our EC2 cluster. So if I will go to EC2.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
And let's see if I have node temp. Yeah, this is running. So technically, this should not have been a problem. Get nodes. So for some reason, the node is not ready. Okay, so let's see what is the problem. It may not be that easy to debug, but let's see. Edit. I will go to the node temp, which was supposed to be connected to this. So let's take the IP of this, and let's go there to see. Of course, there is not much which we will be able to see here, but let's see. Worker node, and okay, now it's a problem that even this security group may require change. Okay, so let's see security group. No, it is the same security group. So why is this not able to reach? Edit, and I have SSH from anywhere. Okay, so this seems to be a much more open group. So technically, okay, let's see. Edit Ubuntu. Let's try to go there. Worker Ubuntu 18.204 instances running. So this is 18.204.216.235. Okay, it seems to be connecting, authenticating with public key. I will try to launch an instance which would not be a free tier, because a free tier basically creates a lot of problems. So I will choose a better machine than T2 micro. So I will say T2 medium at least. Let everything else be same, no problem. Review, add storage of 8 gig is okay. And let me add a name, new worker node and configure security group. Let's choose security group for at least TCP/22 everywhere. Okay, so let's say launch. I acknowledge and we launch this instance. Okay, so technically this will start another instance. What I will do is I will stop the other node. Okay, master, I will be very cautious what I'm doing. So this node, okay, the T2 micro machine, as of now I will not terminate, but I will just stop it. Okay, I will do the deletions later. While this is happening, our new worker node should come up shortly. So let's see. New worker node. Yeah, so it is getting a public IP. Perfect. So what we will do is I will go to worker and will change the IP. What I'm doing is I'm adding a new worker IP. Okay, so that we don't face the error. So let it come up. And remember, if we need to make it a worker IP, things are not that straightforward. So basically, it's not very long step, I would say, but yeah, it takes its own sweet time. So I will just quickly do it. What I will do is I like this approach where we can just put them into a shell file and run them. Okay, so I will say duplicate tab and I will say vi docker.sh insert. Okay, so basically everything gets installed with this command chmod plus x docker.sh, and I will also write a file called kubernetes.sh, and in that I will, okay, these steps I will need to write in that only. These are the steps of Kubernetes, so I will run all of them also. So I'm putting them here. So perfect. So now what I will do is once this is done, okay, 98%, let it run. I will run docker.sh. Okay, so let it finish. These are some general updates. After that, of course, as I have missed these steps, I will need to do this. Technically, I could have put all these steps also into the Docker file. Okay, so let me put that so that we have nothing missing. So out here, I will just copy paste everything, okay, which is in that document. I will just say docker.sh. It runs everything that needs to be run. While this is running, let me update kubernetes.sh and let me just quickly check if everything is okay. Yeah, seems to be okay. So let the Docker get installed. Once this gets installed, I will run kube.sh. Okay, I think the change mode is required for it to get executable permission. So kube.sh. Okay, change mode plus x kube.sh. Perfect. So once this runs, let's see if everything is okay. Sudo docker ps. Yeah, all good. I will run Kubernetes. So practically with this, we need to join it, right? Technically, I need this token. So for that, I have clearly mentioned it that if you want, you can get this join command again by running this command on master. If you have that command stored, well and good. Otherwise, you can go to the master, run this token create command, and basically it gives you the join command with the token. Just take this and run it here, sudo kubectl, and let's see what happens. Right now, if you will see kubectl get nodes, this is not ready. Let's add the third node. Okay, this one should get ready. Let's see if everything goes well. We should see a third node coming and ready. Okay, of course it will take few seconds because it is doing all those checks. I don't think there should be a problem, but still, let's see. Not a good sign, guys, if it takes this much time. 172 31 16 10 6 4 4 3. Okay, so let's try to see what is the kind of a setup. So we have new worker node running, seems to be okay. And this is the master machine security group should not have an issue. Let's see, security group, edit inbound rules. 6443. Okay, you may not specify an IPv4 for an existing reference. Okay, so I will say anywhere IP4. Save rules. You may not specify an IPv4 CIDR for an existing reference group ID rule. Okay, strange. What is this? So I will say, I will do a edit inbound rule, and let's add another rule. Okay, so I will add another rule. I will say 6443 and anywhere. Okay, save rules. I think because this is not able to talk to 6443. You see, the moment we did that, it started working. So basically the security group was a problem. Okay, so let's see what is there. kubectl get nodes, you see. So we have a worker node which is ready, which was just 30 seconds back, it is ready. So you can see, guys, creating your own nodes and everything, it is a slightly messy thing, but technically it is possible, you know. And let's see how many pods I have now. So practically you will see 3 running pods. Okay, forget about these terminating. This is a side effect of that not ready thing. Okay, so these are a side effect of that, but practically I have these 3 running pod. Now let's move back our focus to the dashboard which we were running. Okay, so where is the dashboard? So you see, technically, okay, now I need a token again. So let's see. So for that token, I will need to go to the master, and let's say echo dollar token. So let's see if I will choose the same one. Does it work, or do I need to generate a new one? No, it is working, you see. So basically you have 3 containers running. You can create services from here. You can technically go and let's say go to deployments, and technically if you want, you can say edit. So this is the whole point of this. Okay, in a graphical user interface you can do that. And out here, if you will try to look for something like replicas, you should be able to find replicas here. So you will see replicas, and you see 3. So if you want 5 instances, let's say, so right now if you look here in our pods, we have 3 running, right? 1, 2, 3. I am increasing it to 5, and I will just say update here, and practically you will see 2 additional coming up. So you see 1, 2, 3, 4, 5. Those were 17 minutes old, and this is 2 seconds. Okay, ignore the terminating ones. This is a side effect of that. Okay, we will really need to delete the, let's say, we have to do a bit of cleanup to get rid of these terminating. I'm trying to ignore that, but right now you can see it is running here. Okay, now comes the taints and tolerations. Okay, now this is again an important concept. It's an advanced concept, guys. This is mostly used when you have a need that, let's say, if you have hundreds of nodes or tens of nodes, and you want some kind of a connection between that, which pod can run on which node. If you don't have any such preference, practically you don't need to use this concepts of what is called taint and tolerations. Okay, an example of it would be in a real world scenario. It would be something like taint is something that you define at the node level. Okay, and toleration is something you define at the pod level. So let's say there is a particular node and there is another node. Now technically if you want that, let's say if you run a pod, normally both nodes have an equal possibility of getting that pod. But let's say if you want some kind of a preference that a particular node should be able to get only pods which tolerate its taint. So you can do some kind of a taint of this with some key and value and say whatever you want to based on this. And then only if the pod matches this condition that it is able to tolerate this taint, it will be getting here. Otherwise, it will not be able to get scheduled on it, and it will need to get scheduled on the other node, which may not be tainted, or it has a taint which this pod can tolerate. Okay, so in general, this is how the high level concept is: taints versus tolerations. Taint is a property that you define at the level of node, while toleration is something which you define in the pod specifications. Okay, and this is mostly used when you have a preference due to whatever use case of your business. If you don't have any such use case till now, as we were seeing, there was no taints and tolerations in action, and that is why practically your instance or your pod can get scheduled on any of the nodes. But if you want a preference, you will use this concept. Okay, so let's see a few slides before we move into this. So in general, if you want some kind of a constraint on a pod to be run on a particular kind of a node only, so in that you can use this taints and tolerations. So in general, you will automatically do the placement. So your scheduler will see to it that your taints and tolerations match. Okay. Now, whenever there is such a thing, due to whatever reason, you have some circumstances that you want some control on which node and which pod does the matching. So in that, basically use this. So you define at the level of pod, you will do either something like, let's say this is a node selector kind of a thing. So taints and tolerations is something which is, you practically taint a node with this command. So you can say taint node and you do some kind of a key value and no schedule, which means only pods which have matching key values, they will be able to get scheduled on it. The pods which don't have this matching key value, they will not be able to get scheduled. Okay, so this is how taints and tolerations work. So practically now what will happen is, when you will be defining your pod, you will need to do something like, you will need to put this tolerations key. So in general, at a high level, the concept is as simple as this: taints versus tolerations, taints and tolerations. So what I have done is, we get these nodes, and on one of the node, let's say I will say something like taint this node with key and value and whatever. So you can say something like taint node with name and the key equal to value, no schedule. And in general, remember, this no schedule means who don't have this key and value toleration, they will not be able to schedule. Okay, so but yes, everything else can get scheduled. So normally this is the way you taint the node. Okay, so let's say if I will do this, which is, let's try it on our own cluster. Of course, it's not a very good example, but right now we created this cluster and we have two nodes, okay, which are working. The third one is not working, so let's ignore it. Of course, let's try to see, first of all, you saw till now nothing gets executed on master. Why do you think that is happening? We never saw it, but now the point has come where let's try to analyze it, that why is the workload not getting executed on master? Because let's try to do describe pod, and I will say this, okay, kubectl describe node. So we'll try to see the pod node, and in node, if you will try to see at some point, you should see something like taints. Okay, so let's see. You see there is a taint on it. So because it is having this taint, node role Kubernetes IO master, no schedule. So only workloads which has, let's say, key value, only they will be able to execute, the others cannot. Okay, while let's see what is the case with our nodes, okay, which is the node which we just created, IP23. Let's see what kind of taints this has. So you see, there is no taints on it. And that is why workload can run on it. If you want your master also to kind of, let's say, get this, there is a way that you can remove this taint. Okay, let's try to see if we can do that. So what I will try to do is, I will grep -i taint. So it has this, and the command to do it is, let me copy this. So this is a command to remove the taint. Okay, so I will say kubectl taint nodes, and I will give it this minus. Let's see.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
You see the taint is removed on master. So now let's try to see if things start getting scheduled on master also. How we will see that? Let's try to go to website and let's go to Kube, and let's try to increase the number of deployments. In our deployment right now, we have 3 replicas and they are running on kubectl get pods. Okay, what I will do is grep -i running. So we will see only the running. So there are 5. Okay, Remember, there are 5 while my deploy file shows only 3. I did the change from the dashboard, okay, which doesn't change this, okay. So I updated it through the dashboard option, okay, which is not a very good way, because then my manifest file is not having the right current thing, okay, which is a problem. But anyway, let's apply this now, the deploy, and let's see where this pod will run. So right now I'm doing running, so you should see 10 running. And now interesting things is, let me do a -o wide to see where have they been put. So right now you see, okay, some of them are put on 10, okay, others are put on 23. Let's try to see what is 10 and what is 23. Kubectl get nodes. So you see 10 is the master and 23 is the worker node. But 1, 2, so 2 containers have started on the master node also, because I removed the taint, okay. So this is how it works. Of course, if you want, you can do something like kubectl taint and let's say give something kind of a name. So let's say as an example, if I will do right now, let's reduce it to 0, okay. So what I will do is I will say kubectl delete -f deploy.yml. So I'm deleting this deployment, get deploy, yeah, kubectl get pods. So you have everything terminating, okay, fine. So basically it is gone. These are the old ones. I'm still thinking how to do the cleanup. It's pretty bad that they are, because that node went into such a state. So technically, anyway, coming back to our focus, let's say kubectl, I will now taint the node, okay. So one of the node I will taint. So I will say, let's get the name of the nodes, kubectl get nodes. So I will say kubectl taint nodes, and I will node this node, okay. And we will say something like key1 value1 no schedule, which means this node, which is the worker node, it will only, it is tainted, okay. It will only accept pods which are having toleration to this key1 value1 kind of a thing. For the others, it is a no schedule. So now you will see this is a tainted node. How do you know? You can say kubectl describe nodes. You will take this and see grep -I taint. So you see this has a taint key value 1. Now technically, when you are, let's say, trying to start any kind of a pod, let's see. So I will just take this immediately, this thing, and let's say toleration.yaml, and I will put that here. So now let's see what we are saying. So we are saying nginx, fine, this is not required. Spec is containers, image pull policy, fine. Tolerations, you see key1 value 1. Now in this case, because this pod tolerates it, you will see that it, again, remember, some of these can still go to master, but at least if, let's say, I will change this to value 2, okay, that is more important to see. Let's say this has a toleration of key1 equal to value 2. Now what do you think? If I will start this pod, what is the chance that it will get? So let's say I have a master node, of course doesn't matter, it is one of the node, and I have a worker node. On worker node, I have tainted key1 equal to value 1, and my pod is having key1 equal to value 2. Does the taint and the tolerations match? So if they don't match, it cannot get scheduled on worker node. This pod can get scheduled only on master. Let's say if I change the value to something which it doesn't tolerate, now if I will run this kubectl create -f toleration, let's see, kubectl get pods -o wide, and the running pod, where is it running? You see it is running on 10. And what is 10? 10 is the master. So it can never happen this pod will run on 23, okay. Of course, it may or may not run. Let's say if I will do kubectl delete -f, and let's delete the toleration pod, and let's say if I will do toleration and now I will give it value 1. Now we don't know, okay, the value is mapping the toleration, is mapping the taint. So in this case, if I will run this, okay, let's say I will create this pod again. Now the possibility is, I'm not sure where it can, okay, technically it can go to anything. So let me say get pods -o wide grep -I running, just to see only the running pod. You see, it is running on 23, but potentially it could have run on 10 also, okay, that we already saw. It's not that just because of taint and toleration match, it will always be scheduled here. Now comes this monitoring, okay. In general, for monitoring, again, we don't have really a production kind of a workload, and I didn't see much setup that we can do, but technically monitoring is usually a way of consolidating your data, how the load is on your things. So one of the popular tools in general is Prometheus, and the other one is Grafana. Prometheus is more a data collection tool, while Grafana is more a dashboard tool, which can pull data. So we will try to make Prometheus and Grafana work together. It is a open source tool originally, whatever, and in general, it has this features of its own query language and everything. This is by far one of the very, very advanced topic. Okay, so this is a document which is installing Kubernetes Prometheus. Okay, so basically you have already a repository which is by somebody named Bibin Wilson. I looked at it after Googling out, and all this seemed to be a decent repository, because installing Prometheus is not that easy a thing. If you will see, it has various things like cluster role, config map. There is a full-fledged deployment. There is some kind of an ingress and a service and all that. You will see. So basically, lot of things which are relatively advanced in nature are required to run Prometheus deployment. It needs, we have installed it in a space called monitoring. So what I have done is basically, I have done everything from scratch, where we will say create a new namespace for monitoring. So let me clear this. So the name of this should be monitoring. So we are creating a namespace monitoring, and rather than writing these from scratch, which the documentation of Prometheus of Intellipaat talks about, I have looked at this repo, which seems to be a decent place to directly go here and create these at a time. So you need to create something cluster role, you need to create a config map, you need to create deployment, and then you need to create a Prometheus service, and after that it will start working. Okay, so technically, if you will see the documentation of, let's say, the Intellipaat, let me just try to show you how that is set up so that you will get to know what different I have done. So let's say Intellipaat, Kubernetes, and Prometheus. Okay, basically creating this namespace is okay, but then they say that this cluster role.yml, you should take it and copy it in this way, and this has, by the way, indentation issue. So practically I would suggest not to follow this directly, and that is why you see my documentation talks about cloning this repo. So if you will clone this repo, let me show you what is going to happen. So if you will clone this repo, let's say out here, so you have a Kubernetes Prometheus repo, which I cloned it. If you will see, it is git remote -v. So you will see it is populating there. And the very first thing which we need to do here is create a namespace called monitoring, and then you have something called a cluster role. So if you will see, there is a cluster role. It has all these endpoints, verbs, and it has something like a RBAC authorization, cluster binding with cluster role and Prometheus, and a service account binding and all. So in general, it has to be followed exactly the same way. And so for sure, we will need to install it from here. So let's say something like, if I will try to run this command now, because I already have a namespace, it may give me an error, which is okay. Technically, all you need to do is clone this repo. I already have this repo cloned, so I will do this create. Of course, this will not do anything and it may error out because technically it already exists. Okay, but if it was not existing, The moment you will do this, the role gets created. After that, there is something called a config map. Okay, this is required for some kind of a key value. Let me show you what are the key values here. Again, not a simple installation or a manifest file at all. If you are an advanced user of Kubernetes, you can understand it. But technically, it's as simple as just running this command. So it creates something called a config map. So basically, if you will, all you need to do is kubectl create -f config map. So in general, it creates something called a config map, which is already there. So that's not a problem. It gets created. Then there is a deployment. Let's see what is the nature of the deployment. Okay, so we create a deployment, which is again, let's say kind deployment. Metadata namespace is monitoring, which means we want everything in monitoring. There is some kind of this. You only want one replica, and you have this Prometheus. It is taking the config map which we created, the YAML file, doing something related to storage, some kind of a container port, some kind of a volume mount, and the volume is getting created and everything. So a lot of things, guys, again, empty dir and all that. So it's an advanced implementation. Overall, you do this, and in general, eventually you will create a service to kind of expose this Prometheus, which is running. Let's see Prometheus service. What is the nature of the service? Let's see if that will work. Kubectl get service -- namespace equal to monitoring. So you have this running on 30,000. So our application is running on 9090, okay, which is the Prometheus port. Okay, so technically that is working on 9090. And 8080 is the service port, and the node port is 30,000. So technically, to access this, I will need to go with, let's start with master IP, okay, just to see if it works. So if I will go to the master IP, okay, EC2, and let's see if our running container is there. So normally it is master temp. If I will go to details of it, this is the master IP :30,000, okay. So let's see. So first of all, I think security group allows it, but it's a problem with it will not be exposed on master IP. But let's see if from security point of view is 30,000 allowed. Let's see, edit. And you will see 30,000 is there, but still you see this is not working. So let's try with the worker node, okay? But worker node is a new. I doubt actually it will have, but let's try to see, no problem. So I will go to a worker node to see if it works from there. So let's go to our new worker node, which we just created some time back. Take its IP, and we will replace this with this, okay. Of course, let's see the security group of the worker node also. So we will go to the security group, edit, okay, add rules, 30,000, save. Of course, I don't think it will still work because I think the deployment itself is not working, okay. Be aware there is a problem with the deployment, remember. Let's see, control 30,000, it's working, you see, Prometheus. So technically the problem is not there because it is a different namespace. So I will say get all -- namespaces equal to monitoring. So technically you will see what all it has. So you see there is a pod which is running, and there is a service Grafana which is running. There is a Prometheus service which is running. Again, Grafana we will talk about later on. There is a Prometheus deployment, and there is something called a replica set for Prometheus. So this is Prometheus, this is Prometheus deployment, this is Prometheus service, and this is Prometheus pod, okay. So technically it has everything running, and basically because of this you are able to access. But as you know, we don't have much to show here. If you will see, there is, let's say, Grafana live node and num nodes execute. So it shows you again nothing very fancy, but technically it is showing you whatever is data is available to you. Again, I'm not able to see any use case of it, but technically to install it, if you will follow these steps, you will have a Prometheus running, and I will say public IP worker node colon 30,000. Please see to it that security group on worker node allows traffic on port 30,000. Okay, so I will just highlight it in red color so that you don't miss out this point. Okay, it is important, and in general you can see it in this way. So practically this is how you install a Prometheus. The same thing is true for Grafana also. In general, Grafana also needs a complex setup. Installing Grafana using the cloning of this repo called Kubernetes Grafana.git. Okay, so technically this is from where we can work with it. So technically you can take Grafana.git, and it has what is called a config, which is a config map, which is mainly the key values that you have. And you have this deployment file, which is kind deployment and monitoring and everything. So basically it has some volume concept again. It's empty dir, which means local pod volumes. And it has a service also, which is of type node port again. And this is on port 32,000. So basically, if you will follow these steps the way it is shown here, all you need to do is run them one at a time. So let's say something like kubectl. So I will need to go to that repo which I created of Grafana. Kubectl create -f. Of course, this is already created for me. So you may find this, okay, this already exists. You will need to create this deployment, which also, by the way, already exists. And you need to create a service, which also actually exists. And if you will get this by fetching this, so you will see there is a node port service for Grafana. So all you need to do is technically take this and go to port 32,000. Okay. Now again, we will need to see if the port is open by security group. For that, I will need to go to the security group. I think this is the same security group. Let's try to see. Yeah, it has 30,000, 32,000. So I will say 32,000 because the Grafana is running here. And right now I will take it from anywhere. Of course, this is not very safe practice, but technically it's okay. We are not. So the moment you do this, practically you will see a login page. I have clearly mentioned that by default, when you will start, okay, so this is public IP worker node colon 32,000. And this needs to be replaced with a valid value. Okay, so don't replace it like this. And this less than greater than is more like placeholder. By default, the login password is admin, but the moment you log in, it will ask you to change. I think I already changed it to something else, and let's see if the login works. So, okay, the admin is not working. Okay, it is asking me for a new password. So I will say admin and I will say submit. So practically now this is the welcome page of Grafana. Let's say something like a elastic Kubernetes cluster. So you will get some kind of monitoring here itself. Okay, so technically in general, it will try to show you at this place also as to how many in general, what are the namespaces, how many are the failed and everything. So this seems to be a very simple kind of an installation which just shows you in general what is the kind of workload. Has anything failed? Is anything different from ready or something? Beyond that, if you want, in general, you will need to come up with some kind of a third-party tool like a Prometheus or a Grafana. If you will see out here, technically, by the way, when we were doing it, I didn't do, but if let me show you, if I will try to create a cluster, there is at the time of creating a cluster, technically it asks me as to what do I want to monitor. Okay, so let me show you where it was. So if you will see configure logging. Okay, so let's go next. Okay, it needs a name. So my name. So if I will go to next and out here, if I will again go to next, you see there is a control plane logging. So practically you can do CloudWatch logs here. So you can look at your API server, any kind of authenticator, controller manager, scheduler. These are the control plane elements of Kubernetes. So if you want, you can take help of these, enable these, and then in CloudWatch, you can create your own dashboards like what you can do in Prometheus or Grafana for that matter. But this is a cloud native tool by AWS. would be used if you are using purely AWS platform to monitor. Otherwise, you need to do your own implementation of a monitoring tool like a Grafana or a Prometheus. Let's see. So see, I created an application which is a Java program, and I created a separate application which is a MySQL database. So this kind of gives you an idea why do you need volumes. So basically you can run them as containerized application directly, no problem. So you can run a separate Docker which is having your web application. You can have a separate MySQL using bridge network. They can talk to each other and you have a working application. But then you need concept of volume mapping if you want to store your volumes of database. And for this, you will need some kind of a port mapping. So now Docker world is okay. But what I did is I went to the next step. So I Dockerized these applications and then I kind of containerize these applications also. And rather than running them as Docker containers, I have put up an instructions to run them as pods. And rather than using Docker network, we will use something like a cluster IP kind of a thing to expose our database. And for this, you can use something like an external load balancer if you have a EKS. So basically, it's a good implementation of many concepts. And to do this volume, rather than Docker volume, I am using a persistent volume and persistent volume claim. Of course, this demo that I had, I created it mainly for GKE. But let's try to see together. But technically, let's see if the same solution will work on EKS, okay? But because it has used some concepts of persistent volumes and persistent volume claims. So overall, in general, this is the kind of the nature we will try to create an application. So I have created a good document for this. So let me try to show you. There is a repo that I created, which is technically you can clone it if you want. It's a public repo. Let me try to show you what it does. So practically it has all these files which you need, and the Kubernetes cluster as usual has this. So you can create something like a persistent volume, which is a concept of volumes. You can create a claim to that volume. In your MySQL, in the deployment of that, you can use the same volumes to do mount path where your database of MySQL gets stored, so that even if your pod gets deleted, your data is safe. I will show you that how you do this. So using volume concepts, and same way you have a web, which is the front end deployment, which is pretty straightforward. It is using some image of mine, which is, let's say, P Beniwal, my bank, JDBC, doesn't matter. And overall, I create for MySQL service, we create a service which is of cluster IP. You see, default service is cluster IP. So if you don't specify node port or load balancer, I have a cluster IP service. And for the deployment, I have both options, whether you want a node port service or whether if you have an external kind of a service, you can create a load balancer. So let's see. My only worry is these are slightly advanced concepts, which is persistent volume and persistent volume claim. So let's see if they work on this. Okay, it would be interesting to see whether they work on a EKS node. Okay, this database is based on cluster IP, because remember, we don't want it to expose it to the outside world. And this could be either based on node port or a load balancer, which can be accessed from outside. Okay. And of course, the concept of volumes in general. Okay. So all things play a role and they are able to talk through this cluster IP. So practically, this is how it can be done. And the simplest installation of it is, let's go to my master machine, or I think better would be, let's go to my EKS only. Okay. I would prefer to run it on EKS just to see. So what I will do is, let's try to run it ls minus lrt. So I will say git clone, and let's clone this repo, which I have, which is my bank. And let's try to see how portable is the code. So I will go to CLI and clone it. So now I will go to my bank and Kubernetes, and let's try to see kubectl. Right now, let's see what all it has. Get deploy. So there is, so I will say kubectl delete deploy web deployment. So I'm deleting the deployment. So we have nothing. So if you'll see get deploy, nothing, get pods, nothing, get service, there's only the Kubernetes. Okay, there is this service kubectl, delete service, web lb service. Okay, so let's see. So I have cleaned up everything, and what we will run is this application just to show you. Let's see if the persistent volume and PPC claim and everything works, though I think it should work, but let's see. I doubt actually, but okay, the service is taking some time to get deleted. Okay, it's done. So let's see. So now if you will see kubectl get pod, there is nothing. Get deployment, there is nothing. In service, you will see only the default service of Kubernetes. Now we are all set. Technically, I can say create -f dot. Let's see what happens. So let's see what all got created. Get all. So you are seeing that there is a replica set getting created for my bank, which has one desired. There is a replica set for MySQL DB, one copy. There is a deployment, which is one each. And there is service, which is load balancer. There is cluster IP, and there is node port, and there are 2 pods running. So let's see if things started running. So get pods. Perfect. Both pods seems to be running. Let's see get service. This also seems to be running. So let's try to see if we can kind of access this. So if I will take this IP, copy, Control V, :9999, let's see. It may take some time to come up because it has just been started, but practically if everything goes well, let's see kubectl get deploy. Is everything okay? Yeah, seems to be okay, but again, sometime it could be misleading the pods. Okay, it is still running. So you have 2 restarts, and let's see. Okay, welcome. Perfect. You see, basically it is as simple as this. You see how good it is. All it does is, again, it's a very simple page. All I need to do is something like, let's say, add account. I will add my name, enter some address, and submit. And it should show me this. Okay, so let me show you what has happened here. So technically, remember how it has happened. Kubectl, I will need to go to this, and I will say get pod. So what is happening is I am interacting with this JDBC application, which is a front end. It is talking to MySQL DB and connecting with it and in the database. Okay, I can prove to you also that a row has been created in this MySQL DB. So for that, I may need to do kubectl exec -it. Let's take this, copy, and
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
--bash. So this is the way I can connect to that container which is running in that pod. Okay, so now I am on the MySQL container, and for this, technically I have created a document which will talk about it as to how you can connect to it and see the data. Okay, so let's see if I still have it. So technically there is a lot of things here. So let's say if I will try to connect to MySQL, so I will say MySQL -u root -p. I will connect to the database. Let's see, show databases.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I will say use my bank DB, show tables, select star from account. I should see one row. You see, Prashant Pune. This is what I created from here. So technically, if I will add another thing, okay, let's say dummy and 111. The moment I will submit it, remember, this is technically a service which is hitting my front end, okay, because this is a load balancer service with which I am going. And internally, using the cluster IP service, it is talking to this container. Right now, if you will see how many rows that I have in this, let's see. Right now, it is still one row, right? Let's say select star from account. Select star from account. If you will see one row, let's keep it ready and I will say submit. The moment you do this, practically it has a second row. So let's see what all we have done here. Okay, so technically, if you will see kubectl exit, kubectl get service. So you see MySQL DB is having a cluster IP service and it is only exposed internally 3306, while this is a load balancer service 10.100.45.109. Okay, node IP. So let's see for a EKS cluster, what is our node IP? If I will go to my EKS cluster, I have this node group which has these two nodes. Okay, one of them is this node, one of them is this node. So let's see, we will take this node IP. So let's try to see if I will go to EC2, and in EC2, let's see. Remember, this is one of the nodes. So let's take the public IP of the node 100.24.119.35, control V colon. I will go to 31010. This is not working. Let's see the firewall of this IP. So I will go to the security. So it has these two security groups. One of them is the EKS cluster. So let's see the rules that it has. Okay, so practically it is opening 32,000. What is the number here? 31010. So I don't see 31010 open here, right? So what I will do is, let's try to go from EC2 dashboard, instances. Let's take this instant ID, security, remote access, edit. Okay, I can change one of them, 310. I will change it to 10 and I will say save. Let's see what happens here. You see, it started working and it has that access also, show data. Okay, so practically now remember, technically this can be accessed either from this EC2 or it can be technically accessed from the other EC2 also, because even though, you know, guys, this pod is running only on one of these clusters, we can see that also where it is running. Let's try to see that. Okay, so if I will say kubectl get pods minus o wide, so technically the front end pod is running on the 8754, okay, which is one of the machine. So practically you see one of them is 7182 and the other one is 8754. So technically the pod was running on this, but I use the IP of this. So remember, that is the beauty of Kubernetes. Even though the pod may be running only on one node, but if it is a node port service, I can take any of the node port or public IP and I can do that. Okay, so you see I took this IP and it still works for me. So in that sense, be aware that this is how it is. In general, remember, the whole point of having this volume concept is that even if my pod gets deleted and a new one gets created, you will still see your data. If the volume concept was not there, be aware that what would have happened if the pod would have got deleted. But right now, even if I delete this pod, let's try this flow. I will delete both these pods. Okay, let's say delete pod and I will delete the pod of MySQL DB also. Copy, paste, and I will delete this pod also. Okay. Now remember, because of the deployment and replica set, they should get created immediately again. Okay. It says error not found pod. Okay. Delete kubectl, delete pod. What is it? Get pods. Okay. So let's see. You see, I deleted the database pod. Takes time to delete the pod, and let me delete the front end also. Though front end is not relevant, but just for the sake of it, I will delete the front end also. Okay. Copy, paste. So let's delete it and let's see if new pod gets created. You see the pods are running again. Now technically, let me go to the service, whether the external IP based service or this service. Give it some time before the pod comes up again. And let's see, you see, the data is still shown. This is happening because of this concept of volume mapping. Okay, though we have not used Docker volume, this picture is of Docker, but what I have done is also taken the effort to do it. I have Kubernetized it. Okay, but again, doesn't mean this is the only way. I used a concept of PVC and PV. You could have another things like EFS and all that. That's again an advanced topic. But technically, the cluster IP, the node port, the load balancer, the communication using the DNS names and all this is a good enough demo. So with this, guys, we are done with Kubernetes.
Now let's talk about the Kubernetes objects. Now, as I've mentioned before, Kubernetes object is a record of intent. So once you create an object, Kubernetes system will constantly work to ensure that that object exists. By creating an object, you are effectively telling the Kubernetes system what you want your cluster's workload to look like. And this is your cluster desired state. So what do we mean by that is while you create an object, you tell them how you want your workload to look like on your cluster. So let's say if you have a cluster and you are defining, let's say I want 5 objects in it. I want 5 replicas. So it will create 5 replicas, and if it's not there, it will, Kubernetes system is designed in such a way it will make sure that you always have 5 objects of that kind always available. If it is not there, then it will create more. And if it is, if by mistake, let's say if there are more than the required state, then it will delete it. So whatever you define in your record of intent, that is your object. Kubernetes will make sure you have your desired state always maintained. To work with Kubernetes object, whether to create them, to modify them, or to delete them, you'll need to use the Kubernetes API. So as we mentioned before, this is a very client server based model where it works primarily on APIs. So you make an API calls through this command line interface, which is kubectl. So when you use the kubectl command line interface, the CLI or the command line interface, which is the kubectl, it makes all the necessary calls for you, all the necessary API calls. You just give it a command. It takes your commands and makes those API calls so that you get whatever you were expecting out of it. So that is the important part of it. Then every Kubernetes object includes 2 nested object fields that govern an object's configurations. First is the object spec, which is basically the specifications, you can say, but object spec, and then there is object status. Now let's dig into what these object spec and object status is. So spec is just the object spec, which describes the desired state of the object, the characteristics that you want to have in your cluster. So whatever the state that you want your desired deployment or the pod to be in, you define that inside of the spec, and then in the status you describe the actual state of the object, and this is supplied and updated by the Kubernetes system. So here in the specs section, you describe the desired state for the object, the characteristics that you want for the object to have, and here in the status you describe the actual state of the object, and is supplied and updated by the Kubernetes system. So when you use Kubernetes APIs to create these objects either directly or via the kubectl, the API request must include that information as a JSON in the request body. So JSON is another file format. If you have worked with JSON or Node.js or something like that, you create this file, which basically looks like a key value store again. It is well defined and it's pretty readable and easy to understand. So whenever you are using an API request, that must contain the information as the JSON format. So most often you provide this information to kubectl in a YAML file. So this YAML file is very similar to a JSON file, and so it is very easy for kubectl to convert that YAML file into a JSON file while making those API requests. Now, as we mentioned before, YAML file is a very important aspect when dealing with Kubernetes, because all of the things that you will be defining inside of a YAML file. So it is very important to understand how to create a YAML file and to properly make those information and configurations inside of it, so that your entire Kubernetes system runs properly, right? So that's why the next thing on our agenda is introduction to YAML. So we are getting more and more closer to the more interesting stuff. So this is a pathway to reach that interesting stuff. So I know so far it's been very theoretical, if you will. It'll be a little more theoretical a little while longer, but this is where it begins to become on the non-theoretical end, where we can see more hands-on stuff. So if you learn about making YAMLs, we can do a lot of different things in Kubernetes, which are very, very interesting, and it's very much fun. So we begin by introduction to YAML. So what basically YAML is YAML is abbreviated as YAML ain't a markup language. Now that's a very funny name. Whoever thought of it, that we'll name YAML and we'll put full form of Y as YAML itself. So YAML ain't a markup language is the full form of YAML. So it is data serialization language, which is designed to be human friendly and works well with programming languages for everyday tasks. So it is a very simple looking file. The only thing you need to take care of while working with YAML file is the indentation, because it takes indentation very seriously. By indentation, I mean the spaces that you provide between the two constraints that you have, or the list form of the objects file. We will be discussing that later in this section itself. So while creating that, just take care of the spaces. I mentioned it now just before starting it, because I make those mistakes all the time, and it says that something is missing and it's not properly configuring and something like that. So please take care of the spaces when you are working with the YAML files. Now YAML includes a markup language with important construct to distinguish data-oriented language with document markup language. So the design goals and features of YAML are very straightforward. So YAML data is portable between programming languages. So you can take a YAML file from here to there. It is basically a subset of JSON file. It is mostly used for giving out configurations and information related to configurations and stuff like that. So it is a very portable kind of information that you can pass on between different programming languages. There is a very much ease of the implementation and usage. So it is very easy to type up. It's not that difficult. Only thing is that the spaces thing is very important to make sure of the spaces that you're using. For that, I would recommend you to use something like a Sublime Text or something where you can get the information in properly indented form where your data is going, instead of directly writing inside of, let's say if you use sudo nano and you try to write it inside of your bash terminal. Instead of that, I'd recommend you use Sublime and then copy paste it. I found it to be much better, but something suits some people, something suit the other people, right? Moving forward, it includes data consistent data model. So it has a data model which is very data consistent. So the way you write things is very consistent and you define things in a very particular way, and that's why it is very easily readable. So if you are a human, if I show you a YAML file right away, you'd be able to tell me what is going on inside it, probably, if you know a little bit here and there. So that is how we'll be learning to create a YAML file. Although when you're working with Kubernetes, there are a lot of different things that you need to learn to define a YAML file. We'll discuss that right now itself, and we'll give you a list of things as well, of the versions and stuff like that you need to keep in mind while creating a YAML file. So a different kind of data model works with different kinds of things. So let's say okay, we'll give you an example, then I'll show you. So YAML is a superset of a JSON file. As I mentioned earlier, this is very similar to the JSON file. So when you're making an API call, what you basically do is you have your configurations in your YAML file. So when it is making that API call, it will convert your YAML file to a JSON file, right? So there are two types of structure inside the YAML that you need to know. First is maps and second is the list. So there are two different kinds of structures that you need to know about, because that is how you define things. There are the maps and lists inside of it, right? So when we map a key to a value in YAML, it is termed as map. So if you have a key value pair, like let's say name, Intellipaat, course, Kubernetes. So this kind of thing is called mapping, where you have a key and you have a value. So you map your name as Intellipaat. So when I search for, let's say if I've created this YAML file and I have this as working, so if I just search for the name, it will give me, if I just, instead of writing name, instead of the names of the name section, if I just put Intellipaat, it will work for me. So because you have defined the name as Intellipaat. And then there is a list kind of things. Now list has an arguments inside of it. All of these arguments are started with a simple dash between them, and there is a space between the dash, which we have not mentioned here. So there is a kind of a gap between them while creating them. So as you can see an example here, the first is the argument. It asks you to sleep for 1000 seconds. And then you have the second argument, which is the message which you will be giving, which is Kubernetes test. So this is like a list format. So this is very different from the maps format, where you define something with the help of a key value pair. Inside of this, you can can have multiple arguments in a list kind of manner, where it is a sequence of objects one after the other that you want to define, right? So that is how you define a list kind of thing. So this is a sample YAML file. As you can see, version services, but this is not very helpful. So I will show you a real life deployment file of YAML, which we'll be using in the next module, but I'll show you right away so that you understand how important the YAML files are. So we'll switch to Sublime for a second, and so you can see I have a deployment of an Nginx here. So Nginx is basically something similar to Apache servers or Tomcat if you have used. So it helps you host things on localhost for exposure. So Nginx is that. As you can see, this is right here is key value pair, which is a map, right? I've defined a name, a key, and it has a value version 1. So while creating YAML files, you have to define the API version. Some will have apps v1, some will just have v1, some will have apps beta v1. I'll give you a list of things because not all of these support, like this has the kind deployment. Since this is a deployment, I'm defining this as a deployment. This is under this API version. So when I'm making the call, this API version has this defined inside of it. But not everything has everything inside of it, right? So if I were using, let's say, Ingress, or I was creating a kind of a service or a kind of a volume or a secret or whatever, this will change accordingly to that. We'll give you a list of things like that. So when you are creating these files, you can find most of them mostly online. You can just search for it if you're looking for an Nginx deployment or something. You can find most of the YAML files online itself. But when you're creating by yourself, you need to know some rules, and it'll give you some errors also. I'll show you that also. If I just change it to v1 or something, it should give me some errors in that. So here I have metadata. Now inside of metadata, I have defined the name of the application as Nginx deployment. So if I have to call this deployment, I have to use this name, Nginx deployment. It has few labels inside of it. Now labels and specs and everything, spec we have discussed early on, right? So spec is something where you define the ideal condition of what you want your cluster to be in. So the ideal position of this deployment is to have replicas 3. So I should have 3 pods which are running this deployment, which is the Nginx deployment, right? So this Nginx should run in 3 points, which is the 3 replicas in it. So I have a selector which matches the labels of app name as the Nginx. So if I'm looking for the app name, so here the app is the Nginx, then there is the template metadata, and then there is again, I have defined another specification where I have defined the containers and what image it is pulling. So this is pulling the image of Nginx 1.15.4. So 1.15.4, it is pulling that image. You can define different images that you have created in your Docker. So let's say if I had an image named as Intellipaat rocks, so I can put that here, but with its version properly, then it will pull that image inside of that container, right? And the container port is just 18. So this is how we define a deployment or deployment YAML. So this is a YAML. I'll show you how it works also a little bit, but this is just don't take it for like you don't understand what is going on. I'm just showing you how this YAML works. This is a deployment. We'll be covering deployments in the next future modules where we discuss it in further. This is just how you define a deployment. Now, why I was saying that you can use something like a Sublime text is because of this line. You see this line right here. It contains 2 spaces between it. So every time you have something lining on and two spaces you want, you can do it like that. So while defining a YAML file, you need to put 2 spaces between anything which is defined inside of something. So inside of metadata, I have 2 different things, right? All of these inside the metadata will be separated between 2 spaces. So if I put backspace, this is 1 and 2, right? 1, 2. 2 spaces should be there. Similarly here, this is also inside 2 spaces. Now this is 2 spaces inside of this. So while I'm defining anything inside of anything, it should be separated with 2 spaces. And when you're defining something with like a hyphen, like an argument, then it has to be 1 space. See, 1, that's it, right? So inside of an argument, between a dash and the whatever the argument that you are defining, there should be 1 space. And in the mapping, while you are mapping, you need 2 spaces in there, and you should keep a space between the key value pair. So here there will be a space. So that is something you need to take care of while defining this. I'll copy this entirely. I'll show you how it works just for the sake of it. So we'll go to our, so here I'll write nano, which is create to open a file. So nano, this is my deployment 1. So I'll name it as dp1.yaml, right? Inside of here, I want to paste the details of this particular YAML file. So I'll just copy it. So I'd recommend you to make something like a YAML file right here when you're typing. Just make sure of the spaces. It is very important. Now we'll go to our back here, paste it, and then we'll have a look at it. And then we'll just Control X and exit. So we'll look at it once again. So see, the spaces has been made properly. The image is defined, the container poster is defined, everything is working. So my YAML file is now created. Now you can just type kubectl create -f, now the name of the file, which is dep1.yaml. Now what I'm expecting here is, since the kind is deployment, it should say that this deployment was created. So let's hit enter and see what happens. And you can see the apps nginx.deployment was created. Now if I do kubectl get pods, now I have a deployment. I should get, since I mentioned 3 replicas here, I should get 3 pods, right? So if I do, see, 3 pods of the same deployment of the nginx deployment are running. Each of these are running. You can use kubectl describe pods to see in further details about the pods. Let's look at it. So you can see in-depth details here of all the pods. Like this is the name, this is the namespace is default. So this inside of default, it has this particular IP and it is a replica set. It is controlled by the replica set and its IP, its true status and everything. You can get all the details inside if you want using this kubectl get describe pods. So just we'll do it once again, kubectl get pods to show you now how this is working, right? So so here the API version was 1 kind of deployment here, and nginx deployment and whatever it is deployed here. Now you can see I've mentioned 3 replicas here. That is the reason why there are 3 different pods running of the same. All of these are the nginx deployments of the same time. All of these have the same image and same everything, just there are 3 different instances of it running. So if I have a load balancer, if I hit the pod named nginx, if I hit the deployment which is the nginx deployment, I have 3 pods running in it. So when I hit it from the outside, I just hit I want the nginx to work, I want this app to be running. Now inside that app we have 3 replicas. Now whatever the status of these is, the load will be distributed in a round robin fashion. And whoever is free, the data will be directed to that. That is the job that the replicas do. It helps you balance the load out. You have different replicas which are running constantly. Now, what I want to show you all is, like I was saying you that the API versions, if it is not perfectly defined, that will create a different problem. So what we'll do is we'll create another deployment file, and that should not work. So what we'll do is we'll just change this to v1, okay, and just copy it entirely, and we'll create another nano file. We'll call this, let's say, not working .yaml. This should not be working, right? We'll just paste it. We'll Control S to save it, Control X to exit. Then we'll create the same kubectl create -f, name of the file which is not working .yaml. Now this should not work. See, unable to recognize the YAML file, not working YAML, no matches for the kind deployment in v1. So this is the very important part. Let me just this is the no matches for the kind deployment in version 1. So there is no API version named version v1 which has the kind deployment specified in it. So this is very important to match the APIs with the kind and whatever the data inside of it is. If these two are not matching, your deployment will not work, or whatever it is, your service or whatever you are trying to deploy will not work. You need to have proper API versions so that you have a proper kind of thing that is working. Every different thing is defined under certain things. So you have to get that spot on in order to work. That's why the original part was working, because it was apps/v1. If we just nano it, not working.yaml, if I just write again, it was apps/v1, right? Apps/v1 or app/v1. I think it was app. And then we try again to create this file. Okay, it was probably apps. We'll change it to apps. Or we can just check it out from the previous YAML file. Oh, the Nginx deployment already exists. Now, the name of the container. So while creating this deployment, the problem is I have already specified this name, Nginx deployment. So there cannot be two different deployments with the same name, right? So if I call a deployment, if I'm just like, if I type kubectl get deployment, and then I mention the deployment name, which is Nginx deployment, then I'm specifying a name of a deployment, and it shows me the details of that deployment, that it has 3 different pods which are running inside of it. All of them are up to date and all of them are available, and they have been created 5 minutes 34 seconds ago. The problem with creating not working YAML here is it has the same name, so you cannot have 2 different things being called from the same name, right? If I have 2 different services which have the same name, how will my system know which service to respond to? That is why your YAML file is very important. You have to define everything properly in here. So that's why we made that mistake. Now we'll go back to the nano not working.yaml. We'll just change it a little bit. Instead of Nginx deployment, we'll name it Nginx test, right? You can name it whatever you want here, and then we'll come back here, and now we'll try to deploy this YAML file again. Now you can see this is created. And now if I do kubectl get pods, I will have 6 different pods, right? Kubectl get pods. It will show me 6 different pods. 3 of the type test, because I have 3 replicas here, and 3 of the type Nginx deployment. Now what I can do here is I can change the number of replicas, and the replicas which we'll be creating will be different here. So we'll do that as well. We'll go to nano again. We have to create another one, right? So we'll copy this. We'll just copy this again. We'll create another deployment, and we'll call this just not.yaml because I don't want to type. Not.yaml I've opened. I've copied this here with Control C. I've gone back to my terminal. I've just pasted it in here. Control X, then I'll open it again for better readability. And I have to mention here apps/v1, and the name will be Nginx deployment replica test. So we'll call it Nginx rep, and inside of replicas I'll change the number of replicas to 2. So this should create another deployment which has 2 replicas, right? So it was called not.yaml, right? So we'll just type it right here real quick. Our deployment was created, so we'll just get pods to see. As you can see, now the rep has only 2 replicas, as we defined the replicas 2 in that file, right? If you see the YAML file again for not.yaml, we have replicas as 2. That is the reason why it has 2 replicas here. So you can see how important YAML is while creating anything inside of it. Although we have not learned about deployments and stuff like that here, but I wanted to show you the importance of YAML files so that when I am working in future on different YAML files, you create those YAML files with me. You type those out, even though I would be copy pasting just to save time, because if I type everything and go about it, it will take a lot of time for me to explain and a lot of time for you to watch. You can just see it and start typing so that you get better hands-on on it. Also, you can either just go and copy paste. It's your wish, totally up to you, but I'd recommend you to type it out a couple of times, right? Okay, then now we can go back and move on to our next section. So there are a few additional concepts that I wanted to cover before we move on to the more interesting side of things, that is performing the hands-on. Even in YAML I said that, but I did show you a little bit of what you can do with the Kubernetes, right? So moving on, we'll be covering few concepts here so that you get a better understanding of things, and in the next module we'll be hitting the dime. Okay, so there are a few additional concepts that we must touch upon before we get into the depth of Kubernetes, namely namespaces, labels and selectors. If you remember, inside of the YAML file, we saw the labels as well as the selectors in there. There are the field selectors and there are some annotations that you should know about, right? So let's begin. With name, each object in your cluster has a name that is unique for that type of resource. Every Kubernetes object also has a UID that is unique across the whole whole cluster. So if you remember, we were using the name as deployment, and I showed you this in the hands-on section. So when we tried to make 2 things with the same name, it said like you cannot make it, as Nginx deployment already existed. And when we changed the name of that, it started working again.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So name is what you give to the each object in your cluster. So my deployment had the name Nginx, and it can have multiple replicas of it. It will have an extended name which will be different, but all of that will be inside of Nginx deployment, right? So that is the name. So if you create a similar deployment with the same name, it will not work for you. Then only one of the object of a given kind can have a given name at a time. So this is what I've been mentioning. I showed you last time around that you cannot do this. However, if you delete an object, you can make a new object with the same name. So if I had to delete that Nginx deployment, I could have deleted that and created a new Nginx deployment with the same name, maybe with multiple replicas or something. So a Kubernetes resource can have names up to 253 character long. So you can have up to 203 characters, but you generally don't use that much. You can use proper names for it. And then moving on, every object created over the whole lifetime of a Kubernetes cluster has a distinct UID. Now, this is a very important thing because it is intended to distinguish between the historical occurrences of similar entities. So let's say we created, I told you we can create, we deleted that Nginx object, right? So we could have created a new Nginx object with multiple replicas. Now, instead of 3, I would have 5 replicas. Now, what is to say how that was different from the original one? So here is when UID comes into the picture. Even though you can create new objects with the same name if you have deleted the old object before, but it will have a distinct UID. The UIDs will be different for both of these to have a distinguishing factor between the historical occurrences which in between the two objects that we created, right? Then next is the namespaces. Now, if you remember, while we were working with YAML files as well as when we started with talking about the namespaces. So I told you kubectl get pods -- all namespaces. Inside of that, you had different namespaces inside of it. So there's a kube system, then there is a default namespace. So we can just see that quickly right here, real quick. We'll just type kubectl. So let's really quickly have a look at it. So we'll type kubectl get pods -- all namespaces, right? If I do that, and you can see this is the namespace, right? So inside you'll have a default namespace and under which my Nginx deployment and all of the deployments that I made during that YAML file introduction, these are inside the namespace which is default. And then there is kube system namespace, inside of which there are pre-created pods in there, right? So these are all the pods which are running inside of different namespaces. Now this is done because the namespace are the ways to divide cluster resource between multiple clusters, and Kubernetes supports multiple virtual clusters backed by the same physical cluster. These virtual clusters are known as namespaces. So physically we have a lot of clusters, but behind that also we have virtual clusters, and namespaces are a way to define those clusters. So inside one namespace which is default, I deployed all of my deployments which I created. They go under the namespace default. Then there are few pods which are already running inside of kube-system. That is another namespace. If I define more namespaces, I will have more namespaces described inside of it, right? So namespaces are intended for use in environments with many users spread across multiple systems. Multiple teams or multiple projects. For clusters with few to tens of users, you should not think about creating a namespace because it's not that important. But if you have a giant team, let's say 100 people are working on the same thing, then that is the point you will be needing to define namespaces, because it is good for creating that differentiation between the virtual clusters, right? Then namespaces provide a scope for names. Name of the resources need to be unique within a namespace. As we were saying, the names that we defined inside of a namespace, two things cannot have the same name, right? But across namespaces, you can have like different names. So what we meant here is the name of the resources need to be unique within a namespace, but not across namespaces. I can have Nginx deployment, only one kind of Nginx deployment in the namespace default. Let's say if I had to create another Nginx deployment with the same name, the one way I can do that is either I have to delete the old object and create a new one in the same namespace, or I can change the namespace and create it somewhere else. That is the way it can work. Namespaces cannot be nested inside one another, and each Kubernetes resource can only be in one namespace. So that is another very important fact. Then coming on to labels and selectors. Labels are key value pairs that are attached to objects such as pods. So while creating the YAML file, you must have seen that I've shown you the labels and the selectors inside of the file. We can have a quick glance at it real quickly. Right here, you can see labels, and this is the selectors and match labels we have mentioned here. So this is, you generally define it for a pod. So the replicas are defined for my pods right here, right? So coming back to the slides. So this is generally created for things such as pods, and these are intended to specify the identifying attributes of an object that are meaningful and relevant to the users, but do not directly imply semantics to the core system. So it is usually for identification purposes, and these are the identities, these values which we are identifying are mostly, let's say, these are mostly concerned with the user. Like the users are concerned with these, not necessarily that it impacts the system in any way or impacts the semantics of the system in any way. So unlike names and UIDs, labels do not provide uniqueness whatsoever. In general, we may expect many objects to carry the same labels. You can define labels inside of metadata as labels like this. I've showed you in the YAML file before how you can define that as well. Through a label selector, the client/the user can identify a set of objects. The label selector is the core grouping primitive in Kubernetes. The API currently supports two types of selectors. One is the equality based selector and the other is the set based selector. We'll discuss that now. So equality or inequality based requirements allow filtering by label key and values. These generally what they do is they'll be matching the objects that must satisfy all the label constraints, though they may have additional labels as well. So when I'm using the equality based selector, what I'm looking for is the objects which will be having all of the defined labels that I want. So let's say if I want the label as label 1, label 1, label 2. So it will get all the objects that will have label 1 and label 2, but that can have label 3 and label 4 as well. So it will get all the objects that have label 1 and label 2, but it can have more. But let's say if I have an object that has label 1 but not label 2 but label 3 and label 4, and I'm looking for label 1 and label 2, that object will not be fetched. It will only fetch those objects which have label 1 and label 2, right? Then there is a set based labels. This basically these requirements allow filtering the keys according to the set values. So you can have a set of values that you are looking for. Three kinds of operators are supported in this: in, not in, and exist. Only the key identifier. If something exists in a label or not, if something is in the label or not, if something is not in the label or not. That is the set based requirement. Moving on to field selectors. Field selectors let you select Kubernetes resource based on the value of one or more resource fields. So field selectors are essentially resource filters. By default, node selectors / filters are applied. So if you do not define it, by default there are no selectors or filters applied, meaning that all of the resources of the specified type are selected. If you specify a type of resource, everything will be selected if you do not define a field selector, right? So you have to define it. By default, everything will come inside of it. Finally, the last concept on our hand here is annotations. Now, annotations are not used to identify or select objects as labels do, as I mentioned earlier. But annotations can be used to define metadata. So it can be large or small, it can be structured or unstructured, and CAD includes characters that are not permitted by labels. General use of annotations is to define the build release or something like that. You can have this information somewhere in the backend directory, you can refetch, but some people choose to define these metadata in the form of annotations. So that is the actual use of the annotations.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. Kubernetes is written in which of the following? A. C++, B. Go, C. Python, D. Java Spring Framework. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides Kubernetes Administrator Certification Training course mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Kubernetes is one of the most sought after container orchestrating tool in the world right now. Almost all of the organizations who are using containers are using Kubernetes as the tool to orchestrate those containers, and hence kubectl is an integral part of it, where you can use it as a command line interface to interact with your Kubernetes cluster. So the first command is create. So what do I mean by create? So Basically, what I mean by first command is the simple fact that if you see on your screen right now, the kubectl will be the starting of all of these commands. So the first word that you write will be kubectl. So it basically tells you that this is being interacted with the help of kubectl. So kubectl will be there, and the first thing that you write after that is create. Now, create is a command which is used to create resources from a file. It could be of the file .json, or it could be of the type .yaml. Either way is accepted. Other use for create is also there, so you can use create to use a lot of different things. So in this, when you are using with a file, the syntax is kubectl create -f and then the file name, and it creates those resources inside of those files. But create can be used to do a lot of different things. You can create service loads balancers, service node port, service account, cluster role binding, config map, cron jobs, deployment, namespace. All of these things can be created using this command. There's another thing that you can use to create files configuration as well. So you use kubectl apply, and using that apply, you can apply some configurations to your cluster as well. So that is something else that you can use. So you can use for creating resources from a file, you can use create or you can use apply. So let's quickly try creating a file using kubectl create. So I have my Kubernetes cluster here up and running. I only have one node right now. Let me show you that really quickly. Kubectl get nodes. So this shows you the number of nodes I have. Just wanted to show my cluster is up and running. Now let's create a file. So I have a file ready in here. So this is a YAML file for deployment. So a YAML file for deployment, basically this has the specifications of the deployment that I want to create. So it has the name of the the kind is deployment, and the name is Nginx deployment. That is in the metadata, and it has 3 replicas. So basically it will spawn 3 pods, and you have another match labels, you have images, you have container specifications and things like that, right? So let's create this file. So in order to do that, I will switch to my terminal really quickly. I'll have copied this. I'll move to my terminal really quickly. Now in here, I will type the command nano t2.yaml. I'll just paste this particular YAML file which I have really quickly. And once I've done, I will just save it and I'll exit. So my file is ready. Now what does the command say? The command says kubectl create -f file name. You can see right here, right? Kubectl create -f the file name. So we'll do that. Let's quickly go to the file. Kubectl create -f and the file name, which is t2.yaml in our case. Once I do that, you can see the deployments has been created. Now, if I check for pods, so I have 3 replicas in my deployment, right? So I have 3 replicas in my deployment. You can see, so it has created the deployments and it has created everything. So you can check by kubectl get deployments. This is Nginx deployment, which was created, is up and running. Cool. Let's move on to the next command. So I was talking about this, right? So you can use create to do a lot of different things. Like you can create a cluster role, you can create role binding, secret, a lot of different things. All of these things which are mentioned here can be done with this.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
But the syntax will be a little bit different from what we did just now. So I have that syntax ready for you as well. So if you wanted to say, let's say, create a deployment with the name and you can give this image. So the syntax for it would be kubectl create, then whatever that you want to create. So if this was a deployment, it's a deployment here. If it was a cluster role, it will be cluster role. If it's a secret, it will be a secret. Then here the things will change accordingly, according to whatever you are creating, right? So this will change. For deployment, it will remain deployment's name and -- image, and whatever the image that you are pulling, that image, and then the commands and arguments. So like for example, you can do kubectl create deployment and call it my deployment, and image of nginx and replicas equals to 3. So let's see what happens when we run this command. So let's bring up our cluster, kubectl create, let's bring on top of it so that it's better for you to understand. So you can see kubectl create deployment, name it deployment. I will say name it my dep -- image equal to nginx -- replica equal to 3. Let's see what happens. As you can see, a new deployment is created with the name of my dep. So if I do kubectl get deployments, now I have another deployment coming up. As you can see, the Nginx, which was created when we did the before one, and mydep, which we created just now, has been. So you can use create commands in the way to create something from a file, or you can create some another resource with some arguments and some names and everything that you have to keep in mind about the syntax. Using these syntax, you can do this. So this is one of those commands. Let's move on to the next command, which is kubectl get. So we've been using get now exclusively. So we are doing kubectl get pods, kubectl get pods wide, and different things like that now. So basically, get command, what it does, it prints a table of most of the information about the specified resource. For example, when I was doing kubectl get deployments, it was getting the information with respect to the deployments. You can filter the list using the label selectors, and you can use selector flags, and you can do a lot of different things. So let's say if I wanted to get deployments from a particular environment or namespace, we can do that as well. So that can be done. If the desired resource is in the namespace, then only you will see those results, otherwise you will not. And if you want to see all namespaces, then you have to pass the parameters, which is --all -namespaces. Let me show you how that works. So the basic syntax is kubectl get and the resource name. So let's start with the basic one. I'll show you all of these commands really quickly. So kubectl get pods. You can even type get po, and that will also work for pods. I'll show you. Get po. Oh, sorry. Kubectl get po. This will also work, and kubectl get pods will also work. Both are the same thing. You can see same results. So we are getting pods like this, right? And let's say if you wanted to get some particular pods and you wanted to pass some particular thing, then you can have that as well. But let's say if I wanted to, this is getting me all of the pods in the default namespace, because that is the namespace that I've designed. But let's say if I wanted to see pods of all namespaces, so what you can do is kubectl get pods -all -namespace and pass this parameter. You can see the S was missing, namespaces, it's namespaces. So you can see all of the pods which are there in different namespaces. You can see which all namespaces it belongs to. So default ones were the one which were coming here, and there are kube system is another namespace which we have, and you can see all of the pods which are there in various different namespaces. I have started also spawning, right? You can do that as well. Another thing that you can do is kubectl get pods -o wide. Now what's that command? We've seen something here which is -o wide. So this basically returns you all of the pods with more information, like all the pods which you have in with more information. So you can see before what we were getting is, let's say, the name, the status and restarts and the age. Now we are getting all of those plus the IP plus the node that it is on, plus the nominated node and readiness gates. So we have all the information coming in, and that is with the -o wide. So if you want to get more information with respect to any particular resource, then you use the flag -o wide, right? So that's that. And you can get services, deployments, anything. So you can get kubectl get deployments. We saw that before. You can also get services, kubectl get services. You can get ingresses. You can get basically anything that you want, which you can if you want to print something. There's like a print statement for the resources that you have, and that is how it works, right? So that's that. Let's move on to the next command. So we got done with get, right? So next one is expose. Now what you can do with expose is like whenever you have a Kubernetes service running, right? So if by default it is on like the cluster IP interface, and your deployments and everything which are not on the exposed end, it is not reachable externally. So let's say if you wanted to expose a resource as a service to an external point, then you use the command expose. So basically it looks up a deployment service replica set replication control or a pod by name, then uses the selector for that resource as a selector, and it sends it to a new specified service point. For example, let's say my deployment, I have created a deployment right now, right? But that deployment resides inside of my cluster. Nobody from the outside world can see what is going on in there. That's the problem. What if I wanted to, make it externally reachable, so that somebody who can type in the port numbers or the link or the address, whatever it is, they can reach the particular deployment. So what I'll do is I'll expose that deployment as a service at some given particular port, and using that I can reach it externally. So let's try to do that. So the basic syntax for that is kubectl expose, and then you can have the type or the file name. So for example, here the deployment is the type name of the resource that we are providing, deployment and the deployment's name then you have to give. So deployment and deployment's name is nginx and -- port 80, that is the port that it is currently serving on, and the target port is 8000. So you have to provide both in order to do that, right? So you can do that really quickly. So let's expose us deployment that we have right now. So I'll open. So let's run this command. So kubectl first let's get the deployment. Okay, we have the name of the expose deployment. Let's say my dep. We will expose my dep -- port equals to 80 -- target port equals 8080. You can see a new service is created. So if I do kubectl, now to get service, you can again type a get svc or get service, both will work. You can see a new service has been created with the name mydep, which was the name of my deployment, and it has been exposed to a port 80, which was there initially, right? So that is the idea behind it. So that is how it works. You can also expose it as a particular type of service, which can be externally reachable IPs as well. That can also be done. So, but that is not required for now at the moment. But just know that you can expose your deployments as a service. So my service deployment was exposed. So my deployment was exposed as a service on the port 80, right? So that is that. Let's move on to the next command, which is delete. Now what you can do is you can delete some resources as well. So a lot of times you'll be requiring to delete resources, and it depends on what you're deleting that will determine what all will be deleted. So let's say kubectl delete, and then you can have the file name -f file name, you can have -k directory, you can delete an entire directory, or you can have a type or label and you can delete particular things. For example, if you wanted to delete pod, so kubectl delete pod, and then the pod name will delete a specific pod. But let's say if I wanted to create everything created by my deployment, so that is my deployment should also be deleted. My number of pods created through that deployment should also be deleted. So I can delete a file. So kubectl delete -f t2.yaml will result in all of my deployments with respect to the Nginx deployment being deleted, as well as all of the pods which were created will also be deleted. So and you can delete things with the help of label as well. So you can see this example in here, which is on the bottom left side of the screen. Kubectl delete pods, services -l. So you are deleting pods and services which have the label where name is equal to my label, or by the label name equals to my label. So wherever this exists, all of those pods and services will be deleted. So you are passing it as an argument. So these particular things I want to delete. Let me show you these really quickly so you get a better understanding of things. So first, let's try to delete the deployments that we have. So let's see what all do we have. So kubectl get deployments. So we have 2 deployments right now, and kubectl get pods. And you can see we have 3 pods coming from the Nginx deployment and 3 pods coming from the mydep deployment. This is according to the replicas that we created initially. Now let's say that I wanted to delete the Nginx deployment and all of the pods associated with it, right? So all of the pods associated with it. So what do I do is kubectl delete -f t2.yaml, because these things I created through a YAML file, right? So I'm going to delete that particular file. So what happens? Let's see. So you can see it has deleted the deployment. So if I get kubectl get pods now, terminating, you can see. And if I do kubectl get deployments, only one of the deployments is remaining. If I do get pods now, you can see my Nginx 3 of them have terminated, only 1 is remaining. And in a second, I think the last one will also be gone. So that is basically how you can delete all of the everything which is created from that file will get deleted if I do that, right? Now, what if I wanted to delete a particular pod, right? So let's say kubectl get pods. So this is the mydep pod name. So this is the pod name. So if I do kubectl delete pod and then the pod name, so you just copy that. So the problem with this one will be that since it's a deployment that we created, that is the mydep is a deployment, so it will keep respawning the pods. But you can see, just notice the name 4DZZ4, it will not be spawning once we delete it. Let's see. So it has deleted a pod. It will take a couple of seconds. We'll just give it a couple of seconds. So it has deleted a pod. So if I do get pods now, I will still get 3 pods from the my deployment kind of thing, but none of them would be this particular pod that we deleted, like 4DZZ4. You can see that particular pod is deleted. Since that is the feature of deployments that we keep on, it will once you specify, let's say I want 3 replicas at all time, no matter if it gets deleted or it stops responding or whatever, Kubernetes has this capability where it respawns the pods constantly. So that is the advantage of using deployments. That is why people prefer using deployments. So if your pod fails for some reason, Kubernetes automatically restarts a new pod for you. So that is that. So this is the kubectl delete command. Let's move on to the next one. So the next one is autoscale. So you can give a command to autoscale. So you can autoscale your deployments, and basically it creates an autoscaler that automatically chooses and sets the number of pods that run in Kubernetes cluster, and looks up deployment, replica sets, stateful sets, as well as replication controllers. So all of these four you can autoscale, and it basically gets them by the name and creates an autoscaler that is given with for the resource as a reference. So let's say if I say I want to autoscale deployment and then deployment's name, and I will define how many minimum or maximum pods I need. So this is basically done because let's say if you are Grofers or if you are Flipkart or Amazon, you don't get the same number of people trying to access your website every single day, right? It will not happen that every day you will get the same amount of traffic, but sometimes, let's say during a sale period or during some festival season, you will get a lot of traffic coming to your particular website. So how do you know that when it's going to hit, and how do you autoscale? So you can basically tell Kubernetes that whenever, let's say there is huge amount of traffic coming, so let's say if there is something you can define. So if let's say my pod can handle 3 requests at the moment, and for example during a sales season that 3 becomes 6, my Kubernetes autoscale command will basically enable my pods. So let's say I have only 3 replicas, it can automatically scale up to 5, 6, 7, 8 just to serve the requests. It can basically do that. So it has that capability as well of auto scaling. So you can do that with the help of Kubernetes as well. Let's move on to the next command, which is scale. So I'm moving on to the next command because I cannot show you auto scale right now. I can show you scale. I can show you how you can improve the replicas. And basically what you have to do is you can scale for a new size of a deployment, replica set, replication controller, or stateful set. Works for all of these 3, and basically allows you to specify 1 or more preconditions to scale also. So whatever you need, you can replicate that as well. And basically if you wanted to manually increase the number of replicas that you have, then you use the command scale. So very simple command. So the syntax for it is kubectl scale, and the resource resource version equals to version, and then current replicas count, and then the replicas count and file name and type. So let's try this out. Let's see how this works. So I'm going to be opening my terminal again. So I have a deployment which is running, which is my dep. So kubectl scale replicas equal to 4, and then it says to write the file name and or the type, right? File name or the type name. So replicas equals to 4, and then we are going for my deployment, which is of the name my dep. Let's see. As you can see, it says the deployments was scaled. So I had 3 pods running before. Let's see what happens now. Kubectl get pods. Sorry. As you can see, 1, 2, 3, 4. It has scaled my number of replicas just by a ping of a command. And you can do the same thing with the help of autoscale, where you can define the number of replica sets that you want. You can, in here you can define minimum 2, maximum 10. So at all times it will be minimum of 2, but based on the service request, it can be scaled up to the maximum of 10 to serve all the service requests. So that is the use of the scale command. Okay, let's move on to the next one, which is called describe. So as the name suggests, it's prints out a detailed description of the selected resources, including the related resources, events, controllers, and whatnot, right? So if you are going to get the detailed information for, let's say, one particular resource, then you use the command describe. The syntax is pretty simple and pretty straightforward. So you type kubectl describe, and then you write the type of the thing that you want to describe. So let's say if it's a pod, so kubectl describe pod, and then pod's name. So whatever pod you want to describe, you mention the name, right? And if it's a service, then you write kubectl describe service, and then the service name, kubectl describe deployment, and then the deployment's name. So whatever it is, then you go ahead with that, right? Let's quickly dive in and see how that works. So we have, I'll clear the screen so that, because the describe will give you a lot of information, that's why. So kubectl get pods. That is just to get the pods name. So that's that. Kubectl describe pods and then pod name. Right? It returns the entire information with respect to the pod. So everything for this pod has been here: the name, the namespace that it is in, the priority it has, the node where it is residing, the start time, the labels it has, the annotations, the IP, the controllers, the ID, container ID, image ID, and what ports it is on, if it is being pulled, restart counts, when was it, type of the conditions like initialization is true, container is ready, true, pod schedules true.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
And normal everything, all of the events that has happened with respect to this pod and everything, the volume mounts and everything about this pod you can find in here. That is what describe is used for. So when you want detailed information of a particular resource, you go for describe. That is the basic idea behind that. Let's hit clear and move on to the next command. So next command is logs. So basically logs, as you can suggest, it prints the log of a specific pod or a resource. And if the pod only has one container, then the container name is optional. So when you can have pods with multiple containers also. So if they are multiple containers, then you would have to specify the container name as well. But if you have only one container, then it's fine, right? It's optional then. If you wanted to get, so the syntax for it is kubectl logs, then -f, -p, depending on whatever that you are using, the pod and or the type name, and the container name that you want. So if you want to get all of the containers in a pod by the label app equals to nginx, then what you do is kubectl logs, then -l for the label, and then the app equals to nginx -- all control containers equals to true. So what we'll do is we'll try to get logs of one of our containers, and let's see how that looks like. So it's kubectl. Let's get pods first, that we can copy the pod name. Yep. So kubectl logs -f pod, because I think we can give the type name. Yeah. So we can give a pod or type name pod, and then the pod name, which is, let's say, this one. And since I think it has only one container, so I don't think I need to give the container flag, so it should work. Maybe we don't need to specify pods in here. So you can see the logs with respect to this has been printed. So you don't need to give the name, you just need to give the name of the resource and it will work. So that was the logs for this particular thing, right? So don't need to give that, and you can directly go ahead with that. We could have given some label, but we just went with the resource name, right? So that is that. Let's move on to the next command, which is exec. Now exec is something which is used to execute a command. Even you can use exec to get inside of the containers as well. So you can get inside the containers, you can change different resources in there. So you can use exec command for that. So basically any commands that you want to address, you use the command exec. And the syntax is very simple: kubectl exec, and then the pod or the type name, and then you have different flags which you can put in. For example, kubectl exec my pod, and -- date, it will give you the running date of the pod. Let's quickly try that. Yes. Kubectl get pods, kubectl exec, then your pod's name, and then whatever the command that you want, right? It's not clear. I just wanted to move this here so that you can see the command, and the way I'm typing is the same. Exec, and then any pod name. So go with this pod, go with this pod, -- you can see Wednesday, deck 9, everything with respect to that has been delivered.
What is an ingress? So guys, as we learned earlier what an ingress is. So an ingress basically is used when you have multiple services on your cluster and you want the user request to be routed to the service based on their path. Okay, so in those cases you use ingress. So for example, if I have to go to intellipaat.com/image, so the intellipaat.com domain will point to my cluster, and my cluster should know where exactly should this request be pointed to. right? And that job is done by Ingress. So when you look at this diagram, guys, this looks very simple, right? There is nothing out of ordinary into it. You might be like, okay, so there's an ingress component, and in that ingress component, probably we are defining rules where, if it is /image, it goes to the first service. If it's /video, it goes to the second server. But it's not like this. It's not that simple. So this is the whole architecture of what is going to happen. Right. So say you're a user, you will first be reaching out to the Ingress service. So Ingress is just like another pod that you deploy on your cluster. Okay, it is a software which has to be installed, right? So that software is called the Ingress controller. So once you've deployed a pod for the Ingress controller, now the Kubernetes rule says that the pod cannot be directly exposed, right? It has to have a service. So what we do? There is also a service for Ingress which is created. So this service is node port so that it can be accessed by the outside world, right? But the services that we saw inside, the services for the applications, earlier what we were doing was we were directly accessing the service, right? But when you're using an Ingress, the rule says that a service has to be, or it should be a cluster IP, so that the services cannot be accessed directly. They can only be accessed through the Ingress. Okay, so what you do, you define the services to be of the type cluster IP. Okay, so cluster IP basically means that they cannot be accessed from outside of the internet. But since the Ingress controller can access these services, right, and the Ingress controller is exports, that's how you would get to see those services through the Ingress controller. All right, now you create the Ingress controller. Next step is, this is what you have to define. You have to define rules. So rules are not defined inside the Ingress controller. The rules are defined separately. Okay, so we'll see how we can define rules for Ingress later in the slides. But for now, in this architecture, as you can see, the user sends visits or when he sends when he enters the URL into the browser, that basically gets redirected to the Ingress service. Ingress service in turn forwards the request to Ingress controller, which basically checks the rules, and based on rules it takes a decision as to where the request has to be sent. If it's intellipaat.com/video, then it'll go to this particular service, and if it's intellipaat.com/image, it will go to this particular service. These services in turn act as a load balancer to the pods which are beneath them, and hence your request is being sent to from the pod through the service, through the Ingress controller, through the Ingress service, and that's when it reaches out to you. Okay, so this is how an Ingress works full-fledged when you're working in a Kubernetes cluster. Okay, now let's go ahead and see how can we install the Ingress controller. Now for installing the Ingress controller, guys, there's a GitHub page for the Ingress controller which we want to use, right? And that's Ingress controller is Nginx. So we'll be using the Nginx Ingress controller, which is again open source, right? So you can use this Ingress controller and you can basically install it on your system. So let's see how we can go ahead and install Ingress controller. So all right, so let's jump to our browser and let's go ahead and see how we can download the Nginx Ingress controller. So what you have to do is go to Nginx Ingress controller, just search for this. Okay, you will see this GitHub page. Just click on that GitHub page. Once you click on that GitHub page, just scroll down and go to deploy. Okay, now in deploy, open readme and go to docs deploy, and here is the installation guide for Nginx Ingress controller. Okay, now I'll make you go through this installation guide so there are no confusions as to what is being done. All right, so this is the command which is a mandatory command. So this command you have to run irrespective of the fact where your Kubernetes cluster is basically existing. If it's existing on Google Cloud Platform, if it's existing on Azure, if it's existing on AWS, it does not, or if it's a bare metal server, it does not matter. Just execute this particular command. So we'll just copy this and we'll execute it on a server. All right, so some steps have been done. I'll explain you what all had been done when you basically executed that particular command. Coming back, so now that you have executed the mandatory command, let's go down and read what else has to be offered by this documentation. Now it says provider specific steps. Now what does that mean? That if you have a Mac system and you are running the cluster over there, right? And if you have installed Docker for Mac, in that case you would run this particular command, but that does not apply to us. If you are running the cluster on Minikube, then this is what you have to run, but that does not again imply to us. Again, if you are on AWS and you have installed your Kubernetes cluster using KOps, right? So in that case, if you want a normal load balancer, classic load balancer, you would be executing these two commands. If it's an application load balancer, you will be executing these two commands. Okay. After this, you will see that there is a network load balancer. If you want to launch a network load balancer, this is the command. If you are on Google Kubernetes Engine GKA, you will be executing this particular command. If you are on Azure, you will be executing this particular command. But we are on bare metal, right? So we would be executing this particular command. And I'll take you through what is exactly happening over here. So I'll execute this command over here and hit enter. So it says service ingress nginx created. Okay. So now let me show you what is actually happening. So when you basically execute the mandatory command, which is this one, you basically get your pods created. Okay. So your pods are created. Some roles are created. Don't get into roles because you haven't studied that. Just understand that the pod for your cluster is created. Okay. Now what is the next step? When you have a pod, you cannot access it directly. You need a service for that, right? So that's what the secondary command or the second command which we are going to run is basically doing, right? So if you're on Docker for Mac, you can see that you will be running this particular command. Let's go and see what this YAML file is. So if I paste this over here, can you see the type of this service is load balancer? And as you have already seen, if you type the type load balancer does not work on bare metal servers, right? So this command will not work on the bare metal server. Then we have Minikube. So Minikube has everything inbuilt, so you don't have to worry about this command. Second is AWS. So again, if we go ahead and see what this command or what this YAML file is actually, we just paste it over here. And you can see this is again type load balancer, right? So this is again not implied to us. Similarly, if I go to GKE, if I again go to this particular file, this is again deploying a service which is of the type load balancer. So we don't need that, right? Only when we are coming to bare metal, right? And if I just show you the YAML file for bare metal, can you see the type of the service is node port, and this is exactly what we want, right? And that's what happened over here back in the terminal as well. First, the mandatory command, it installed all the pods, and the second command that he executed, it basically created a node port service for me so that I can access the ingress from outside. Okay, so let me just check one thing. Okay, so now if I go to kubectl get pods -- all namespaces, you can see that there is a nginx ingress controller pod over here, right? So this is what you deployed from that particular command. And now if I go to kubectl get service, actually all namespaces, so you can see that you have a service for Ingress Nginx, and this is the node port for that particular service. Okay, so what we can do now is let's go to this node port and see what is happening. So I'll just go to this node port. Let me just copy the IP address, go to this IP address along with the node port. So the node port is this for the Ingress service, right? Let me paste it here. It says the plain HTTP request was sent to HTTPS port. Okay, so as you can see over here, this is a 443 port. 443 port basically means the command that we have to run is HTTPS. Okay, so once you go to HTTPS, you will see a page like this. Just go to advanced and click on proceed. Okay, so that page says 404 not found. Now what is this page? 404 not found. This is coming because you have not defined any rule on your computer. This page is similar to what you get over here. So say I go to Intellipaat.com and say I type /897. So what will happen? it'll basically show me a default page for 404, which basically means what you're searching for is not available. So it says, oops, we are unable to find the page you are looking for. Similarly, if now I type in say 456, right, I'm getting the same page again. Similarly, over here, if I type in this 12345 slash 123456, I get the same page. If I type in slash 5446, again I get the same page. Why? Because this is the default page. Now if I don't want my user to see the default page, I will have to define some rules. So how can I define those rules? So let me come back to my slides. The rules can be defined with a YAML kind of file. So we can deploy, like we created services, like we created deployments, we can also create an ingress rule by writing a YAML file like this. Okay, now I already have a YAML file commands in place, so I'll just have to copy, but let us discuss all these commands one by one. So what do? You first mention the API version for the ingress, which is extension /v1 beta 1. Okay, once you mention that, then you specify the kind of YAML file which it is. So it is the ingress kind of YAML file. So you mention that. Then you specify the metadata, the name of the ingress rule. So this is simple fan out example. You can put any name that you want, right? Then you talk about the annotations. So annotations basically will talk about where do I get all these properties from the installations, right? So this is the annotation. You don't have to test it. This has to be exactly the same for it to work. Then we talk about the specification. So what specification will this ingress rule have? So in specification, we define rules. And the first rule that we define is for the HTTP connection. And the path says, if the path is /FOO, then in the backend, it should reach this particular Nginx service, which is available on this particular port, which is port 80. Okay, so this is a similar kind of thing that we are going to do now. So let me just go ahead and open the notepad file. So one second. Okay, so guys, so this is my notepad file and it has the exact same ingress what we have over here written over here. Okay, so let's change the name to say Intellipaat -ingress. Okay, we specified this, and then in the backend, if I want to reach out to the service name, let's change the path to Nginx, right? And the service name is Nginx, the service port is 80, and of course I'll just have to check if I have an Nginx service in place. So the service is kubectl get service. Okay, so I don't have the Nginx service running. Let me check if I have the pods, kubectl get pods. Yes, so I have the Nginx pods, but I don't have the Nginx service. So what I can do, I'll just say kubectl create service. And remember guys, this has to be cluster IP if you're using it with Nginx. Cluster IP, name of the service is Nginx, and then you specify the ports. TCP equals to 80:80, right? Let's just fix this and hit enter. So your service is now created. Okay, so if I go to kubectl get service now, I have the Nginx service, which is basically on this cluster IP, and this is the port. Okay, in the rules, as you can see, the service name is Nginx and the service port is 80. Awesome. First, let's try with these rules. Let us copy these rules, go to our terminal, and let's create a file. So let's create a file called nano demo.yaml. Okay, let's copy the description or the code over here. So let's save it. And now let's create it. So kubectl create -f demo.yaml. Okay, I'll hit enter. And as you can see, the ingress is created. The ingress rule is now created. And similarly, if you see over here, this is exactly what we did. It says ingress.extension /simple fanout example created. And over here I get Intellipaat ingress created. Reason being, the name of the ingress which I specified in the YAML file was Intellipaat ingress. Okay, now if you want to check the rules whether they are ready or not, you can type in the command kubectl get ing. So if I type in kubectl get ing, you can see that I have Intellipaat ingress which is running over here. I also have this simple fan out example, so let me just remove that. So kubectl delete ingress simple fan out example. Alright, so ingress is that deleted, And we have the main ingress now that we want in our place, which is kubectl get ing, which is this. Okay, awesome. Now what is this kubectl ing says? It says that if I go to path /nginx, I should be able to see the nginx server. So let's do that. So I will go to my browser. All right, so I'm on my browser now, and what I want to do is I want to go to /nginx. Can you see we are seeing the nginx service? Let's type in /engine. So as you can see, it says 404 not found. If I type in http, 404 not found. Only on nginx it is showing me the service. Let's make it a little more interesting. What I'll do is I'll just go to my terminal and let's change the YAML file a bit. Okay, so let's add a path over here. So let's say I add a path and I say that if I'm going to say http, in that case let me define the backend. So the backend would go something like this. So the service name should be httpd and the service port should again be 80. Okay, so you might be wondering, I don't have a service called httpd. We'll create that, don't worry. So I'll just save this ingress rule, and now let's also change, or let us have a look at deployment.yaml. So let me do an ls over here. All right, so if I go to nano nginx.yaml, what I have to do over here is I have to change the values. So I'll change the name of the deployment as httpd, change the app also to be httpd, replicas, say I want just 2, the math labels, this should be httpd. Okay, again the labels would be httpd. Container that I want to launch, the name of the container would be httpd, and the nginx image, instead of this I want the httpd service. Okay, so I think we have changed pretty much everything. So, and the container port obviously would be 80. Okay, all right, so let's go ahead and let's deploy this kubectl create -f nginx.yaml. Let's hit enter. So it says httpd created. Awesome. Now let me just check kubectl get pods. So they are in the running state, and let me also check if I go to the IP address of this pod, am I able to curl something? So curl on the httpd. Okay, so I'm getting the it works message. Awesome. So the pods are configured properly now. Let's create a service for this. So let's kubectl create service, and the service name would be httpd, and the type of the service would be cluster IP. So let's specify that. Right, the port would be TCP equals to 80:80. Let's hit enter. Awesome. So my service is now created, and let me just go to the service as well to verify if everything is working fine. So this is my service for httpd, and if I go to this IP address, curl on this IP address. Okay, so I'm able to reach out to the pods. Awesome. Now I have edited the demo.yaml file, which was for the ingress. So all I have to do to update the rules is kubectl apply -f, and then I have to specify demo.yaml. Okay, so it says Intellipaat ingress configured. Awesome. So let's check it. So if I'm going to nginx, it's showing me the nginx page. If I'm going to some other path, it is showing me 404 not found. If I'm go to httpd, it shows me the Apache service. Awesome guys, so we now know how to configure and create an ingress controller in Kubernetes, and that was all the session that was about.
So what is GKE, right? So what is this Google Kubernetes Engine? So Kubernetes was something which was created for container orchestration and what's being used offline on premise with many people. So what people decided was, since the boom of the cloud era, we have AWS, Azure, and stuff like that. So all of these cloud platforms, like Google Cloud Platform itself, every cloud platform has now started providing their own Google Kubernetes service, so that it's much easier for you to go about doing things. Like Amazon has EKS, which is Elastic Kubernetes Services. Google Cloud Platform provides you with Google Kubernetes Engine, which is basically a Kubernetes service which you can use to create and deploy clusters on Kubernetes and do a lot of different things with it. You have graphs and stuff like that related to it. So let's have a look on it. So Google Kubernetes Engine, also known as GKE, is a cluster manager and orchestration system for running Docker containers in the cloud. Right? It is a production ready environment with guaranteed uptime, load balancing, and it includes container networking features as well. It allows you to create multiple node clusters while also providing Kubernetes features which are self-healing and what all we just saw. It provides you with all of that. So GKE does that. So if you go to the Google Cloud Platform and search for Kubernetes Engine, and this is what basically your screen would look like when you are looking at a Kubernetes engine. So you can see things that you should know is what is a cluster, what are different workloads, what is service and ingress. You should know what is a deployment, you should know what is a pod, what is a container, how different things work again, and what is storage and what is the configuration. So if you have doubts with respect to these, I'd recommend you to watch our previous video on Kubernetes, where we discussed about all of these concepts in detail with respect to architecture and YAML files and pods and deployments and stuff like that. We'll talk about a little bit about pods and deployments and containers right now as well, so that we have a clear picture before we get into the hands-on session. But it's more desirable that you learn the concepts so that you can understand what is going on in the hands-on session as well. So let's discuss some of the important Kubernetes concepts. So you need to know a few of these because we'll be doing that in the hands-on. So you must know what we are going to do and how is it working. Let's quickly talk about some of these important concepts. We have something called as a deployment round. With Kubernetes, it is very much expected that you will have multiple replications of the similar pod. So let's say one of my pods does image processing, right? I have putting the files of image processing. So what you want is when you're running a website or something like that, you will have a multiple number of service requests which are coming to your one particular pod. Now, a pod can only service so many requests at one time, right? So it won't be able to do it. So what people do is they create multiple replicas so that there is no downtime. So let's say I have 5 replicas. Now, these 5 replicas need to be maintained at all times. Now, these can be done either with the help of a replication controller, which is something which people use a lot. So replication controller's job is basically to create replicas of the replica sets of the pods. You can do that, or you can go for deployments. Deployments are basically an upgraded and higher version of the replication controller. They manage the deployment of the replica sets, which is also an upgraded version of replication controller. Now, they have the capability to update the replica sets with respect to the pods. You can go about updating different versions with the help of deployments. You can have rolling updates with respect to deployment, or you can roll back to the previous version using deployments as well, right? So let's move along. So deployment provides many updated features, like it has a lot of different things that your replication controller does not. And in Kubernetes master, the deployment controller basically makes it happen, makes all of the things happen, and it has the capability to change the deployment midway as well. So you can change the deployment midway as well, and you have something called as selectors and match labels to call application and stuff like that. So there is another, again, if you have to clarify all of these concepts, you have to visit that video. Talking about services, so as I mentioned before, so your pods, they have Kubernetes has an internal infrastructure where it communicates internally. So you do not have you have like a network proxy where if they communicate with each other, you do not know how they communicate, through which pipeline that so through which network communication that they are communicating. If you are looking from the outside, nobody can reach to my cluster unless I expose it. So there is 2 ways that you can go about exposing these clusters. So one is called as a service. A service is a defined set of logical pods. You can think of service as a set of logical pods that it does not show you where the actual pod is. It helps you interact with the pod without telling you where the pod is. So let's think of a gate where if you go to that gate and you tell them ki, I want to reach this particular destination, and the gate directly puts you on that destination. You do not know how you reach there, but it is basically helping you communicate with them. So it is giving you whatever you needed from that destination to your particular place, so you do not have to worry about it. It feels like you are communicating to the pod itself, but it goes through one particular kind of a gateway kind of thing, right? You can think of it like that. So it can be defined as an abstraction on top of the pods, which provides single IP address DNS name by which pods can be accessed, right? With service, it is very easy to manage load balancing configuration, and it helps to scale the pods very easily. Now there are different kinds of services as well. So you have a cluster IP kind of service, which is not externally reachable. You have a load balancer type of service, you have an external namespace service, and you have a node port kind of service. Now if you want to expose your ports externally, then you have to create the services of the type node port. It basically helps you expose your services. The other way to go about exposing your pods is creating an ingress. Now ingress basically it does a similar thing. It creates an external host for your particular application. It will create a pathway for you. So you can think of ingress as something which is on top of a service as well.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So Ingress is much better than services when it comes to exposing a pod. Again, if you have doubts, you can just refer that video and you'll get it clarified. Moving along, service is a REST object in Kubernetes whose definition can be posted to Kubernetes API server on Kubernetes master to create a new instance. The set of pods which are targeted by a service is usually determined by a selector. So when we talk about the YAML files, you will see that there is a field called as selectors, which basically helps you choose one particular application from the other.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let's say we have various different kinds of applications. I have 5 applications, but those applications I can call them through their selector. Selectors can be thought of as simple as name, you're calling through them some kind of a name. So that is something that you can do, right? We'll see example of that when we get into the hands-on session just now. So to create a specification for an object named my service which targets the TCP port 9366 on any pod with the app name is which is my app, you basically need to define a service which looks like the one on your screen. So this is what a service YAML file looks like. So you have defined the API version and you have defined the kind. So if it was a deployment, I would have written deployment in there. If it was a pod, I would have written pod in there. Since we are defining a service, the kind will be specified as service. Apart from that, we have a metadata, which is the name. And as you can see here, there is a spec, and inside the spec you have a selector, and in that selector we have called it is as my app. So if I want to call this service, I have to use the selector my app only, and through that I can call this service very easily. Other than that, we have given it the target ports and stuff like that. So whatever the target port is, and we can define where you want to expose it and stuff like that. So you have a target port for that, right? So let's quickly jump on and look at the GKE service itself and understand these concepts on a fairly hands-on level so that we can do better things with it. So let's quickly jump on there and then we'll see what we can do. So once you open your Google Cloud platform, this is how it will look like. It will show you the CPU usage, if you have used any APIs that you have called and stuff like that. All of the resources, instances that you have created, trace within the last 7 days, news, error reportings, and everything which is with respect to that. It will show you everything here. You can go to the navigation menu and see the various different things with respect to the cloud platform, but what we are interested in is Kubernetes Engine, so we'll search for that. So here it is. We'll just click on that. So we have one pre-made cluster which did not close properly, so that's why the option of deleting it is not here. Anyways, we'll go on and create a new cluster and just work on it and see how it looks like. So this is what your Kubernetes GKE engine looks like. Here you have the workloads, you have the services and ingress. So we have no workloads created as of yet. we have no such services created, we have no application, no configuration, no storage whatsoever. So you will not find a lot of things. You can free navigate from this place itself. So we'll come here to the clusters itself, and we'll try to refresh it once, and we'll create a new cluster. So all you have to do is to click at the new cluster. You can name your cluster whatever you want. We'll name it as cluster 2, and you can have it zonal or regional. You can choose the zone wherever you want this cluster to be, and these are all the zones which are available to you. I'm going to keep it as default. We will not change those locations. You can specify the default node locations as well if you want to, but we are not looking to change that. You can change the release version and you can choose whatever of these. And once you are done with all of this, all you have to do is click the create button right here. So let's quickly click that. So it will submit and take a couple of seconds to initialize your cluster. As you can see, our old cluster has finally disappeared and a new cluster is being created, and we'll just wait for the cluster to start. That should take about a couple of seconds, and we have to wait till our cluster is initialized before we go ahead and do something with it. So let's wait for it. Apart from this, like if you had some other cloud services, you can use similar way. And if you're using, let's say, an EC2 instance or using on Linux, you have to install Kubernetes services. But these platforms come with Kubernetes pre-installed, where you can create your plus clusters. Pre-made clusters will be created for you, and you can customize them according to your needs. And it should take about a couple of seconds to get initialized, and we'll just wait for it to work real quickly, and then we'll begin soon. So as you can see, finally our cluster has been created. Our cluster size is 3. We have 3 CPUs and 11.25 total GBs of memory data. And we have the clusters here. What we have to do here is we have to click on connect. As you can see, you have to run this in shell command line. So we'll be using the shell command line for our purpose only, for using Kubernetes as well. So we'll just quickly click on this. So it will open a shell on the bottom of your screen right here, and it will provision your cloud shell to your machine. So we'll just wait for that to happen. Once it is done that, all you have to do is press enter to connect your shell to that, and I think it's ready. Let's check. So let's do kubectl get nodes to find out if we have a working Kubernetes cluster. It's taking a couple of seconds. It's not initialized yet. The cluster 2 is still creating. Okay. So now our cluster has been initialized. So let's check if the cluster is ready. Kubectl get nodes, and you can see ready state. We have it in the ready state. So our Kubernetes cluster has been created. Now let us begin with the small different things. So let's do kubectl get pods. So we should not have any pods as of now. So we do not have it yet. Kubectl get pods. My bad. And as you can see, no pods have been created in the default namespace. So what we'll be doing is we'll be defining this particular YAML file. So if you are familiar with creating YAML file, this is a kind of a deployment. We have to define a deployment in this section where the version is apps v1. We have defined the kind as deployment. The metadata is Nginx. So we are creating an Nginx deployment, which has about 3 replicas in it. And we'll change the number of replicas to, for now, let's say 1 for now, so that we only create 1 pod, and we can change it later on. And we have other service also which is defined. So you can define all of that in one particular YAML file, so that you don't have to run a YAML file again and again and again. So as you can see, this is a service which is of the type node port, and it is looking for the port number, which is 80. So the target port for this service is 80. So this is basically doing that for us. So what we have the type as load balancer. Sorry, it's not node port, it is of the type load balancer. And as you can see here, so let's just quickly copy this YAML file real quickly and see what happens. So in order to do that, what you have to do is you have to create a file here. So let's call it nano test1.yaml. In this YAML file, okay, we already have a YAML defined in this one. So we will exit from here, and nano, we'll create another YAML file which is not of this kind. So let's call it gktest.yaml. You can say this is a new one, and we'll paste our particular file here. So we have copied everything from top to bottom, and all you have to do is save the file here. And once you have done that, you have to create this file. So whatever is in the file which we have defined, that is the deployment as well as the service, will get created. So command for that is kubectl create -f gktest.yaml, right? It'll take a couple of seconds. So as you can see, the deployment for the apps Nginx is created, the service of the types of Nginx is created. So if you want to check what all pods we have now, so let's do kubectl get pods. We have one Nginx pod running, and you can check the similar for the services as well. Kubectl get deployments or get services, get svc. Let's do it. Let's see how it is. And this is our service. So see, you can see the service type is load balancer here, and it is just pending. It has not been provisioned yet, so it's still in pending state. So we have to wait for it to actually run, so that we can go about making a few changes to it. And that is about that. So let's quickly, what we can do till the point being that now is we can get inside the Nginx, and we can what Nginx does is, when we can export this Nginx page, it displays an HTML page. We can edit that HTML page to display our own code and see how it works, right? So let's check again if our service has been initialized, and you can see the Nginx load balancer service has been initialized now, and it's on the external IP has been mentioned, and wherever it is, it's everything has been mentioned. So the next thing that we have to do is we have to get inside the pods, right? We need to change those particular thing. So let's get the pod that we want to get inside. Get pods. So if I want to get inside of this pod and see what all is in there, so I have to use the command which is called exec. So we have to do kubectl exec -it space the pod that you want to get inside of, right here, and then -- space /bin/bash. This is the command to get inside of the pod. Take a couple of seconds. As you can see, the Power BI has changed to root Nginx. So we are inside of this pod now. The pod that we defined, we are inside the pod now. So let's see what all things are there inside of this pod. So the command for that is ls. So you can see a lot of different things is there. So I know what is the path to the Nginx YAML file. So we have to get inside the user. So just like any other thing, we have to do cd user, then do ls again and see what all components are in here. I know it is inside of share, so you can do cd share, and in there we have to check what all is there in share. You can see a lot of different things is there, but I know that the file is inside of this folder called as Nginx. So I'll go to Nginx. In there, now what I have to do is check for ls again, and you can see there is a folder called as html. So we'll go to cd html and ls. So we can see there is two files. One is 50x.html and the other one is index.html. So what we have to do is we have to edit the index.html, that is the page which is generally displayed on the outside world, right? If you want, we can check it real quickly. We had a kubectl service defined at the external port somewhere, right? So this, if I go to this, it should generally represent the HTML ports. Sorry, it should show me the HTML screen. Welcome to Nginx. We are trying to move this page to whatever we wanted to create for this service. So that's why we are inside of this. So let's quickly look at what this how we can change that. So the command to change whatever inside the file is cat this arrow, then file name, which is index.html. And now you have to copy or paste the code that you want. So I have created a code right here which I want for my index.html. I will quickly copy that, and then I will go back to my page. Here I will paste all of the code, and the command to exit it with saving is Control D. So once I do that, it should register whatever the changes have been made. So we are outside of the file now. Now what we have to do is we have to exit the root, because we cannot run the commands here. We have to go to the command line interface, which is the kubectl commands won't work inside of here. We have to go outside, so we have to do Control D again. As you can see, we are back to our Power BI. Now what I have to do is just check if my service is still running. So kubectl get svc. So in here we still have the external IP which is working, and we'll just copy this real quickly and see if that changes things. So still not. So finally the change has been made on the same IP address which we copied. As you can see, 124 right here. So now welcome to GKE test. This was created by Intellipaat. So we changed this. So this is how you basically use a pod. You could have a lot of different things inside of the pod. As we saw right here, we went inside the pod. We made a few changes to things here and there. And then inside of that, I changed the page where we were putting our code to, and we created it. So this is hosting my one particular service. It is not directly going to the pod, it is going through my service, and it is basically mapping it. So that is how you can basically use GCP platform, and that is how you can use Kubernetes. You can do various different things with it. You can delete these services and do a lot of different things. So let's try to delete something. Delete pod, or we can delete the file itself. If I want to delete, let's say I've created with that file, right? So if I wanted to delete two of the deployment, the deployment and the service together, all I have to do is delete the file. Delete -f. Then what was my services file's name? My file's name was gk test something, right? The file which we used, gktest.yaml. So gktest.yaml, and you can see my deployments and my services have been created. So if I try to do it again, my host should return that there is nothing of that sort there. There is nothing there because there is no such thing present anymore. You can just copy the external IP, paste it here. It will not work for you because there is nothing there anymore because we deleted the services. So we've deleted it right now. So other thing that you can do with it is probably let's create that service again, and let's go back and let's create so we can see for right now we are not seeing anything about the services and like that. It's saying you to learn more, and same goes for the ingress. And if you go for the storage also, you have not defined any persistent volume, or it shows only the storage classes which have been predefined. So you can define storage classes and you can manage them from here. So I'll show you how that works. So let's quickly clear this. Okay, so what we'll do is we'll create our services again, which was the gktest.yaml. This will create my deployment as well as my service, right? So my deployments and my services has been created. So now if I refresh this, I should see my services here. So you can see it is creating the service endpoints. It is of the type load balancer, and it is showing me different things with respect to that. So once it gets ready, so we can check it from here also. kubectl, my bad, kubectl get svc. So now we can see it is still in pending state, so we have to wait for a couple of seconds for the pending state to get over. So if we go to the services right now, we can see various different things with respect to this service. You can see it's ready now. So we can see various things related to this service, like what is the namespace it is in. Since it is, we have designed it, we have not defined any particular namespace. It is in the default namespace. It is showing the labels and load balancer external endpoints. Where is it? And what is the status of the deployment serving pods? What are the pods inside of this? You can get inside of these pods as well. In here, you can find the details with respect to the pods, what it has requested, and how the things have been so far. And you can check things from here as well. On your command line, you can check for kubectl describe pods, and you need the pod name for that. So you can get that pod name from here itself, I think. Yeah, the pod name, we'll copy it and we'll paste it here. You can see various different things with respect to this pod. Has all of the different commands that you can execute through here. You can see what is the start time, the label, the annotations which is being used, what is the status, and what are the different things that it has. And you can change various things regarding that, and you can check from the services here as well. You can if you define more services, you will see more endpoints in here, and similarly if you define an ingress, it will come in here. If we define a storage class, then we can have those storage classes in here, and we can segregate them on various standards, like what is the provisioner, what is the type of the cluster, what zone it is, and what cluster does that volume serve to. So we can check from all of the things that is here. So it is very intuitive in terms of that. And similarly, if we are looking at the workload right now, so we have one deployment which has one pod, and we can see everything it is here and here. So in here we can check the various different things with respect to our particular default the deployment details which we have in here. You can see what is the active revision and different things which is there with respect to that. And if you want to check how a self-healing perspective of the Kubernetes, what you can do is kubectl get pods. I need the name of my pod. That is the name of my pod. What if I delete that pod? So what will happen to the deployment? The deployment's job is to keep on creating new pods, right? So if I do delete pods and then provide the pod name, which is this, it will delete this particular pod. Now, if the job of the deployment was to self-heal, right? I deleted a pod, but the configuration says that I should always have one replica. So in that scenario, what it should have done is it should have remade the pod. So the pod will have a new name now, as you can see. It is different from that one, but it's the job of the particular deployment to make your replica sets be available at all points of time. If I had two replicas here, I will see two pods at all times. Even if I delete one, or if one gets deleted or restarted for some other reason, you can see that with the help of this. And you can auto scale from here. You can auto scale, as you can see. You can change the minimum replicas to, let's say, 2. Now if I do that and I auto scale, once it gets deployed, I should have two particular copies of these, right? It should have two different replicas which should be there. You can see there are two pods now. Since we auto scaled it from our Kubernetes engine, since we auto scaled it from our Kubernetes engine, to auto scale it automatically went to 2. And you can change that. You can have more actions with respect to it, and you can do auto update and different actions as well. You can do all of these. You can auto scale, you can do rolling update, you can scale, you can expose, you can do a lot of different things. With the help of that, it will automatically do for you. That is the advantage of having of that. Or you can get YAML or edit YAML. You can make some changes from there itself. You can see what the memory standard is. It's using 2.1 MBs so far, and various different status. Now I have two managed pods, and here you can see it has uploaded, and there are zero restarts still now. So that is how you can use that. And with respect to services also, you can edit the services for some if there is some YAML that you want to edit and I want to change something from in here, I can make those changes directly to my particular YAML. Or we can create an like we can go through a kubectl as well, and we can do it from there as well. And what other feature are we seeing right now is we can do port forwarding as well with respect to that. So whatever the port forwarding is, you can run it in the shell and make some changes with respect to that. And this is the external endpoint of the particular service which we've created of the type load balancer. You can see the graphs being plotted, and you can measure it for various different number of hours, like 1 hour, 6 hours, and whatever it is. You can have that detailed version of it also, and you can have various different events that have occurred, like the scaling of the pods was done, like we auto scale the pods. So you can see the successful rescale was done to 2 pods, and we change that replication as well. So you can do that also with the help of this platform. So that is the easy things that this platform provides. You can see the various things from the info panel. You can get what is meant by all of these steps, so you can learn more about it intuitively with the help of this platform, which is the Kubernetes engine. And that is about it, guys. So that is how you basically use. You can define various different things. You can manage it from here. You can scale and downscale and do various different things with it. And similarly, you can create a lot of different storage classes and have configurations of the secret, which is the default token, and you can manage various different configurations also from here itself. So that is the great thing that Kubernetes provides. So it gives the command line interface an intuitive end where you can use and see how your different things are doing. You can create graphs and stuff, and this service does everything for you, the Kubernetes engine service in the cloud platform. So that is about it, guys. You can see various different things. You can refresh and create a cluster of your own, and you can try doing different experiments with it. You can create your own images. You can check the deployments and stuff like that. So that is basically how you use Google Kubernetes Engine. Let me show you a demo on Kubernetes. So what we have done here is we have basically created our own server. We have created an own cluster. So we have a master and a node in it. Let me show you real quickly. Kubectl get nodes we can do to find out how many nodes are there. So I have one master and one slave which is ready. So we have created this configuration. So if you want to create this configuration or want to know how to do that configuration, so what we are going to do now is we are going to create a pod, and then we're gonna delete that pod and see if the pod is deleted. Then we'll create same pods with the help of a deployment and delete them and see if they are still working, and then we'll be seeing what our service looks like, and basically that will be all we are going to do in this hands-on section. So that is the agenda for this one. So let me talk about the YAML files first. So if you're creating a pod, what will your YAML look like, right? So if you are interested about finding out more on the architecture and the YAML files, if this is fairly new to you, you can ask that in the comment section as well. So there is another video on it where we have in depth gone about how to create the YAML files and stuff like that. So you can go ahead and learn there itself. So basically for now, just understand that this is how a YAML file looks like. So you can see the API version is v1 and the kind of the version is pod. There's metadata, and the name is of the pod is Intellipaat, and the name inside of the container is SISE, and the image that we are pulling is HSHAR web app. This is a Docker container which we have created previously, and the container ports have been mentioned. All right, so how do we go ahead and create that in Kubernetes? So what we're going to do is we're going to do nano pod1.yaml. We'll be creating this YAML file. So let me quickly, it's very important that you manage this particular indentation that we have given here, right? Like there is one space after two spaces after every this double dot, and one space after this hyphen, because that is how you basically define the properties inside of it. So if you are interested in that, you can ask for the video, they'll be happy to assist you. So now we're going to be creating a pod real quickly. So we're gonna paste this pod configuration. I'm gonna save it, and let me just quickly create this. So for now, just let's just check if we have any pods running right now. So we're gonna do kubectl get pods, right? And you can see there is no pods in the default namespace. Now we're gonna create our own pod. So kubectl create -f pod1.yaml, right? I'm gonna create that pod real quickly, and as you can see, the pod Intellipaat was created. So let me quickly jump on and see how that looks. Kubectl get pods. As you can see, our Intellipaat pod is running right now, right? So we can get inside of this pod, find out different details inside of it. We can use this command kubectl describe pods, and I'm gonna give the pod name, which is Intellipaat. So you can see the image that is being pulled, the container ID and the ports and the host and everything with respect to that has been mentioned here. The image is pulled successfully, and whatever is there with respect to that, if it has secret volume, everything has been detailed in detail described in this one as soon as you use the kubectl describe command, right? So this is how you create a pod. Let's see if we can delete this pod real quickly. So let's clear this screen for a while, and kubectl get pods, kubectl delete delete. We can delete the entire file itself, through which we have created, and through which that can also be deleted, right? Pod1.yaml. Let's not do that. Let's just delete this pod. Delete pods, and we're gonna get the pod name, right? And with that, you can see the pod has been deleted. So that is how it'll take a couple of seconds to finalize it, and we're gonna wait for that. And meanwhile, let me show you real quickly how the deployments. So this is the in one YAML file you can define multiple things, right? So in this one we have defined only the pod, but in this one we are creating a deployment, and this part from this pink arrow up here to this pink arrow down here, there's a deployment YAML. So this is the version we are pulling here is app/v1. You can see here there was a different version. His API version was different, and you can see that was v1. This is app.v1, so you have to take good care of that. And then there is the strategies to recreate. Then there is this name nginx, and then there is matching labels. You can have different number of replicas. I can have 2 replicas here as well, and you can have 2 replicas of the pod running. So if I were to change this one to 2 replicas, it will create basically 2 pod instances for that. And the container's name has been given here, and below it, sorry, we have a service of the type load balancer, right? We are creating it on the go itself to save a little bit of more time. So we have the nginx name and the default namespaces is there, and you can see the name and the external port, and the type of the service that we are using is load balancer. So let's quickly just copy this whole real quickly. Let's see if our pod has been deleted.
Just a quick info, guys. Test your knowledge of Kubernetes by answering this question. What can you deploy on Kubernetes? A. Containers. B. Virtual machines. C. System process. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
See, our pod has been deleted. So now what we're going to do is nano. Let's create dep.yaml. So we're going to call it deployment, and let's quickly paste it real quickly here, and everything has populated. Let's go outside. So the command for running it is kubectl create -f dep.yaml. So this has basically created a deployment for us and a service which is called nginx. So so the advantage of this is right now we'll have a kubectl get pods. So we'll be having this pod. 1 second. Yeah. So we'll be having a replica of this pod which is there, right? So you can see this one pod is there. Just keep the eye on the name, right? So it is D6TGF in the end. Now let's see what happens if I delete this pod. What will happen? So kubectl delete pods and the pod name. Click enter, and you can see the pod has been deleted. Just wait for a couple of seconds. Now what will happen if we get pods? Now according to the self-healing service of Kubernetes, we should have another pod running of the different name, right? So you can see it has created a new pod on its own, so there is no down seconds whatsoever. So you can see this pod was deleted and this copy pod was created because this is a deployment that we made. So the job of deployment is to make sure the pods are always up, right? So let's quickly see if we have created the services also. So kubectl get svc. So we have the type of the nginx service being created, but it is in the pending state. I think it is because of the slow internet and service today a little bit slower on the server's end. So let's quickly do one thing and get inside of a pod and see how that happens, right? So kubectl exec -it, and then your pod's name. We are going inside of this pod, guys. So let's see what's there inside of this pod. How does it look like? So -it, and to get inside of it, -- space bin/bash. We made a spelling mistake. Let's quickly remove that and go. So you can see we are inside of this pod now. Let's see what all is there inside of this pod. So ls, as you can see, there is different folders inside of this pod that we can go. So I am going to show you what basically Nginx, how Nginx, where the Nginx HTML file is there. So cd user, then ls again, then inside of this folder you can see all of these folders are there. So cd share, and then we're going to do another ls, and you can see a lot of different things is there. We can see the Nginx is the folder that we want to go to. Then we're going to go ls again, and you can see there's an HTML folder. So we're going to go to the HTML folder and see what is inside of it. So if we do cd and and see this HTML file. We are inside the HTML folder, right? So cd ls. So let's quickly see what is there in that index.html. As you can see, this is the HTML code inside of that service. So if we are going to create that service and in the endpoint is exposed, this is something what we'll be seeing as export. So if the service is not running right now as of now, but if it was running, we'll be seeing this one. So what you can do is you can change this code and you can call it internally the service, and you can see how that works, right? So let's quickly change this. So the way to change it is cat, and you make this and index.html. So now you can basically change whatever is written inside of that file. So we have a sample code ready here, which just says Intellipaat, and if the internet was properly working, we'd probably see that. Let's see if we can get it up and running. And I'm going to paste it real quickly, and we're going to be saving that. And let's cat it again to see if that works. As you can see, here it is, the end of the section, and we have Intellipaat. So to get out of this, just press Ctrl D. Now we are back in the kubectl. So let's see if the service is up and running. The service is still pending. So what we can do is we can curl the internal address and see what is happening. And if I curl it, I should get the above given Intellipaat thing, right? So let's quickly do that. As you can see, it gives this in the background. So that is about the hands-on, guys. So let's quickly jump back to our PP session and get ahead and find out what we can do to learn more. The first one is the most basic question. This is generally used to ease you into the conversation. So whenever you write Kubernetes in your resume and you're a beginner, for that matter, people ask you like, okay, what is your understanding of Kubernetes? Like, what do you mean? What is Kubernetes? So the good answer to this question would be Kubernetes is a container orchestrating tool that is used to automating tasks of managing, monitoring, scaling, and deploying containerized applications. Now you can have a group of containers which can be logically discovered, and majorly Kubernetes is used because when you host your applications on Kubernetes, and let's say if you're going for some updates, in that scenario you will not have a downtime. There's a feature in Kubernetes which allows you to have less or zero amount of downtime for your application. Other than that, Kubernetes has very great functionalities like self-healing capabilities, auto scaling, and different things like that, which makes it very good. When compared with other container orchestrating tools, it is very much more secure, and that's why Kubernetes is preferred in the industry. And through this question, they may ask you a few questions like, what do you mean by a container? What do you mean by a microservice? What is a monolithic service? So if you are looking for answer of these, just check them out really quickly if you don't know the answers to these questions. And from this one, let's move on to the next question. Next question is, when you mention like Kubernetes is a container orchestrating tool, so they will ask you, is Kubernetes the only container orchestrating tool, or they will ask about containers. And whenever you talk about containers, Docker is the number one container, right? Number one tool for making containers. So Docker is extensively used across almost all the organizations to create containers. Now people will ask you, why not use Docker Swarm, right? Docker Swarm can also do container orchestration, so why go for Kubernetes rather than Docker Swarm? And this is where the differences between Kubernetes and Docker Swarm kick in. So basically you should know that a Docker Swarm is a default container orchestrating tool that comes with Docker. Docker Swarm can only orchestrate simple Docker containers, and whereas if you talk about Kubernetes, you can handle much more complex software applications environments. The few things which gives Kubernetes an edge over Docker are like Docker Swarm cannot do auto scaling, whereas Kubernetes can. Kubernetes can do auto scaling for your applications. So let's say if there are certain times, let's say if you are hosting an e-commerce application, right? So there are some times of the year where you have much more traffic than the others, and whenever you're hosting some kind of sale, the traffic would be more than usual. In those scenarios, what you would require is a scaled up version of your application so that it can handle the traffic. Docker Swarm cannot deal with that, whereas Kubernetes can. So that's why people prefer Kubernetes, number one. Second, Docker Swarm doesn't have a GUI, whereas Kubernetes provides you with dashboards. Although a lot of people do prefer the dashboards, but mainly people go for something like a Prometheus or a Grafana for the monitoring, as well as they look into logs and different things like that. So it is something which is useful, but not that extensively used. But as a defense, you can give like people prefer having dashboards, and Docker Swarm doesn't provide them with one, whereas Kubernetes does. That's why people prefer Kubernetes. The third thing you can say is the Docker can deploy rolling updates but cannot deploy automatic rollbacks. So what happens is, let's say whenever you're hosting in some new version of your updated application, right? So Docker Swarm can roll your updates without it can do rolling updates for your application. But let's say the application that you hosted, the version 2.0, it was having some bugs. It was not able to work function properly. Now when you want to roll back to the previous version, Docker Swarm does not have that capability to scale you down for the automatic rollback, but Kubernetes does. Kubernetes provides you with the functionality where you can do automatic rollbacks, and that is one of the greatest features which is out there. So if your application has some kinds of problem, you can roll back really quickly, and that is something which is desired by almost every developer which is out there, right? Because writing a perfect code is important, but not always achievable. There will be bugs here and there, and in those scenarios what you would need is automatic rollbacks, right? There are few other things that you should also keep in mind when you are comparing Docker Swarm and Kubernetes. Like Docker requires third-party ELK stacks for logging and monitoring, while Kubernetes has some integrated tools as well. But I would see that whenever you mention this, just mention that although this is the case, a lot of people prefer different kinds of monitoring tools like Prometheus, Grafana, and there are a lot of different things like that. And you should tell them out that you have knowledge about this, because that gives you a little bit of the edge. Other than that, Docker Swarm can share storage volume with any container easily, whereas Kubernetes can only store storage volumes with the containers which are in the same pod. So if you have a pod which is like two different pods, they cannot share the information. But if you have two containers inside of the same pod, then they can share that volume amount. Whereas the difference between Docker Swarm is it can share the volumes between the two containers very easily. So these are the differences between Kubernetes and Docker Swarm. You can use this based on your questions, whatever the question is being asked, like which is better and whatnot. You can choose some points from here and there, and you can leverage itself and get yourself ready for that question. Let's move on to the next question, which is what is a heapster? So heapster is something which lets us do cluster monitoring, container cluster monitoring. It lets you basically do cluster wide monitoring and event data aggregation as well. So, and it has a native support for Kubernetes. Always mention that it has a native support for Kubernetes, and it is used for cluster monitoring. So this is an important questions when it comes to monitoring. We were talking about in the last one, right, that Docker has to depend on ELK, whereas Kubernetes have native supports for a lot of different things like heapster and whatnot. And that's somewhat why it is important to know about heapster. Let's move on to the next question, which is talking about a Kubernetes architecture point. What is a kubelet? So kubelet is a service agent that controls and maintains a set of pods by watching for pod specs through the Kubernetes API servers. What is a pod spec? Pod spec basically refers to pod specifications, where you tell them what the pod is all about, what is the image that it is pulling, what are the arguments to be passed, and different kinds of things with respect to what the pod should have, like the replicas and different things like that, all the specifications of the pod. So it's the job of the kubelet that controls and maintains the set of pods by looking at those specifications, and it gets that from Kubernetes API servers. It also preserves the pod lifecycle by ensuring that given set of containers are running as they should be. right? It makes sure that if, let's say, one of the containers or one of the pods is not functioning properly, it is its job to make sure that it's running properly. If it doesn't, it has to do something about it, right? Kubelet runs on each of the node which you have. So you have in the architecture, when we'll discuss sometime in the later in the questions, you have basically two different components in Kubernetes architecture. There is master components and there are node components, right? Two major ones. So in master you have different set of things running, and in the node section you have different things of set of runnings. So in each node you have a kubelet that runs, and it enables communication between the master and the slave nodes. So that is another job of kubelet. That is what a kubelet is. When you talk about kubelet, you cannot let go of the another important thing, which is what is kubectl. So kubectl is again a very important component. You basically interact with it to use it to interact it with your cluster. So kubectl is basically a Kubernetes command line tool that is used for deploying and managing applications on Kubernetes. Kubectl is useful for, inspecting the cluster resources, for creating, updating, deleting components. So basically any interactions that you do with your cluster, you do it through kubectl. And whenever you want to, let's say, know how many pods are running or which pods are running in which namespace, you want to create pods, you want to delete pods, you want to do automated updates, anything with respect to that, it is done with the help of kubectl. So you write the commands as kubectl and then get pods or create f in the file name and different things like that, right? So kubectl is the command line tool which is used for basically interacting with the cluster. So with that, let's move to the next one. What is the different services within Kubernetes? So in here you would be expected to talk about different services as well. So you have different kinds of services in here in Kubernetes. So basically we have 4 kinds of services in Kubernetes. So these 4 types of services are cluster IP service, the node port service, the external name, and the load balancer. Let's talk about all of these services really quickly. So the cluster IP service is the default type of service. Whenever you create a service and you do not give specification of what it would be, what kind of service it is, then by default it creates a cluster IP kind of service, and you can reach this kind of service only internally within the cluster. It is not exposed to the outside world. So let's say if you want to see it on your web browser, that is not going to happen because it is something which is created for internal interaction of inside of the cluster. It is not exposed outside anywhere. You cannot reach the service externally. If you want to go for externally reachable service, you have to go for some other kind of service. Then the next type of service is node port type of service. This type of service basically exposes the service on each node's IP at a static port. So you define a port, and that on that static port you can expose your services there. A cluster IP service is created automatically, and a node port service will route to it. Basically it's done like that. From outside the cluster, you can contact the node port service by using the node port IP and the port. You can use IP and then the port name. You can interact with that, right? If you want to access the node port service. Then there is a load balancer service. This kind of the service basically exposes the service externally using the load balancer of your cloud provider. So whatever the cloud provider you are using, it will use the load balancer of that cloud and it will expose the service externally. Now, external load balancer basically routes your node port and the cluster IP service, which are created automatically. That is in behind what happens. Generally speaking, when you are talking about load balancer services, you just need to mention that this is the kind of the service which exposes your service with the help taking the help of the load balancer of the cloud provider that you are using, right? That has to be mentioned, of the cloud provider that you are using. Now, the final services that we are going to be talking about is the external name service. Now, this type of service basically maps the service to the contents of the external name field. For example, www.intellipaat.example.com. It does this by returning the name of the value for CNAME record, right? So that is what these services are. So there are 4 kinds of services. If you are asked, cluster IP is the internal kind of communicating service. If you want to expose, you can use node port or load balancer service, and there is another service which you can use, which is the external names, right? So these are the 4 services. Let's move on to the next question. Now this is to ask about the how to set a static IP for Kubernetes load balancer. So Kubernetes master basically assigns a new IP address. So we can set a static IP for Kubernetes load balancer by changing the DNS records whenever the Kubernetes master assigns a new IP address. So whenever it is assigning a new IP address, you can basically change the DNS records, and with the help of that, you can set a static IP for your Kubernetes load balancer. So it is a bit of an intermediate question about asking about how to set a static IP for a load balancer. Let's move on to the next question, which is what is etcd? So again, very core question asked in about almost all of the interviews for beginner levels with respect to the architecture. Etcd is a very important component of the architecture. So etcd is basically a distributed key value store for all of the data, including the metadata, configuration data, and everything else. All of the information is there in these etcd, and it is stored as a key value pair. It allows the nodes in the cluster to read and write data, and etcd represents the state of a cluster at a specific moment in time, and it is the center for the management for cluster coordination in Kubernetes, right? So for management and the cluster coordination, etcd comes into the picture. It represents the state of the cluster at a given moment of time. It stores all of the information, including the metadata, whatever the configuration is. So whatever it is there with respect to how the cluster is looking right now, that information is stored in etcd, and it is in the form of a key value distributed form, right? So that is what etcd is. And talk about can we use many claims out of a persistent volume? Now, interesting one. So let's talk about persistent volume first. So we have various different kinds of volume mounts, right, in Kubernetes. So you can use different kinds of volumes like mtdir, or there are a lot of volumes mounts which are possible in Kubernetes that you can mount. Now the difference between these volume mounts is and the persistent volume is the simple fact that let's say we have a pod, right? So if let's say if I delete the pod, and it's a part of a deployment, so deployment keeps on respawning your pods, right? So let's say if I delete one particular pod, what happens to the information inside of it? So if it is not a persistent volume kind of volume mount, then that information will get lost. It will go somewhere. It won't respawn, right? So if you want that information to stay and persist, for that you use persistent volume. Now creating a persistent volume is different from what you create a normal volume, right? For creating a persistent volume, you need persistent volume claims. You need a storage class, and then you use the claims to mount the volume. So it is a kind of a tedious process. You have to do 2-3 different things: create a storage class, create a volume claim, and using that claim you need to mount it on your persistent volume, something like that. So the question here is asking is how can we use many claims out of a persistent volume? So the answer is the mapping between the persistent volume claim and the persistent volume is always 1-to-1. It is you cannot use many claims out of one persistent volume. The mapping is 1-to-1. Even when you delete the claim, the persistent volume still remains as we set in the volume reclaim policy, and it will not be reused by any other claim. So the answer to the question is no. The mapping is always 1-to-1, and it is not being used by any other persistent volume claims. Move on to the next. How do you deploy a feature with zero downtime in Kubernetes? Again, interesting question. So if you are deploying a new feature, how do you ensure that there is zero downtime whenever you're doing it? The answer I think we answered this question before, that this is one of the great capabilities of Kubernetes, and the answer is you can apply a rolling update. So in Kubernetes, in the strategy, while deploying your deployments, while creating the YAML file for your deployments, you mention the update strategy in there. So if you do the update strategy in your deployments as a rolling update, in that scenario, whenever you're trying to deploy a new feature, it will do a rolling update, and that will ensure that your pod does not see any kind of a downtime. How does it do that? So let's say I have 4 different pods which are running, or the 4 replicas of the same pod, right? So I have a version 1 of 4 pods. Now what I'm trying to deploy is 4 pods of the version 2. So what it will do is it will take down, let's say, a pod 1, and all the requests which are there, like let's say 4 fingers are pointing to pod 1, 2, 3, 4, like 1 pointing to 1, 1 pointing to 2, 1 pointing to 3, 1 pointing to 4. So if any request comes based on the load balancing feature, it could either go for pod 1, pod 2, pod 3, or pod 4. As they are replicas, it shouldn't matter which one it goes to, right? So it is going to there. So whenever you are applying an update, so let's say it will take one of those pod down. It will not take all of the 4 down together. It will take one of them down, and it will stop showing it as a mapping. So where it takes one down, and instead of the one, it puts a new pod, and then it takes the second one down and it puts something else. So till your update is completely done for all of the pods, it will make sure that there is no downtime, right? So it will keep on pointing to the older pods till all of your pods are replaced. And once all of the pods are replaced, it will start rerouting the request to the new version of the pods. That is how it does that when you're doing a rolling update. Okay, so let's move on to the next question. So next question is, what is the difference between a replication controller and a replica set? So the question is pretty straightforward. First and foremost, I would want to mention that the replication controllers are obsolete now, no longer used in the newer versions. It was used in the older versions when Kubernetes came out, so you should point that out. It shows that you have information about the current situation of Kubernetes. So the replication controllers are obsolete now in the latest version of Kubernetes. There's the slight difference between replication controller and replica sets, and that slight difference is called as selectors. Replication controllers do not have selectors in their specifications or spec part of the YAML, whereas replica sets do. So this spec lets you help, this selectors helps you select different kinds of services and different things like that. Replication controller does not have it, replica set does. That's it. Okay, next question. What is a kube proxy? So with proxy, you can think that this is some kind of an alias, has to be related to network. Your mind should go there instantly. So kube proxy runs on each of the nodes, and kube proxy is responsible for directing the traffic to the right container based on the IP and the port number of the incoming request. So whatever the incoming request is, so let's say the outside world doesn't know what is the architecture inside, right? So they just basically click on something and the request comes. So whatever is the request, whatever the container they are asking, like this is the request, this is the particular thing which I want to talk to. So it's the job of the kube proxy to direct traffic to the right container based on whatever the requests are, and that request is based on an port number as well as the IP address. So that is how you basically do it, and that is done through kube proxy. Let's move on to the next question, and this is what is a headless service? Now, interesting question. So this question may or may not show up depending on the kind of interview you have, because headless service is not used in many organizations, to be honest. But a headless service is very much similar to a normal service. Only the thing that it does not have is a normal service, but does not have a clustered IP. So basically, this service enables you to directly reach the pods without having to go through an proxy. So you can have directly hit it with an IP address and you directly reach the service. It does not have a cluster IP. It does not have a direct IP you can reach. You have to provide a proper IP to reach it. It doesn't go through any kind of a proxy. So that is what a headless service is. Let's move on to the next one, which is explain PVC. So we talked about persistent volumes, right? So PVC basically stands for persistent volume claims. So the earlier question that we have, like how many claims that we can use, this question is talking about what is persistent volume claims. So the full form is persistent volume claims, and it is basically the storage requested by Kubernetes for pods. It asks Kubernetes, okay, this is the volumes that I need for the storage for this particular pod, and the user does not require to know the underlying provisioning. This claim should be created in the namespace where the pod is created. So two things you have to keep in mind: wherever your pod is, in the same namespace, you have to create your particular persistent volume claim. This is the one thing, and through persistent volume claims, you basically request for storage volume. Like this storage is required here. You ask for that, and Kubernetes provides you with it. So you do that, and using claims, you can mount it in the volumes of the pod. Only thing to keep in mind: make it in the same namespace. What is a namespace? I think that question will come up later. But basically, a namespace is used to segregate your cluster into different parts, so that people who are working different teams or different geological locations can divide the resources among them, and address things in one place. So that is what a namespace is. So in one side of one namespace, you will have one particular set of things only, and if you do not define any kind of a namespace, everything that you create, let's say a pod service or anything else, it goes to the default namespace by default, right? So that is what it is. Let's move on to the next question. So now it is the interesting one. So tell us about the different components of the Kubernetes architecture. So as you can see in the picture below, the different components of the Kubernetes architecture, right? So as I mentioned before, we have two main components, which is a master components, which you can see the big box on the left hand side, and the node components, which is on the right hand side. There can be multiple nodes. Both of the nodes have the same architecture, if you can see, and different components are there. So in master, you can see there is an API server, there is a scheduler, there is a controller manager, there is kubectl, and on top of it, and there is etcd. So in the master node components, let's talk about the different components. So API server, it is the first point of contact for the entirety of all the REST commands, REST commands, which are basically used to manage and manipulate the cluster. So API server is the first point of contact for all of the REST commands, and it is basically used for managing and manipulating the cluster. Then you have the controller manager. Controller manager, it is a daemon that is responsible for regulating the cluster in Kubernetes and manage various other control loops which are non-terminating. So non-terminating control loops, as well as responsible for regulating the cluster in Kubernetes. Then there is a scheduler, which, as the name suggests, is responsible for scheduling tasks on the worker node, and it keeps the resources utilization data for each of the slayers nodes. So whenever you have a new service or new pods or everything which is spawning, it's the job of the scheduler to make sure it spawns on which node, and it does that based on the resource utilization, resource ability, and different things like that, and keeps the track of all of the resources which is used in all of the different nodes, and it takes a judgment call based on that as to which node should be given this particular task. So that is the job of the scheduler. Then you have etcd. We discussed about etcd a while back. So basically it is a distributed key value storage where you have shared configuration. It is also used for service discovery as well, and it stores all of the information about the current situation of what your cluster looks like. So that is what etcd is. And that we have some components on the worker node, which you can see. There is kubelet, there's a docker container, there is kubeproxy, and there is pods. The Docker container, and could be any other container also, in my opinion, but Docker containers are most widely used, so that's why it's mentioned Docker container. So Docker container must be initialized and run on each worker node in a cluster. Docker containers run on each and every worker node, and they also run on the pods that they are configured, right? So that is what it is. Then there is kubelet. So we discussed about kubelets. The job of the kubelet is to get the configuration of the pods from the API server. So API server has all of the details. It gets it from there, and then it ensures that whatever the containers are mentioned and whatever the specification is mentioned on the API servers, it makes sure that everything is running according to that. So that is the job of the kubelet. Then there is kubeproxy, which we also discussed. So kubeproxy behaves like a network proxy, and as well as the load balancer for a service on any single worker node, and basically it helps to direct traffic to the particular proper node, particular container which the request is coming based on the IP as well as the port number. So that is the job of kubelet. And then there are pods. A pod can be thought of the most basic execution unit of Kubernetes. It can have one or more containers which can logically run on different nodes altogether. So these are the different components of Kubernetes architecture, right? So with that, let's move on to the next question. So this is a scenario based question. If you have to pass sensitive information in your cluster, how would you do it? And by sensitive information, we generally mean, like, let's say you have username, you have password and something like that. So how do you pass that to your cluster without, making it vulnerable to any kinds of attacks? How do you do that? So Kubernetes has this very good feature called as secrets. So we can pass the sensitive information in Kubernetes using secrets. Now secrets can be created through YAML files. You can have that in your YAML defined, or you can create it through text files as well. And majority of the organizations in the world will be using secrets to pass on information. You can utilize environment variables and whatnot to bring it from here and there, manipulate it and everything like that. So you can use that in order to pass on the sensitive information with respect to your cluster. Let's move on to the next question, which is, what is a sematext Docker agent? So basically, this is something which is there present in Docker. So it is basically a log collection agent with event and metrics. It runs as a small container in each of the Docker hosts. So in each of the Docker hosts, it runs, and these agents basically are there to gather metrics, events, logs for all clusters and nodes and containers. So again, another feature which is there for storing information with respect to logs, metrics, and different events which are out there, and it is basically used for that. Let's move on to the next question. If you delete a pod which is created as a part of deployment, what happens to the information inside of it? Well, the answer to the question also we discussed earlier on. So if the volume mounts which you have used inside of the pod of any other form rather than persistent volume, then it is almost obvious that your data will get lost, right? Your data will be deleted, it will be lost somewhere if you delete the pod having information which does not have volume mounts which is persistent volume. If you want the data to be retained, then in that scenario you have to create, a storage class, make a persistent volume claim and use that claim in one of the pods as a persistent volume. Mount your information in your persistent volumes. In that scenario, what happens is, let's say if my deployment has three pods so far, has three replicas, 1, 2, 3, and it's, let's say pod 2 has the information which is required, and pod 2 gets deleted for some reason, so it will respawn a new pod. Let's say the new pod is pod 4. So now we have still 3 pods running, but the pod names are 1, 3, and 4. So in that scenario, the pod 4 which is respawned will have the information which is required, and this is coming from the persistent volume. So that is the basic idea behind it. So let's move on to the next question, which is question number 19. Is there any pattern to pods being assigned to different nodes? Can you make sure a pod gets scheduled on a particular node? So to answer this question, you can start off like the initial assignment of the pods. A pod can be assigned to any node. It depends on the scheduler where it wants to do it, and depends on the resources and the requirements. It totally depends on the scheduler. So it could, let's say if I have 6 node, if I spawn it the first time, it could be gone to the 6th node. Next time it could be pod 3rd node. It could be some another node. But let's say if there was a requirement where I wanted to run a pod, but I wanted to this pod required the services of a very good GPU, and only one of the nodes have that good GPU. So how do you make sure that the pod goes and attaches itself to that particular node? It can be done through something called as taints and tolerations. So you can add a taint to your particular pod, and you can have a particular node which can tolerate those taints. So you can add that taints and tolerations, and if you do that, the pod will not go and assign itself to any other pod. It will only go and assign itself on those nodes which can tolerate the taints. So that is the way you can basically make sure your pod goes and gets assigned to one particular node, right? So that's how you do it. Next question, which is let's say Kubernetes job should be finished in 20 seconds. So we create a job which should be finished in 20 seconds. However, sometimes it takes like 5 minutes to do it. How can I make sure to stop the application if it exceeds more than 40 seconds? So a normal job is created which has to be done in 20 seconds. Generally it gets done in 20 seconds, but due to some scenarios it takes 5 minutes. So whenever it takes 5 minutes, we have to make sure that that does not happen, and the maximum allowed time for the process to run is 40 seconds. So how do you avoid that? It is very simple. You only have to add one particular instruction in your YAML of while creating the cron job or whatever the job that you are creating. Whenever you are creating that in the YAML file, you need to provide the specification of -- active deadline seconds flag equal to whatever the number of seconds that you need. Whenever you do that, it basically relates to the duration of the job. So once it reaches the particular threshold specified by the flag, the job will be terminated. So if the condition here is 40 seconds, then -- active deadline seconds equal to 40. That's it. All you have to do is that, and it will make sure that after 40 seconds, your job gets terminated. So these were the interview question, guys.
We have come at the end of the session. Kindly subscribe and hit the bell icon for more updates.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.